Hello everyone, welcome to yet another session by Scaler, and in this particular session we're going to look into AWS Complete tutorial with interview questions. So before we move on with this particular session, make sure to subscribe to Scaler's YouTube channel so that you don't miss our upcoming videos, and also leave a like if you enjoy our content. And if you have any queries, leave it in the comment section below and we would help you out with an answer. Also, do check out Scaler events where we conduct free masterclasses which are taken by industry leading instructors, and that link is provided in the description box below. Go ahead and check it out. So now let's understand what is the agenda for today's session. We'll start off with cloud computing basics so that we can understand what is cloud computing before moving on to AWS, because AWS is the cloud technology which is currently the leading cloud provider in the world, and that is why learning AWS is really important. Once that is done, we'll look into the introduction to AWS, understand what it is. Moving further, we'll be looking into individual services in AWS. Let me list down the services which we'll be covering in this session. We'll be starting off with EC2, VPC, Elastic Load Balancing, CloudWatch, Beanstalk, and Auto Scaling. So these are the services which we'll be covering, and also I'll show a hands-on demonstration so you guys also can practice it by yourself. Once that is done, we'll be looking into AWS interview questions which could help you in another interview which you're going to attend very soon. So now that we understood what will be covered in the session, let's begin with the first topic, which is cloud computing basics. So what is cloud computing? So cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. So to put it even simply, so it's basically getting resources, especially IT resources, over the internet, and you only pay for what you have used. For example, a very simple one, which is Google Drive, you're going to pay per GB, you're going to pay for the storage. You're not paying for the application itself. You're not paying for the code itself. You're only paying for the storage you're using up. You're not paying for the application. So basically you're paying for what you are using, and that is one form of cloud services. So we'll be looking into the different types of cloud services. I'm just giving you an example of one type of cloud service, but essentially the IT companies started using cloud services which help them scale up and scale down, which helps them to host their applications, which helps them to deploy complete data pipelines on the cloud without any hassle. So those are infrastructure services. Again, we'll be getting to that, but these are some of the examples, and the IT industry was revolutionized once the cloud providers came out. Okay, so also instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases. So basically, instead of the companies buying data centers and setting up a complete physical data center by buying all the hardware, hiring professionals, hiring security and network professionals, which will obviously cost a lot, they don't have to put in any capital. They just have to select the cloud vendor they are going to use and directly use the services they are going to provide. So if you look at this image, so you can see cloud computing. So using a cloud computing provider, like let's say AWS or Azure, they provide you services such as networking services, and they provide you software applications, security services, data storage, BI services. So you can also basically deploy your BI applications, your software applications on the cloud, and you can basically have one central portal from where you can access all of this. So that's exactly what cloud computing is providing to you. All right. So on-premises versus cloud computing. So on-premises is more of the thing which we are talking about, that is a company's own data center. They have their own data center where they have their own physical hardware, where they have to set up and configure everything. They have to hire professionals in order to basically maintain and upgrade them every single day. So for that, if you can see to the left side of this particular image, so customization and implementation, the hardware, the IT personnel who are required, the maintenance, the training for new personnel who are coming in, and so basically the ongoing costs are a lot. For example, when there is a downtime, let's say when your data center goes down, when there is a power outage, rewriting integrations, customizations. If there are applications which are dependent on other dependencies, then in that case, you'll have to upgrade them every single time when the dependency is also updated. And then the maintaining of hardware, whenever a new set of hardware comes out, you have to upgrade and maintain your network and your security so that there is no breaches, so that there are no unauthorized person who are trying to get into your data center. And basically it will cost a lot. So these are the ongoing costs in an on-premise data center. But when it comes to cloud computing, so ongoing costs are the subscription fee. Okay, so basically you put in the money on the subscription fee because everything is already set up by the cloud service provided for you, and you just have to pay the subscription fee to use it. And the implementation, customization, and training. So basically you'll have to train your employees on the cloud service, or they should be already trained in it before you hire them. There are certifications which we can take and get accustomed to that particular cloud provider. And then implementation and customization is again will be done by those cloud professionals. So to put it very simply, cloud computing is a lot cheaper than setting up a complete data center, because obviously you have to do a lot of work and also put in a lot of capital investment upfront. In cloud, there is no upfront cost. You just pay the subscription fee and you pay as you go. That is, every single month you pay it as a bill. All right. The top cloud service providers. So we were talking about cloud computing service providers, right? The subscription fee. So the top three ones are AWS, Azure, and GCP. So AWS is owned by Amazon. They started in 2006. They started off with two services, EC2 and S3, and they basically changed the way IT companies started using servers. And then came Azure in 2010. Google Cloud launched in 2011. So, and then these guys have been at the forefront of cloud advancements, and they are the top three cloud providers in the world even at the moment. Okay, so the next thing we're going to look into is the cloud deployment models and the cloud different types of cloud services. So the three models are basically public cloud, private cloud, and hybrid cloud. So the public cloud, these basically are owned and operated by a third-party service provider while delivering their computing resources like servers and storage over the internet. So public cloud, to be very simple, so these three are all public clouds. So they are a third-party cloud vendor who provide you resources over the internet, which you are accessing it through the portal, and you're going to pay them at the end of the month for whatever services you have used. So these are public cloud service providers. Also, private cloud also can be given by AWS or Azure or Google Cloud. But again, a private cloud is basically cloud computing resources used exclusively by a single business. When it comes to public cloud, let's say there is a data center. That data center, let's say there are 100 customers, and 100 customers are using this particular cloud provider. So that data center will have the servers, the storage, the other services of all those customers running in that one data center. So it's not exclusive for one particular customer, but so other customers can't access the resources, even though in one physical hardware there can be many servers running which can be of various customers. But when it comes to private cloud, you will be provided dedicated hardware. Even though it's not your hardware, you are renting it, but you will be provided dedicated hardware. Let's say you have been dedicated 10 servers. So in those 10 servers, only your company's servers and your company's resources can run. Also, a private cloud can be physically located on the company's on-site data center. Also, one more thing, in this case, a private cloud can also be set up by a public cloud provider like AWS or Azure. You can also basically purchase a private cloud subscription from them, which will give you basically a dedicated hardware, and nobody else can basically run their resources on those particular set of hardwares. It will be exclusively given to your business. And finally comes the hybrid cloud. Hybrid clouds combine the power of the public and the private clouds, bound together by technologies that allows data and applications to be shared between them. This is again pretty simple. Let's say your company wants to have an application. So the application's front end, the mission critical data, not the mission critical data, and then mission critical code. So they just want to put the front end of the application in the cloud, in the public cloud, which is internet facing. People should be able to see your website, right? And then they want to put the database, which is the data, mission critical data, and the code, which is really essential for the application to work, in their own on-premises data center, that is their private cloud, so that the data is not stolen or their code is not stolen. Okay, so now the public cloud has the front end running and the private cloud has the back end and the database running. So in this case, there should be a connection between these two. So normally, if you want to make those connections, if you're separately using a public and a private cloud, you will have to use a VPN tunneling, or create a peering network. So that will take some time. Instead, you can just use a hybrid cloud model, which will combine the power of both, so that you can keep whatever you want in the public cloud, and very mission critical and sensitive data and information can be kept in the on-premises data center. And many companies also use this particular cloud computing model, which is really essential. Okay, so these are the three different types of models, guys. Now let's move on to the next topic, which is the cloud computing services, the different types of cloud computing services. So software as a service, platform as a service, and infrastructure as a service. So software as a service, I already gave you an example at the beginning, which is Google Drive. So Gmail, Google Drive, all of these are software as a service. You may ask why? Because they are providing you a software over the internet. You're not doing anything, right? You're not going to code that application. You're provided the software over the internet. You're able to use the software over the internet using any device. And that application's code can be running on any remote server. That application's data can be stored on any remote server. The software is running on a remote server and you are getting that software. It's not running on your local desktop. So Gmail, if you open mail.google.com, it opens up the Gmail website, the Gmail application. So you do not know where that particular thing is running, but you're given that application, you're given that software as a service so that you can use it over the internet. So that's basically software as a service. Next comes platform as a service. In this case, application development and deployment. So basically platform as a service, they'll give you a platform in which you can, let's say there is a platform called Elastic Beanstalk in AWS, where you can upload your code and it'll automatically host the website for you. For example, let's say you have a Python application and you want to host that Python application. So in this case, if it is a regular one, then you'll have to launch a server, and then in the server you'll have to install all the softwares and upload all the dependencies, and then deploy your application in that particular server to make it run. But if you do not want to do that, if you just want to concentrate on the code and you want to make your application better and secure enough, and you do not want to worry about the server and the infrastructure part, in that case you can go with a platform as a service, in which case basically you just select the platform, for example Python, and then upload your code and it will automatically host your website and deploy your complete application for you, and you don't have to do anything else. You just have to concentrate on the code and make sure it is compatible with the platform you're uploading or deploying it to. Okay. Next comes infrastructure as a service. So in this case, servers, storage, operating systems, database engines, any kind of infrastructure you're getting over the internet is infrastructure as a service. For example, you can launch a server and you can start basically upgrading your server. You can start installing whatever software you want in that particular server. You can basically use it like your own computer, and then you can basically terminate it whenever you want to. It's not like once you start a server, it should be running for a certain period of time. You cannot terminate or delete it. It's not that case. Let's say you want to use the server just for 3 minutes, you can do that over the cloud provider. So the main difference between a platform as a service and the infrastructure as a service is the control you get over what you're going to do. In platform as a service, you only get the control over the application which you are building. You're just deploying the code, and the cloud provider will make sure to launch a server and host your application inside of it. You're not going to be given access to the operating system level. But when it comes to infrastructure as a service, you will be given software and operating system level control so that you can install and upgrade your server according to your needs. It's more of, you can configure it more. If you just want to host your application, in that case, go with a platform as a service. If you want to configure your server in order to make sure that every single part of your application is working and it's properly deployed, then you can go with an infrastructure as a service method. But it's not just servers, even storage. For example, there is something called S3 in AWS, there is blob storage in Azure. So all of these are infrastructure as a services, where you're given storage over the internet, where you're given servers over the internet, where you're given database engines over the internet. Okay, so these three are the main services. These three are the main cloud computing services. And so at the beginning, learning these three are more than enough. All right. Okay, so to give you more understanding about these services, I'll just brief about these on this particular image. So on-premises is completely managed by you. So every single part, every single aspect of the on-premises data center is managed by the company itself. So the applications which you are deploying on it, the runtime, the middleware, the operating system, the virtualization of the servers, the storage and networking, everything is managed by the on-premises, the company. Okay, and then there is infrastructure as a service. So in this case, if you see over here, the applications, the data, the runtime, the middleware, and the operating system is managed by you. Okay, so because you are creating the application and you are uploading the application, and the data which the application generates, and the runtime, for example, the runtime is basically, let's say you create a server and you are installing Python inside of it, and so that you can deploy your Python application. So it's a Python runtime, so that is maintained by you. You can upgrade it or downgrade it according to your need. The middleware is what makes the application run, the middleware, the logic, and the softwares you're using for it. And the operating system, it could be Windows, it could be Linux, it could be any Linux distribution, or it could be Mac. So all of this would be managed by you. And the virtualization, the deployment and provisioning of servers, the provisioning of storage, the management of networks, everything will be managed by the cloud vendor, AWS, Azure, or GCP, whoever you're using. Coming to platform as a service, so everything except the application and the data is managed by the vendor. As I told you while explaining in the previous slide, it basically makes sure that it creates the servers, it creates the runtime, everything for you, and it is already set up, and your application will be directly deployed into the existing setup which it created for you. So everything else is managed by the vendor except the application you've created and the data generated by the application. And finally, software as a service, as I told you, let's say Gmail, you don't own anything, everything is managed by the vendor, you don't have to manage anything, you just use the application. So that is software as a service. All right, so now moving on to the next topic, which is benefits and use cases. So first, let's just understand the benefits of cloud computing. So we've seen the cloud computing models, we've seen the cloud computing services. From that, you could understand what kinds of benefits cloud computing provides. So to just summarize and brief that, I've created this slide. So first of all, reduced IT costs. So the first thing any company wants to do is basically try to reduce their operations and IT costs, right? So that's exactly why they are trying to shift from an on-premises data center to cloud computing, so that they could cut costs and make it even more profitable. So in this case, they could easily reduce IT costs because their on-premises data center, they have to pay for the IT and the networking and the security professionals. They have to pay for the hardware. Let's say if some hardware is broken, they have to maintain and repair it, they have to upgrade it, and they have to pay for that. So there are so many hidden costs as well in running a data center. If there is a downtime for 1 hour in the data center, that will again cost them. So all of this will eventually lead to very high operation costs. But when it comes to cloud computing, you're not doing any of that. You're only paying the subscription fee, and everything else is managed by the cloud provider for you, which will significantly reduce the IT costs. You'll only have to pay for the services and the resources you're using on the cloud provider. All right. Next comes scalability. So this is really important. When it's an on-premises data center, let's say you have 1,000 users, and your application could handle 1,000 users at a time, and let's say your application has 10 servers in your on-premises data center. So now let's say each server can handle 100 users. So in this case, your application could handle 1,000 users, and let's say your application has become viral overnight and there are 10,000 users using your application right now. So in that case, if you have only 10 servers running, it cannot accommodate all the 10,000 users. It could accommodate only the 1,000 users, which will be a significant loss for you. So in this case, if it is an on-premise data center and if you only have 10 servers running or 10 servers available at the moment, you cannot do anything else. You can basically buy more servers and configure it and upgrade it and set it up. But again, that will take a lot of time, and that will also you'll have to put in a lot of capital to do that. But when it comes to cloud computing, let's say 10 servers are running, you can set up a policy which will check the traffic, which will check the CPU utilization of these servers. If they are utilized completely, it will automatically launch more servers in order to accommodate the incoming users. So let's say there are 10,000 users, and so 1,000 users can be handled using 10 servers. So now there would be 90 more servers created so that it could handle the incoming 10,000 users at that particular point of time. So let's say after some time, it's basically after midnight and people are logging out of your application. So now there are 5,000 users, there are not 10,000 users. When it, again, in cloud computing, so it will automatically notice the reduction in the CPU utilization in the servers, and it will automatically reduce 100 servers into 50 servers, which could handle 5,000 users. Okay, I think I'm pretty clear in the scalability part. You can scale the number of servers up or down according to the needs. You don't have to basically have to keep running certain number of servers all the time, which will cost you more. You can cost optimize your servers using basically scaling options. And in global infrastructure, let's say you have your application in India and you want to globally make it available. Let's say you have a customer base in US as well. If it is not in on-premise, then you will have to get a space in US and you will have to set up the complete data center all over again. But if it is cloud, they have an established global network all around the world, and you just have to deploy your application. You'll just have to duplicate your application into the US data centers, and that is more than enough for you to make sure the application is going to be available for your US customer base. And then up to date. So up to date is basically, again, they make sure it's updated, the hardware, the software, everything is updated. And one more point in up to date is that, so whenever there is a new groundbreaking AI application or an ML application is available on the so basically when it's coming out, so the first people who are going to adapt it are the cloud service providers, because they want to provide the latest innovations to the customers, basically either to retain them and to show them that they are constantly improving, because that will help their business model. So whenever there is a new technological advancement coming in, the cloud providers are going to adapt it and going to provide it to you. So you don't have to do any other work. They'll already create a service for you and provide it to you. You'll just have to use it. And then finally, reliable data backup and disaster recovery. They already have failovers set up in cloud service providers. You will just have to use those data backup services. You'll just have to use those disaster recovery services in order to make sure your application is running all the time without any crash. So that is, let's say your application is running in one data center, and let's say there is a power outage in that complete area. So if you've not duplicated it into another data center, in that case, your application will be down until the data center comes back up. But if you have a disaster recovery failover set up and you have a standby application running in another data center, so whenever one data center fails and your application is not running in that, the standby application will automatically start running, and the incoming customers will be redirected to the application which is running on that particular data center, which is a different one. All right. So this can be done very easily using cloud computing. So these are some of the benefits. There are even more benefits in cloud computing. And then some use cases, big data analytics, video streaming platforms, for example, YouTube. So YouTube is one big example of cloud computing. And then also Netflix. So Netflix entire architecture. So Netflix went all in AWS. That basically means everything they use, that is the storage, that's the servers, the database engines, the data warehousing tools, the analytical tools, everything is running on AWS. Netflix completely went on AWS, and you can know how fast Netflix is if you have used it. And Netflix is also pretty lightweight, and also it is the biggest video streaming platform in the world, the premium video streaming platform. YouTube is the biggest video streaming platform, but with a premium, there is a paid streaming platform. Netflix is the biggest one. And in this case, they went all in AWS, and you can basically shows how big cloud computing is and how major impacts it's going to make in the upcoming future. And then disaster recovery, we already discussed it. Serverless computing. So you don't have to worry about the servers. You can just upload your code and deploy your applications without even having to provision servers by yourself. Again, we discussed it in platform as a service. And then AI and ML as a service. So this is one important thing which right now it is making strides in the IT industry. So cloud providers already have this ML ops setup. So ML ops is basically machine learning and operations, where you can create a complete machine learning pipeline using the cloud itself. You don't have to set up anything specifically. You can use the inbuilt services in cloud. For example, if you talk about Azure, there is a service called Azure Machine Learning, which will help you set up a complete machine learning operations pipeline and again, when it comes to AWS, even they have EMR, they have code pipeline, they have their own operations and DevOps setup, which you can use directly in order to deploy your machine learning or artificial intelligence models onto the cloud computing providers. Okay, so again, these are some of the use cases. The cloud computing is used in so many different industries, and these are some of the examples which I'm giving you because these are some major industries, and these are some of the major use cases which cloud computing is used for right now. And finally, we're going to look into the future of cloud computing. Okay, first of all, I just wanted to give you a brief about edge computing, which is going to be the future of cloud computing. So it's not cloud. Edge computing is not cloud, but edge computing is like a local cloud computing network. So over here in this image, you can see cloud. We already explained over here. So this is the cloud part. So let's say this is AWS. This is the cloud computing provider. And then there comes edge. So edge nodes. So let me put it very simple here. For example, let's say you have a supermarket, and the supermarket every day it's generating 1 terabyte of data, and you want to analyze that data. So let's say you want to analyze it every single day. You want the analysis to be done every single day. In that case, when the data is generated, you're going to upload it into cloud, and then it's going to be analyzed in the cloud, and that analyzed data is going to be sent back to the local data center, the small data center which you'll be having in the store itself in the supermarket, and then you'll be using it to further analysis, right? But what if you can analyze the generated data right there in your location itself? So that basically is edge computing. You can set up a smaller analyzing system, so basically a smaller node in your local supermarket itself, which will basically speed up the process of analyzing. So as soon as your data is generated, you can basically analyze it in your own edge node, and that analyzed data would be right there in your own supermarket. So you don't have to upload or download or wait for it uploading or downloading, because obviously terabytes of data will take some time to upload, right? And yeah, so that could be done using edge computing. So service delivery, computing offload, IoT management, storage and caching. So it'll be much faster than cloud computing. So edge computing is already being implemented in various places. Even the major cloud providers like AWS, Azure, they are setting up local edge locations, and they are trying to make sure the data retrieval and the transfer of data and the services, basically it's much faster than it being on cloud. Okay, so they're already investing into it. So edge computing would be the next big thing after cloud. Okay, so the final thing is that the size of the cloud computing market. So this is according to Statista, and according to them, $146 billion is the size of the cloud computing market right now, and it is always in the increase. So it would be around $320 billion by 2025. So the size of the cloud computing market will never stop. It's going to be increasing until and unless every single company has moved to cloud, and companies are willing to move to cloud. And according to Gartner, 75% of the companies they surveyed have told that they have a cloud first approach. That is, they want to shift completely into cloud as soon as possible. So this is according to Gartner reports. Okay, and then 10.6 zettabytes cloud data center traffic. So again, so this shows that how much data has been uploaded to cloud, how much data is being analyzed in cloud. So the volume of data is going to show how big of an industry is. And if 10.6 zettabytes of data is in the global cloud data center traffic, that basically shows how massive cloud computing has grown since the first major cloud provider AWS has launched in 2006. And then 17% increased demand for public cloud services. So again, as I told you, every single company is using cloud right now, and the increase is not anything new. It is increasing every single quarter in every single year. So that is every single year, if you compare the previous quarter, there is a significant rise, about 30% every single time in the spending in public cloud services. So this is nothing new. So basically, this is the future of cloud computing, guys. So if you are looking to learn cloud computing, this would be the right time to go for it. So you can choose any cloud provider, but AWS, Azure, and GCP are the top 3 cloud providers. After that, there is IBM Cloud, there is Ali Cloud. There are so many other cloud providers which are available, which you can choose from and start learning from. And yeah, so these 3 are the major ones. So I hope I've provided you all the basic fundamentals and all the basic information about cloud computing, where it is being used, the future of cloud computing, what are the different types of cloud computing models and services. So that's it for this particular video. Guys. I hope you all like this video, and make sure to subscribe, like, and also share the video if you really liked it. And also leave a comment down below if you have any queries, and we would be addressing them all. So thank you. So let's start with what is Amazon EC2. So Amazon Elastic Compute Cloud provides scalable computing capacity in the Amazon Web Services Cloud. So using EC2 eliminates your need to invest in hardware upfront so you can develop and deploy applications faster. So to put it very simply, EC2 is a service which provides you servers. So you can basically create or any kind of server you want on the AWS cloud and start using it whenever you want to. So basically you don't have to wait for someone to buy hardware. So basically provide an upfront cost or put in a lot of capital, buy a lot of physical hardware, set up your servers, configure it, and then deploy your applications inside of them. Instead, if you're going with AWS cloud, in this case, they provide you the service called EC2. So EC2 is the service which can provide you the means to basically deploy your applications faster than how you used to do normally in an on-premise setup. So when it comes to EC2, you can basically create a Linux machine, a Windows machine, a Mac machine. So any operating system you want to, you can choose the RAM, you can choose the storage you want for that particular server. If you want 10 servers of the same configuration, you can get the same thing. If you need 100 servers, if you need 10,000 servers, AWS Cloud can scale up and down according to your needs. That's why it is called the Elastic Compute Cloud. So basically you can increase the compute power, decrease the compute power. You can increase the number of servers and decrease the number of servers according to your needs. And you can basically do it whenever you want and wherever you want. You don't need any high configuration machines. So you can use any laptop with just an internet connection, because every process is happening in the AWS infrastructure, in the AWS data center. You just need a proper system with internet. That's more than enough to access EC2 or any AWS service for that matter. So why we are going with EC2 first is because EC2 is the most integral service in AWS, and without EC2, a lot of other services would not work. For example, if you take Elastic Beanstalk, Beanstalk is a platform as a service where you can upload your code by choosing the runtime. Let's say I have a PHP application. I can choose PHP, upload my PHP application's code, and it will automatically provision servers in the backend for me, and it will automatically host my application. So, but in this case, the thing is, to host the application, you would need a server in the backend. So Elastic Beanstalk automatically provisions the server, but that server is basically an EC2 server. You're not provisioning it, but yet it is launched in EC2. So Elastic Beanstalk would not work if there is no EC2. So like that, there are many other services which needs EC2 to function in AWS. Also, in Amazon EC2 provides scalable computing cloud in the Amazon Web Services Cloud. So this is what I'm saying right now. Using Amazon EC2 eliminates your need to invest in hardware upfront. So Amazon EC2 enables you to scale up or down to handle changes in requirements or spikes in popularity, reducing your need to forecast traffic. So basically, when you're using EC2, you can create a scaling policy which will automatically look into the traffic, the CPU utilization of the servers. So let's say you have 10 servers, and right now there are 1,000 users using your application. So now, to handle each 100 servers, you need one server. So basically, there are 1,000 users. You have 10 servers handling 1,000 users. So that basically means, let's say by average, one server can handle 100 users at a time. So let's say your application becomes an overnight hit, and now there are around 10,000 users. So in this case, obviously you would need more servers to accommodate 10,000 users, right? For example, to handle 1,000 users, you needed 10 servers. So to handle 10,000 users, you would need 100 servers. So now Amazon EC2, if you set up a scaling policy according to the CPU utilization, if all these servers have already been utilized, the 10 servers, then it will automatically create more servers to accommodate the incoming traffic. So same thing, let's say then it reduces to 5,000 users. So now if there are 100 servers running for 5,000 users, that would be a waste of compute power, and also would be a waste of your cost. You are basically buying these servers, right? You are basically paying for whenever the servers are running. So you would be paying extra. So if there are 5,000 users, EC2 automatically will figure out and reduce the number of servers accordingly. So instead of 100 servers, it would make it 50 servers. So now you only pay for 50 servers for that particular period of usage. Let's say for 1 hour, 100 servers have run. So for that 1 hour, you would be paying the cost for the 100 servers. And let's say the next hour, the user traffic has reduced, now 5,000 users. For the next hour, there are only 50 servers. So the next hour, you are only going to pay for the 50 servers which is being used. Then let's say it's after 1 or 2 a.m. the user base has reduced because most people will be asleep. So let's say it is back to like 50 users. And in this case, let's say you need only 5 servers. So in that case, if there are only 5 servers running in that particular period of time, let's say for 3 hours, only 5 servers were running. So that 3 hours cost would be the total of those 5 servers cost only. There won't be anything else or extra cost added to it. So this is how you can cost optimize, and this is how you can scale using EC2. All right. So this is basically EC2. It's an infrastructure as a service. So now in EC2, the virtual computing servers. So the servers are called instances. So I'm going to use the word instance hereafter whenever I want to mention a server, a virtual computing server in EC2. So if I say instance, that basically means a virtual computing server which is running on EC2. Okay. And okay, so now instances, let's keep them aside. Next, coming to the next important concept in EC2, which is an Amazon mission image. So it's called an AMI. So it is the template that contains software configuration, for example, the operating system, an application server, the application, so whatever it is. So basically it contains the entire software configuration for your instance. From an AMI, you launch an instance, which is a copy of the AMI running as a virtual server in the cloud. So to put it very simply, let's say you are creating a virtual machine in your local system using, let's say, Oracle VirtualBox or VMware workstation. So in that case, you will be using a ISO file. So the ISO file will have all the necessary configuration, the necessary data in order to create that particular server, right, in your local system. Create that particular virtual machine in your local system. If it's an Ubuntu system, it would have the Ubuntu configuration. It will have the Ubuntu complete setup inside of it, so that you can create the virtual machine in your local system. So same way, the AMI consists of the configuration which is required to create that particular server or that particular instance which has that operating system, that server, or the applications which are meant to be in that particular instance. Okay, so now again, you would understand this concept even better when I show you the demo. Right now I'm just trying to give you a simple understanding of what exactly we're going to do. So if you look at the image, it will give you an even better understanding. So now coming to the next point, the root device for your instance contains the image used to boot the instance. The root device is either an Amazon Elastic Block Store volume or an instance store volume. So this is basically the root storage for instance. So it could be Amazon EBS, which is a volume, or it could be an instance store volume. So instance store volume is created with the instance itself. Amazon EBS is a separate storage tool, okay, in AWS. So now looking at the image, you can see AMI over here, right? So this is the AMI. So now using the AMI, you can create one instance, or you can create multiple instances with the same configuration. So let's say you have a web server, and the web server has a website running inside of it. So now you can launch one instance, and it doesn't have to be that you'll have to launch every time individually. So let's say this particular AMI consists of an Ubuntu operating system which has a simple application running inside of it. Let's say it's a static website, and let's say it's just a hello world website. Okay, so now you want this hello world website to be running in 10 instances. So using this AMI, you can launch 10 instances at one single go. You don't have to basically create each and every instance and basically then log into it, then set up the entire configuration, then upload the file and do all of that. You don't have to do that. You'll just have to launch instances, and you'll have to set up the entire thing completely. You can do that with just a single AMI, All right. Okay, so when you launch an instance, so this is complete. Now coming to the next point. So when you're launching an instance, you should choose something called the instance type. So the instance type that you specify determines the hardware of the host computer. So each instance type offers a different compute, memory, and storage capabilities and is grouped in an instance family based on these capabilities. Amazon EC2 provides each instance with a consistent and predictable amount of CPU capacity regardless of its underlying hardware. So what they are trying to say here is, so there are so many different instance types and you can choose any one of them. And if you need a high performance instance, you would need to choose an instance according to that. If you need a simple general purpose instance, you can choose according to that. But one more point which Amazon is telling, that Amazon EC2 provides each instance with consistent and predictable amount of CPU capacity. So whatever you choose, that will exactly be given to you. It will be provided consistently and predictably, so that whatever your underlying hardware is, the capacity you choose will always be provided to you. So this particular thing is this site. Over here, you can see there are the different types of instances. So these are the instance types. So general purpose, so these are the instance various kinds of instance types: general purpose instances, compute optimized, memory optimized, storage optimized. Okay, so now these are the available instance types. The complete list is provided here. You can just have a go through if you want to know what kinds of instances these are. And then previous generations. So these are the naming conventions, guys. For example, there is C3.large. If you want to know what that is, everything would be provided in this particular section. Okay. So I just wanted to show one thing to you guys before moving on to the next slide. So all of this information would be provided while you're creating an instance as well. Yeah. So if you want to know more about the general purpose instances, you can go over here. And then there is compute optimized. So the compute optimized instances are ideal for compute bound applications that benefit from high performance processors. So if you have an application which requires a high performance processor, then go with a compute optimized instance. If you are just doing it for a regular application, go with general purpose. Or if you're doing it for practice, go with general purpose. Memory optimized instances are designed to deliver fast performance for workloads that process large data sets in memory. So if you have a machine learning model which needs to process a large data set in memory, not by storing it in the disk, but in memory, in that case, you should take up the memory optimized, which will give you a much bigger memory compared to the storage. Okay. And then finally, there is storage optimized. Storage optimized instances are designed for workloads that require high sequential read and write access to very large datasets on local storage. So the previous one, memory optimized, they are basically running it on memory itself. They are analyzing the dataset in memory itself. But if you have the data stored in a local storage, and if you want high read and write output, so if you want high speed read and write access, in that case you should go with a storage optimized instance. Okay, so if you want to know more about these instance types, you can go ahead and look into this particular documentation. So now I'm just going to go ahead with the PPT so that we could move on from the theory, and then I'll show you the demo, because theoretical, yes, it would teach you something, but then if you see the same thing practically, that would give you an even better understanding of what is going on. All right, and then okay, so now let's say we learned the basics about Amazon EC2. We learned what is an instance, what is an AMI, what are the instance types. So, and one more thing we'll be learning, which is the storage. That would be the next slide. So now these three are required. So let's say now we are launching an instance. Let's say this is a Ubuntu AMI. I'm launching an Ubuntu instance. And an Amazon EC2 instance transitions through different states from the moment you launch it through its termination. So what they're telling is that once you launch, it will start from a pending state, then it will have so many different states, and finally it will come to one particular state. And then once you are trying to do certain actions, the states will keep on varying. Okay, so now let's look into it. So I'm launching an instance. So the first state would be pending. So it would be in pending, and it would basically be launching this instance in the Amazon data center. So once it's launched, it will give us the required details like the public IP address, the private IP address, the DNS name. So all of that will be provided. So once that is done, it will do a status check. whether the instance is running or not. Once it is done, it will give us this particular state. It will be in a running state. So when it's in a running state, that basically means we can start working on the instance. We can log in into the instance and we can start working on it. And then if I reboot the instance, then it will be in rebooting state and again it will start running. And then if I stop the instance, so there are two major things, stop and terminate. If you stop the instance, that basically means you're just stopping the instance. You can restart it. It's like putting your system on sleep or shutting down your instance, and you can basically restart your instance and start using it. It's just stop. Okay, so if you stop it, you can start it again and it will go back to the pending state and running state again. So that's basically stop. But if you terminate the instance, what happens is it basically shuts down this instance. Once it shuts down, it deletes the instance from the Amazon data center. It basically deletes the data, or it deletes the virtual machine altogether from the Amazon data center. Stop will basically keep your server right there. It will keep your instance in Amazon data center and you can basically restart it again. But termination is completely terminating the instance. So these are the various states which an EC2 instance goes through. Okay, so the final slide we're going to look into is about the storage, because we already know about the instance. What is an instance? What is an instance type? What is an AMI? So, and one more thing we need to know before starting off with this demo is basically the storage, because when you are launching a server, that the server would need a storage in where the configuration files are stored for the operating system, right? Let's say I'm launching an Ubuntu instance. Obviously, the Ubuntu instance should be stored somewhere. So the data of the Ubuntu instance would be stored somewhere, right? So for that, we need storage. So there are different kinds of storage in which you can do that, which you can store in Amazon Web Services. So these are some of them, and that's what we're going to see. So Amazon EC2 provides you with a flexible, cost-effective, and easy to use data storage options for your instances. So each option has a unique combination of performance, durability. These storage options can be used independently or in combination to suit your requirements. So basically what they're saying is they provide you flexible, cost-effective options in terms of storage for your EC2 instances. So over here from the image you can see, so this is one instance, this is another instance. So let me just give you a brief about these different types of storage. So the first one is Amazon EFS. So Amazon EFS is elastic file storage. Okay, so basically EFS provides you shared storage, so you can have one storage and you can attach it to multiple instances. For example, let's say there is a very large data set and you want to share it with hundreds of servers, but that basically if you upload it to each server, that will obviously take a big chunk of the storage in each server. So instead of doing that, you can have a shared storage where you can create an Amazon EFS, and that shared storage could be connected to all of those instances. So every instance can see this exact same data set and basically import it or start using it. Okay, so that is EFS. So now then comes in the host computer section, you can see there is something called the mfril storage. So mfril storage is basically like RAM. So it only exists in the time of the instance is running. So let's say I launch an instance and the instance is running for 10 minutes. So in that particular period of time, let's say I'm doing some operations in the memory, so there will be data stored in the mfril storage. Okay, so now if data is stored in the mfril storage, so in that case, let's say I'm stopping the instance. If I stop the instance, that data won't be available because I've stopped the instance and the data in the memory would be erased. So that basically is mfril storage. And yeah, so this is the instance store. So this would be stored within the instance itself. And then finally comes Amazon EBS. So it's called the elastic block storage. Okay, so elastic block storage is basically the main storage type used in EC2 instances to basically connect. For example, when you launch an EC2 instance, you can choose to take an EBS volume. So when you choose to take an EBS volume, that basically will create an EBS volume, which is another AWS service, and that could be attached to an EC2 instance. And let's say you're launching an Ubuntu instance, the configuration files, the setup files, all the data files, everything will be stored in that EBS volume. Okay, and that EBS volume is exclusive to that particular EC2 instance. So there is a new feature, multi-attach EBS. You can create an EBS volume which can attach to multiple instances. But in this case, you will have to create a EBS volume, which is a different type of EBS volume. And also it will not attach to all types of EC2 instances. You will have to create something called a Nitro based instance, which is a much bigger and a much expensive instance. So normally to practice, I would not suggest to go with multi-attach EBS volumes. The normal ones are more than enough. That is normally attaching an EBS volume to an instance. So one more thing is that you can attach multiple EBS volumes to one instance. So let's say I have a laptop and the laptop storage is 1 TB. So I'm almost done with my 1 TB. I need more storage. So I can either buy a new laptop which has 1 TB more storage, or I can basically buy an external storage, okay, and attach it to my laptop and use that to store my data. So like that in EC2, you can create another EBS volume and attach it to the same instance and also mount it and use it like normally. So you can use the EBS volume normally. So yeah, so this is another storage. And finally, there is one more, which is Amazon S3. So we're going to learn about S3 in another tutorial, but right now I'm just going to give you a very brief. So let's say you want to basically terminate the instance, but you want to basically keep the configuration of the instance available in EC2 in AWS, so that the next time you want to launch the instance with the same configuration, same files and the same applications which you have already installed in it, so you can directly use the setup, the file, and directly launch an instance. So for that, there is something called a backup in AWS. So that backup is called a snapshot. So you can create a backup of the EBS volume, which again is called a snapshot, and which will be stored in S3. So now using the snapshot, you can create an EC2 instance which resembles the one you currently have. So this is where AMI comes in. So let's say you have created an instance, you have launched a server inside of it. There is a web server running. There are 10 different web files stored inside it. Okay. So now let's say you want an instance just like this. You want the same files, you want the same web server running in it, but you don't want to configure it again. So in that case, you can create a copy of the same instance. And once you create the copy of the instance, you can use that copy to create multiple instances with the same configuration. So this is the end of the theory part. So guys, in the demo, what I'm going to show is I'm going to show you how to create an EC2 instance first and how to connect to an EC2 instance. And once we connect it, I'll be showing you how to launch a web server inside the instance and how to basically make sure it runs. Okay, and the final thing I'll be showing you is how to create an AMI and create a copy of the same instance, so that you can increase the number of servers or decrease the number of servers according to your need. So these are the three things which I'll be showing you. So this is the theory part. Now let me open the console and let's start off with it. So guys, this is the next part. So we've covered the theoretical part. So now what we're going to see is we're going to understand the AWS Management Console. So the first thing you will have to do is obviously log in into AWS. And before doing that, make sure you have created an AWS account. So to do that, I'll just show you because I want to start from scratch. I don't want to give you guys information from right in the beginning. So basically, you will have to come to aws.amazon.com. So for now, it's showing sign into the console, right? I've already signed in. So let me just sign out. All right. So now it's asking me to sign in to the console. So I can directly sign in like this. Okay. So if you've not created an account, you can click on create a new AWS account. So then it's pretty simple. Just provide your email address, password, and your AWS account name. It'll be like your username. So this is basically set up like how you set up for a Facebook account or an Instagram account. It's pretty simple. So once you do this, just provide continue. So after that, they would be asking some more information like billing information, but either debit or credit card details. So the thing is, you will have to provide a debit or credit card detail. Without that, you cannot proceed. So if you're from India, they would detect 2 rupees from your account and which will be returned back to your account after 3 days, because they just want to verify if your card is an authentic or a legit card or not. So that's it. So once that is done, your AWS account will be set up and you can wait for an hour or two, and then everything would be set up in your account and it will be ready for use. All right. So once that is done, you can basically sign into your account. So I'm just signing in. Okay, so now you can access all AWS services here. There are sections for recently visited, and you can save your favorite services too. Okay, so first of all, if you click on services, you can see every single service over here. And recently I just opened EC2. Okay, so this is a new account. And again, analytics, application integration. So these are the various service domains which you can click and look into various other services. For example, if you want to look into a migration service, then you can just click on migration and transfer, and it will show all the different tools which are available for migration. So database migration, AWS migration, simplify and accelerate the migration of your data centers to AWS. Server migration, if you have servers in your on-premises system and if you want to migrate it to AWS without any further attention, without setting up anything, you can use server migration service. So like this, you can view services for every single domain. So in our case, EC2 is a compute service. It provides you compute power. So it gives you virtual servers in the cloud, which are called as instances. All right. So this is what we're going to cover in this particular session. So why EC2 at first? Because EC2 is the most integral service. So we'll be looking into many other AWS services in the future in our YouTube channel. So we'll be looking into VPC, S3. We will be looking into a simplified project using these services. We'll be looking into RDS, and there are so many services to learn. So this session, we're going to look into EC2. All right. So once logged in, few things you'll have to look into is, so this is services. This is the search bar, like you can search for the services over here, and this is the shell. So it opens up the Cloud Shell if you already have services. So you can basically access those services via the shell. So to basically start working with the shell, you will have to know the commands, AWS CLI commands. So you can check out the AWS CLI documentation in order to start with that. So again, this is a little complex. I'm not going to go into this. This we'll see later in another session. And this is a notification one. So if there are any issues with certain services, they'll be showing it over here. And then over here, so this is the help section. So basically, if you want to raise support ticket, then you can go to support center and do that. Okay, and this is an important part. So this is where you will be provided all the regions from all the regions which you can choose from. So these are the data centers, different data centers available in different various locations. So this is North Virginia, which I'm currently using. So if I'm in India, I could go with Asia Pacific Mumbai as well. So right now, the only data center available in India is in Mumbai. So rest every Asia Pacific regions are, you can see Hong Kong, Osaka, Seoul, Singapore, Sydney, and Tokyo. All right. And in US West, there are 4. Europe, there are 6. Yeah. So basically, you can choose whichever region you want. I'm just going to go with North Virginia. So this is one of the most reliable regions in AWS, because as you can see, this is US East 1. And so basically the US data centers get the new features first before they implement it in other data centers. So if there is a beta version of a new service, that would be implemented in the US data centers. So if you are using AWS, then go with the US data centers to start off with, that is to practice with, because if you want to check out the new features, it would be available in the US data centers. All right. Okay. And then this is your account details. So your account ID will be provided here. If you click on this, more account details will be provided. This is organization. This is a separate tool, AWS organizations. So if you're working for a company and let's say you can create an organization, under that you can have multiple AWS member accounts. So for example, let's say you are managing a team of 50 people who all are working on the cloud, who all have separate accounts or who all have member accounts. So you can maintain that access from this one particular tool, organization. So if you want to remove certain access, if you want to give people access, you can do that from this particular console. Okay, service quotas. So initially there would be certain service quotas. For example, you can only launch 100 servers in one particular region. So if you want more, you can basically click on service quotas and check what are your current service quotas, and then ask for an increase in your quota to AWS, and they would give you an increase as soon as your ticket is solved. Okay. And then billing dashboard. So this is where you get all your billing details once you, let's say you're using a service for 3 hours. If it is not under the free tier limit, that will basically give you a charge. And that charge will be reflected in the billing dashboard, which you can view over there. Security credentials. So these are important, but again, you need to know more about AWS in order to understand these concepts. Okay, so I'm going to skip this. Alright, so this is the account and you can sign out directly from here. Okay, so this is basically the console, guys. And then over here, you can see build a solution. These are for beginners. You can start off with this as well. You can learn the fundamentals from the documentation. You can pick a learning path. Okay, so now I'm going to just open the EC2 console. Alright, this is how the EC2 console looks. Over here, you can see the instances, the elastic IP addresses, the key pairs. So I'll be explaining what is a key pair. So you don't have to worry about what are these. I'll be explaining about them. So I won't be explaining about load balancers or security groups. What else? Yeah, so load balancers I won't be explaining because it's a separately different concept. Load balancers again is a major topic which we can see. And then there is a new feature available right now, EC2 Global View. So if you have servers in, let's say, 10 regions, and if you want to view them in one single place, so you can click on EC2 Global View and it will give you a view of all the servers running in all the regions. So this has been provided recently. This was not available before. So you can see they are giving you a complete overview of all the regions, number of instances running, if there is a VPC created, if there are subnets, if there are security groups, and every single information you need to know about EC2 instances. All right. Okay. And one more thing I wanted to show you guys is, yeah, so instances running, if there are any instances running, it will be shown over here. Okay. All right. So this is basically the introduction. So next what we'll be doing is we'll be launching a server in EC2. That's when we'll be understanding more about EC2 and how to configure EC2, how can we choose an AMI and all of that. So I'll be explaining every single step. I'll be explaining the components and the things I'm entering. So you don't have to worry about anything else. So just follow me through. If you already have created an AWS account, then you can just follow this tutorial. You can basically walk through with me. If not, create an AWS account and then start off with a video from this particular part, because we'll be looking into a demo from here on. All right. Okay. So we'll start off with the demo. So starting off with the demo. So first of all, we'll be looking into instances. So we'll be launching an instance using EC2. So as I already explained, instance is a server. So I'm going to show you how to launch a Ubuntu instance. And once we launched an Ubuntu instance, I'm going to show you how to connect to the Ubuntu instance using the terminal. So this is a Mac, so the connection, I'm going to use a terminal to connect it. If you're using a Windows system, then you can download something called Putty. So Putty is a tool which I'm going to show you. So this is the Putty link. So you can basically go over here and download the Windows installer. So over here you can just download it and you can start using the Putty tool instead of using the terminal. So this is for Windows. If you're using a Linux machine, so let's say you're using Ubuntu or a CentOS machine, so in that case again you can directly use the terminal itself. You don't have to use anything else. Okay, so now let's start. I'll be explaining each and every step while we go through this. Alright, so instance running. So currently there are no instances running, so it's not going to show anything else. And so before moving on, I just wanted to show one more thing, which is the free tier in AWS. Okay, over here you can see, you can go to aws.amazon.com/free if you are watching the video currently. You will be provided with all the services which you get a free tier for. So basically you would get a amount or number of services, number of features for free for a period of time. For example, for EC2, they're giving you 750 hours of runtime for a server. Like it's not one server. Let's say if there are 10 servers running and each server can run for 75 hours. The total would become 750 hours. So for that 750 hours, you would not get billed anything. If your hours go beyond 750, then you will start getting billed for the first 12 months once you create your AWS account. So like that, all the integral services have certain free tier limits. So you can basically be within the free tier limits while practicing and you won't get any bill. You would not get billed anything. So you can just check what is free for 12 months. What are the services which will be always free. So like DynamoDB, 25 GB of storage in DynamoDB is always free. 1 million publishes in SNS is always free. So like that, all of this will be provided. All right. So I just wanted to show that because while we go through this particular process of launching an instance, here we'll be given options of something called a free tier instance type. So I don't want to take you again over the website to show you this is what a free tier is. So I just wanted to show you right now so that we can move on. All right. Okay. So now let's launch an instance. So to start off with it, you can just click on launch an instance over here, or you can just go to the EC2 dashboard and click on launch an instance over here. Alright, so the next step is basically to choose an Amazon mission image. So over here you can see the first one is Amazon Linux 2 AMI. So Amazon Linux 2 is the operating system which Amazon themselves provide, and you can see there is something called free tier eligible. So whichever AMIs have the name free tier eligible over there are the AMIs which are given for free of cost. You won't get charged anything for using these AMIs. If you're using the other AMIs, for example, the deep learning AMI or the deep learning AMI GPU PyTorch, let's say Microsoft Server 2019 with SQL Server 2019 standard. So these kinds of AMIs will cost you. You will get billed. So to start off with it, to practice, you can just start off with the free tier eligible AMIs. So I've already explained what is an AMI. And so again, they also recently added the Mac OS. You can also create a Mac server. All right. Okay. So what I'm going to do is I'm going to launch an Ubuntu server and I'm going to show it, and I'm going to connect to the instance and show it to you. All right. Okay. So Ubuntu instance, it's free tier eligible. And yeah, so I'm going to choose the 20.041. There is the 18.04 as well, which is the older version. The new latest stable version is 20.04. So I'm going to select this. So the next thing it will ask is what type of an instance type do you need? So the instance type which is going to be free for you if you create a new AWS account would be t2.micro. So every other instance types will get you a build. So the only instance type which is free is t2.micro. So go with it. So what you want to know here is, so t2.micro provides you one virtual CPU. So that basically means it provides you one virtual CPU of compute power and 1 GB of RAM. And it only allows EBS storage. That is, you can only connect an EBS volume to it. You cannot connect anything else. You can connect other storages, but the root volume would be EBS. So if you come down, so here you can see SSD is allowed. Here EBS only. So wherever EBS only is provided, you can only connect EBS. Wherever SSD is provided, you can connect other services like instance store. You can connect EFS. So all of that can be connected. So you can also connect EFS to here, but EFS would not be the root volume. The EBS volume which will be created with the instance would be the root volume. So that would be added in the fourth step, which is add storage. So first we choose the AMI. Second we choose the instance type. We need one virtual CPU and 1 GB of RAM. Alright. Next, we are going to configure the instance details. So over the instance details, the first one is number of instances. If you need one instance or 10 instances or 100 or 1000, how many instances do you need? You'll have to provide the number over here. Okay. So it will create that many instances for you. The next one is a purchasing option. So we are not going to purchase any instance right now. So this basically I'll explain it to you. Purchasing option is basically you can reserve the instance for a year or 3 years. So it will basically provide you a dedicated instance in a dedicated physical server, which will always be available for you at any time. So if right now we are creating an on-demand instance. An on-demand instance is basically an instance which you create whenever you want, terminate whenever you want. But if you want, let's say 100 instances dedicated for you in a dedicated physical server, even though it's AWS, it's someone else's data center, but you want dedicated number of instances. So in that case, you can use the purchasing option. You would also get a discount in the purchasing option because you're going to purchase it for a complete year. So you'll be locked in for a year and you'll be paying for that. All right. Okay. And next comes the network, subnet, and auto assign IP. So this I'll be covering in the VPC tutorial, but again, these are very vast concepts which you'll have to understand more. But to be very simple, so every single system should be in a network. Without a network, you cannot have a system. So to connect with the system, to communicate with the system, there should be a network. So that's what VPC will do for you. You can have an isolated network within AWS, which will be isolated from other VPCs, other networks which other customers have. Okay, but again, you can create a peering network within two different VPCs. So peering network is a communication network where a server from another VPC can talk to or communicate with another server in another VPC. So again, these concepts we'll learn in another tutorial, and so I'm just going to move ahead. Okay, so for now you just have to know this number of instances is 1, so we're going to create 1 instance. That's it. Next, we have to add storage. So while you install a server, while you install this particular instance, the data, the files should be stored somewhere, right, in a root volume. So for that, we need to create a root volume instance, okay, a volume. And here it's basically an EBS volume. As I told you, only EBS is allowed in this particular instance type. And free tier eligible customers can get up to 30 GB of EBS volume per month. Okay, so you can see I can go to the free tier thing and check it out. So I'm just going to use 8 GB. So because Ubuntu server doesn't need more than 8 GB of storage, just takes 2 GB. The server itself is 2 GB. Then there will be lots of space for storage because I'm not going to upload any huge file to the server. So it doesn't matter for now. I'm going to go with the initial size, which is 8 GB. Okay. And delete on termination. So if you switch this on, what happens is when you delete the server, that is the instance, the EBS volume which is attached to it will also automatically delete. If not, if you disable this, when you delete it, the EBS volume will still be available. You will have to delete it manually. Alright. So I'm just going to keep it enabled. And encryption, you can use a key which is available already, or you can leave it just like that. And shared file system. So this is EFS. So you can add a file system directly over here, or after creating an instance, you can create a shared file system and then later attach to it. Okay, so again, this would be a storage tutorial. I'm not going to get into the storage part. We're just covering the EC2 part. Okay, so we need a storage root volume. So we've created that. So that is automatically provided. It's 8 GB. And volume type, it's going to be general purpose. And next, tags. So tags are not integral. They are clearly an optional step. So why tags is basically, let's say you have 10 instances, let's say you have 100 instances and you have created 10 instances in that particular region. There are other people using the account, but you want to differentiate your instances. So in that case, you can give all the 10 instances a unique tag, which you can search for, and it will provide those particular instances. For example, let's say name, I'm gonna put it as scalar. So in this case, the instance which I'm creating will have the tag as scalar. And if I have 10 instances named scalar, and if I search for scalar in the EC2 instance dashboard, it will give me all the instances named scalar so that I don't have to navigate through the entire list. Alright. Okay. So this is basically tag. And then security group. So a security group is really important for an EC2 instance. A security group is what decides basically what traffic should come inside the instance, what traffic should go outside the instance. It's basically like a firewall. Not exactly a firewall, but a list of rules which lets something happen. For example, right now only SSH is allowed. SSH basically means secure shell. So secure shell is a type of a TCP protocol which lets you connect to the EC2 instance via port number 22. Okay, so for now, basically this particular EC2 instance will be allowed to all the IP addresses. So if I want, I can change it to my IP. For example, if I provide my IP, it will only allow my IP, that is my particular personal computer, to access this particular EC2 instance. But if it is in custom or if it is in anywhere, so this basically will allow any system across the world to connect to my EC2 instance. But not everybody can connect. You can only connect to the instance if you have the private key to decrypt the public key which will be available in the instance. So now you would be confused by the key pair. So that's what we're going to cover next. So I'm going to just provide just this one SSH. So I'm going to review and launch. Okay. So everything else is provided. I hope you guys understood the steps. So just follow through and you can create an instance within a couple of minutes. So now when you click on launch, it won't launch the instance. It will ask for a key pair. Okay. So now I'm going to create a new key pair. And so I'm going to name it as tutorial key. Alright. I'm going to download it. So the key pair is downloaded. Okay. So now you can launch the instance. So why did I download a key pair? You might ask, what exactly is the purpose of a key pair? So now I've downloaded this key pair called tutorial key. So now this particular key pair will have two keys. One will be the public key and one will be the private key. The instance we are going to launch, will have the public key inside of it, and the private key is the one which we have downloaded. Alright, so now when you're logging into the instance, not if you provide public access to anyone could log in into the instance if they have the public IP address, but that should not happen. So we do not want that happening. So in that case, what you're doing is only I would be having the private key, which I just downloaded. Only I have the private key, nobody else has it. Even though they know the public IP address of my instance, even though my instance is open to the world, anybody could try to log in. But if they don't have the right private key, nobody else could log in apart from me. Alright, so that's why we need a key pair. It's for security purposes and it's to log in into the instance. Okay, so now let's launch the instance. So now first it basically create all the dependencies. Once the dependencies are created, the instance will be launching. So now we can view the instance. As I told you, first it would be in a pending state. So in a pending state, then it will come to a running state. So then you would be seeing here status check. So the status checks will become 2/2. So that basically means the instance is successfully running. So now the instance over here, you can see the public IP address has been provided. The private IP address has been provided. So the public IP is what you will be using to connect with. The private IP address is the IP address which is particular for the EC2 instance. If there is another service within my AWS account trying to connect to my EC2 instance, in that case it can use the private IP address instead of the public IP address. Okay, alright. So now we can see the instance is running and status check is initializing. So let's just wait until this completes. Sometimes it will so you can see the status checks are running, system status checks and instance status check. So it will just check if the instance is running properly, if there is any issues. If there are no issues, that it will just show 2 out of 2. That's it. Okay, so then there is a security. So this is where you see all the security rules, the security group which was created. Networking, again, so networking provides you more information about every single networking detail, the public IP, private IP, public DNS. So public IP address and the public DNS is the same. So it's basically this DNS name will search for this particular IP address. That's it. It just redirects to this IP address. So you can see it's the same thing. And so it's an internal DNS name, and then what VPC has been attached to it, which subnet has been attached to it, and what is the availability zone. So in North Virginia alone, there are 6 availability zones. That is 1A, 1B, 1C till 1F. Alright. Yeah. So basically, this is launched in the 1B availability zone. Okay. So next storage has been created. It's been attached. Status checks. Let's just refresh this. Okay, then monitoring. So this basically will provide you a little bit of insight to the instance. So it will show what is the CPU utilization. So the instance is yet to start running, right? So that's why it's not showing any data. So once it starts running, it will show the CPU utilization. It will show whether the status checks have been succeeded, network in, network out, what is the packets, how many packets came in, how many packets went out of the particular server. That's the internet usage. And if there is any data which was read, there was any data which was written, so all of that will be written. Okay, got it. So now you can see 2 out of 2 status checks have been passed. Okay, so now I just want to show one thing. So first let me open this particular IP address. So I just wanted to show that there is no website running or web page running in this particular EC2 instance, because I just launched it and I am just opening that particular IP address so that you wouldn't know there is no web page running in this. Okay, so there is nothing running in this. That's why it's still loading. It won't show any web page. Okay, so I'll be launching a web page. That's why I'm saying when I launch a web page, when I run this exact same IP address, it will show a web page. Okay, got it. Okay, so now let's connect the instance. The instance is successfully running. Okay, and then over here you can see there are 3 options. You can reboot the instance. You can stop the instance and terminate the instance. I told you what each of these things does. And if you stop the instance, then also you can terminate the instance, or you can start the instance back and start using it. And there are other actions you can connect to it. So again, the connect option. So these are the same things which are provided over here. All right. Okay. So now let's connect to the instance. So there are multiple options to connect to an instance. One is the EC2 Instance Connect. So when I click on it, it will open another tab in the browser, and we can we can basically access the instance directly from the browser itself. And there is another option, Session Manager. So we are not going to use this. Okay, we weren't able to connect to your instance. Common reasons for this. So basically, I have not installed these agents, so I'm not using this. So we're not going to go ahead with this. Connect to your instance without SSH keys or bashing a host. Okay, so we are not going to use the SSH manager. And then we have the SSH client. So SSH client, which is what I told you, Putty is in SSH client. There are other SSH clients as well. So if you have those SSH clients, you can start using them. Okay. And then there is one more, which is EC2 Serial Console. Again, I do not have this particular setup. So either we can go with EC2 Instance Connect, or we can go with SSH client. So I'm going to show you both of these, how to connect with both of these, because I have an SSH client in my local PC, which is automatically enabled in my terminal. So as a Mac, so I can just search for the terminal and connect directly to it. Okay. And so first I'm just going to connect it over here. So you don't have to do anything else. You can just click on connect. It will automatically open a new tab, and it will automatically establish connection to the instance. You don't even have to provide the private key over here. Okay. So whenever you launch an instance, the first thing I would suggest you to do is update it. So as this is an Ubuntu instance, it would be apt-get, it would not be yum. So if it's another Linux instance, if it's Amazon Linux, then it would be yum. And also so I'll tell you that when I'm connecting it with the SSH, what would be the default login name. So the default login name for an Ubuntu system would be Ubuntu itself. So this one. If it's any other Linux system, the default login name would be EC2 user. So this would be the default login name for any other EC2 instance. If you're launching Amazon Linux, then you'll have to use this when you're connecting with via SSH. So one more thing I would suggest is, do not connect it via browser and start working with it, because it's a little buggy. I would suggest you to connect with the SSH client itself. All right. So one thing I want to do is, so for example, let's say there are no files in this drive. I'm just going to create a 1.txt file, so that when I connect it via the SSH client, you would know it is the same instance. That's it, nothing else. All right. Okay. Just going to close this. So now let me open the terminal and let's connect to it. All right. So I'm just gonna make it a little bigger and increase the size. All right. Okay. So now we have opened this. So now to connect to this, we'll have to use the SSH client. So the SSH client, this is the example. Basically, we can use this directly and connect to it. So I'm going to just use this. So one small correction would be that this could be the IP address, or this could be the DNS name. For example, let's say I'm pasting this. All right. So this could be the DNS name, or this could be the IP address. So one thing is that the tutorial key.pem file is not located in this particular location. All right. This key is not known by other names. Yeah. So I'm just going to give no for now. Okay. So the thing is, this particular key which I downloaded is in the downloads folder. It's not in this particular folder. So we'll have to go to that folder in order to access it. So now before doing that, I just wanted to show you. So SSH minus -i or -i, and this would be tutorial. Yeah. So basically what I was saying about is, so we have to figure out where the key is. So then we can basically connect to it. So we can, again, as I told you, so this is the DNS name. If I go to the instance, all right, so this is the IP address. We can use the IP address, or we can use the DNS name. So what that basically means is, so instead of this, you can provide the IP address. That's what I mean. But you can still go with the DNS name. So I'm not going to change it. I'm just going to copy it. And one thing is that SSH-i, so tutorial key.pem. So this is -i basically denotes the key, and we are providing the name of the key. And then Ubuntu is the username at what is the IP address. So that's what you're providing. So it will basically search for the server, and it will use this particular key to connect to it. Okay, pretty simple. Now I downloaded it, so it would be in the downloads folder. So I'm just gonna see, and yeah, so it's in this folder. I'm just gonna paste Okay, so now this particular key is in this folder. I know that, so I'm just going to go with it. So I've hit enter, and now you can see the authenticity of host. The IP address has been provided, can be established, and the key fingerprint is provided. The key is not known by other names. Okay, so yes. Okay, so now you can see this has been added to the list of known hosts, unprotected private key file. So that is fine. We can just change the permissions of the tutorial key. Yeah, so the key's permission has been denied, so nothing else. We just have to change the permission of the key. Okay, so over here you can see, right, chmod 400. We can just run this command and we can make sure it's available. So that's it. I'm just going to paste this and done. So now let's run this again. So now it has been successfully connected. So the instance has been connected. You can see Ubuntu at the IP address has been provided over here. Okay, so now if I do an ls, it should show the 1.txt file which I created in that browser, right? So it's the same instance, we just connected it with the browser. Now we are connecting it with the terminal. Okay, so if I do an ls, you can see the 1.txt file is available. So simple. So we have created an instance and connected to the instance via the local terminal. So this is basically one of the biggest things in AWS and one of the most easiest things to start with. So you have successfully created your own server and you have connected to the server in your local system. Okay. So now the next step we're going to do is we're going to create and we're going to configure a web server inside of this particular server, and we're going to run it publicly. So over here, right now, as I told you, there is no web server running. So we're going to launch a web server inside this, right? Okay. So now, so there is a web server. We can either use Apache 2 or we can use engines. So I'm just going to go with Apache 2. I'm going to install Apache 2, and so it would be a sudo apt-get install Apache 2 and -y. If there is any question which is asking yes or no in between, it will automatically provide the answer as yes. Okay, so we are installing Apache 2. So this is a web server which will be configuring and creating a complete web server for us, in which we can put our HTML pages, or we can put in our, what is that? Yeah, so we can put in our PHP pages, and that will work fine with this. All right. So that's what we are trying to do over here. And once done, we'll have to do one more thing. That is, we'll have to allow this particular web page in the AWS console. So we have provided only access to SSH, right? So the instance could only allow SSH, but in this case, we need to allow another access. So we need to allow another protocol which would be listening to this particular web server. All right. Okay. Okay. So the web server has been successfully installed. Alright, so the location of this particular web server in this particular server would be in a location called /var/www/html. Alright, so there is an index.html file available over here. This is the index.html file which will reflect when I'm going to refresh this page, but it won't reflect now because we have not allowed the port number 80 and the protocol HTTP. So once we allow that, this particular web page will be shown over here. Okay, I'm going to go to instance management and go to security. So we'll have to allow the port number over here in inbound rules. So to allow it in inbound rules, we have to open the security group which is attached to the instance. So I'm going to open the security group and edit inbound rules. So I'm going to click on inbound rules and add a rule. So here it could be custom TCP, and you can just provide the port number as 80, or you can basically select the HTTP and you can provide anywhere IPv4, or you can provide my IP. So you can connect it from your IP. So I'm connecting to the instance from my IP address, right? So then it will only show that particular instance, particular web page from my IP address. So I'm going to use anywhere. So okay, so I'm allowing anywhere over here, and I'm going to save the rules. So done. So now HTTP protocol has been allowed. So now if I refresh this particular web page, this particular IP address, which is the IP address of my server, this web page index.html should be shown over here. So I'm going to just refresh this. So it's just taking some time to load. So I'll just close this and let's open it again. We'll go to the instance. We go to networking. Yeah, so now we can see the Apache 2 default page has been loaded over here. Okay, it's pretty simple. So this particular page, index.html, is shown here. So we have successfully launched a web server and hosted a simple web page over here. So now what I'm going to do is I'm going to do one more thing. I'm going to basically create, so this is a web page. So what I'm going to do is I'm going to basically create another file, let's say 1.html over here, and we are going to use that. So I think this particular page is kind of still loading. So what I'm going to do is I'm gonna launch another terminal. Okay, and I'm gonna make it bigger and then open downloads. Okay, so I'm going to connect to the instance once again. Okay, so we've connected to the instance. So now let me open the same drive. So we'll have to add a slash here because we are in a different directory and we are taking this from root. So that's why we'll have to add that. All right. So okay. So now index.html is available over here. So now let's do one thing. Let's add sudo 1.html. Okay. So I'm gonna just provide something like hello world. This is 1.html file. All right. And I'm gonna save this file. So I'm going to save this as HTML. It's been saved. So now I'm going to exit. So now you can see 1.html file has been created. Let me just check. So hello world, this is 1.html file. So HTML file has been successfully created. So now let me go over here again. So this basically searches for the index.html file in the /var/www/html directory. So in the HTML directory, it's searching for the index.html page. So now if we write 1.html, then it should fetch the 1.html page. Over here you can see, hello world, this is 1.html file. So this is very simple web page hosting. So that's what we have done here. So if you want your website to be running as the default page, in that case, you would just have to remove this particular index.html page and replace it with a new index.html page. And that's more than enough. So when you put the IP address, it will automatically run. So, okay, so this is basically the very simplest part. All right. So now, this part. So I'm going to show you one more demo, which is going to be AMI. That is, we're going to copy the AMI and we're gonna launch the instance so that it has the same web page, Apache to Ubuntu default page, and this 1.html page already available inside of it. So we are not going to configure anything. We're just going to launch it and we're going to see if that instance has this pages available. Okay. So to start off with that, we have to first create an image of this instance. That is, we have to create a copy of this instance we have created over here. So instance state, so this is the instance state. Now if you go to actions, there will be an option called images and templates. Okay, so here you get an option called create image. So you have to click on create image and you have to provide an image name. I'm just going to provide it as copy of scaler. All right. And then if you don't want any reboot while you are creating this image, you can provide this, but it's fine. Let the instance reboot, no problem. If you want to add another volume, you can add it, or it will automatically create a default volume, and it will use the snapshot of the instance which we already have, which is the scalar instance. It will use a snapshot of that and basically copy the entire configuration into this, so that all the configurations we've made, all the software we've installed, all the files we've created, all of those will be available in the new instance which we'll be creating using the AMI, which we are creating right now. Okay, got it. Okay, so now done. So we provided the name of the image. That's more than enough, and we're going to create the image. Okay, so image has been created. So to see the image, you have to go under images, AMIs. So now you can see it's pending. All right, so this is the instance which we have, guys. So I'm creating an AMI and I'm going to use this AMI to launch another instance, And that instance, I'm not going to log in into the instance. That instance is already going to have all the files which you already configured in this particular server, in this particular instance. So let's say if you want to create an instance and want to scale up and down accordingly, so this is how you do it. You create a copy of the server which you have configured, which is all the software, which is all the code files, which is all the data which is required for your application to run. And you create a copy of that, and you use the copy to create multiple servers, so that there could be more servers created of the same configuration again and again. So now again, the thing is, if you want to change the configuration a little bit, in that case you can just change the configuration in one server, create a copy of it, and use the copy to again create similar servers. So this is how it works. You don't have to log in into every single server and configure every single time. You just have to create the server once, configure it once, create an AMI, use the copy to create a similar server. Got it? So it's that simple. So it will take some time to basically come back, basically come as available, and it's a private AMI because I'm creating the AMI within my AWS account for my personal use. So it would be private. If you want, later you can make it into a public AMI which others can use. Okay, if not, it's fine. So for now, let's let it be a private AMI. Okay, and so this is the AMI ID, and this is the source, which is my account, the owner account. And yeah, so pretty much that's it. So only thing we have to wait is for it to become available. Okay guys, so now the AMI it's been available. Okay, so the status has been changed from pending to available. So now we can use this AMI to create a similar instance of the instance which we created and configured. So it's pretty simple. Just select the AMI, click on launch. Then it's the same steps. Okay, just choose the instance type. I'm going to choose the same instance type, t2.micro. Configure instance details. I'm going to leave it to the same. Add tags. So this is the storage. Again, I'm going to leave it to blank. I'm going to just leave it like this. I just need the same thing. Tags, I'm going to name it as AMI instance or copy of scalar. Next. So here, I'm going to use the same security group which we just created, launch wizard 52, I guess. Yeah, which has HTTP and SSH both. So I'm going to use the same thing because we are not going to log in into the instance and launch a web server and then configure it. It's already been configured. We'll just have to allow HTTP, and once the instance is running, the web page will be already running in the server, in the instance, right? Okay. So now let's launch. So now, second thing is that you don't have to create a key pair every single time you launch an instance. If you have a private key in your system, you can just use the same key pair. Over here, I've created as tutorial key, right? You can just use the same key pair in order to connect to any instance you want. So the public key will be available in various instances. So make sure only you have the private key because it's pretty important. If anybody else has the private key, they could connect to the instance. So keep your private key with yourself, and that's it. So then you can just launch the instance. And once the instance is running, then it will already have the web page running inside of it. So this is the web page which we have over here, right? Okay. So this particular server should have the same web pages running because it's the copy of this particular server. Okay, so I'm just going to copy the public IP. So it's in pending state, but yet I'm just going to paste it and keep it over here. So once the server is up and running, it should show the Apache 2 default page over here, the Ubuntu default page over here. Okay. So it's running. So status checks are not done yet, but sometimes even though it's showing initializing, it will be already done. So I'm just going to refresh it and check once. Okay. So the instance is running, guys, and you can see it's a completely different IP address, and this is a different IP address, and it already had the Ubuntu default page available inside of it because it's a copy of the instance we created. So this is how an AMI works. The AMI will have the complete configuration, the software, the applications, the files, everything which is inside of an instance, and we create an AMI of that instance. It will create a complete copy which can be used to create more instances, basically replicating the same instance. Alright. So now this instance should also have the 1.html file. So it also has the 1.html file inside of it, guys. So this is basically it for this particular demo for the EC2 tutorial. So I showed you how to create an instance, how to create an AMI, and how to launch an instance with the AMI which we just created. So this is basically it. It's pretty simple, right? And you can also follow through with this particular tutorial, and you can also start with AWS. So it's pretty simple to start with. Anybody could start with it. And if you want to launch or deploy your own website, you can just use the server. It's really cheap. You can just use this server in order to host your web page or your website. Okay. So that's it for this session, guys. Thank you. So guys, let's start off by understanding what is Amazon VPC. So Amazon Virtual Private Cloud enables you to launch AWS resources into a virtual network that you defined. So in the AWS cloud, you basically have to define a virtual network, which is basically an isolated network in your own AWS account. So now this virtual network closely resembles a traditional network that you would operate in your own data center with the benefits of using the scalable infrastructure of AWS. So basically, when you're using AWS, there are millions of people, millions of companies using AWS, right? So in this case, what happens is you would have to isolate your resources from the others' resources, or you would have to isolate your resources in your own account from other resources in your own account. So for that case, you can have a VPC, a virtual private cloud, which creates an isolated network inside the AWS cloud. So even though it basically resembles a traditional network setup, you can still use AWS's architecture in order to scale up or scale down your infrastructure. And also one of the main common use for Amazon VPC is it's the networking layer of Amazon EC2. So if you do not know what EC2 is, go ahead to our previous tutorial on Amazon EC2 and learn about that, and then come back to this tutorial so that you could get a better understanding of what EC2 is, because when we are looking into the demos, in that case, we'll be using EC2 to demonstrate certain aspects of VPC. So in that case, you would have to know what is EC2 and how to create an EC2 instance. So for that, you can go ahead and look into it. Okay, so now this is what VPC is. Okay, so now let's just look at the key concepts in VPC before we move on. So first of all, VPC, Virtual Private Cloud, a virtual network dedicated to your AWS account. So again, it's dedicated to your AWS account, and also it will be dedicated to a particular region. So there are many regions in AWS which you can choose from. So under each region, there would be a default VPC available. And then you can create more VPCs. About that we'll see later in the session. So now, so it is basically dedicated to your AWS account. It is not shared with anybody else. And then a subnet. So under a VPC, you can have multiple subnets. So a subnet is basically a range of IP addresses in VPC. So let's say your virtual private cloud VPC allows around 64,000 IP addresses. So now you can create a subnet which allows around 4,000 IP addresses. And so that subnet allows 4,000 IP addresses. And you create another subnet which allows 10,000 IP addresses. But they cannot overlap because they are individual subnets. And the subnet 1, which has 4,000 IP addresses, the range of 4,000 IP addresses, will have a set of IP addresses which we can assign. So if you launch an instance, EC2 instance, within subnet 1, it will have an IP address within that IP address range which has been provided. And then same thing if you go with subnet 2, which has 10,000 IP addresses, which has a different range of IP. In that case, if you launch an instance within that, it would have a different IP address, which would be within that particular range of IP addresses. Got it? Okay. So next is route table. So it's a set of rules called routes that are used to determine where network traffic is directed. So again, this we'll also learn later in the session. Internet gateway, a gateway that you attach to your VPC to enable communication between your resources in your VPC and the internet. So as I told you, the VPC makes sure that it isolates your resources in your VPC from the outside world or from any other VPCs in the AWS network itself. So how would a communication happen? How, let's say you are opening your instance and you want to download something from the internet. If the VPC doesn't allow that, in that case, you would not be able to download any applications. Okay. So for that, you can use internet gateway. So an internet gateway is attached to that VPC. So once it's attached to the VPC, any resource within the VPC will be able to access the internet. So that basically is an internet gateway. And then a VPC endpoint. So it enables you to privately connect to your VPC, support AWS services and VPC endpoint services powered by private link without requiring an internet gateway and NAT device VPN connection or AWS Direct Connection. So a VPC endpoint is another concept, another tool in VPC. So in this case, let's say you have another service, another AWS service, and you want to connect to your service within the VPC. But let's say in this case, if you want to connect within your own AWS account, in that case, it would be much better to connect privately rather than connecting publicly over the internet, because that would be unsafe, right? So if you want to connect privately, for that case, you can use a VPC endpoint. You can create a VPC endpoint for your resource, which can be used to connect to the resource. So let's say you want to access S3 from your EC2 instance. S3 is a storage service. So let's say you want to access the storage service from your EC2 instance. One way you can do is from the AWS CLI directly via the internet. So if the internet gateway is attached, and if you have given permission, if you have configured your AWS command line interface, you can access S3 from your EC2 instance. But if you have not done that, in that case, let's say you create a VPC endpoint for that S3 bucket. Okay, so now using the VPC endpoint without going through the internet, you can connect to the S3 bucket directly via your just the VPC endpoint. Nothing else is required. All right. Okay, and then there is CIDR blocks. So CIDR blocks are called classless inter-domain routing. So this is the Internet Protocol address allocation and route aggregation methodology. So when I was talking about subnets, I said there would be a range of IP addresses, right? So to provide that range of IP addresses, you would have to use a CIDR block. A CIDR block decides from what IP address to what IP address would be the range of that particular subnet. So it has its own methodologies, which is again a completely separate major topic. So we'll be learning about CIDR blocks as well. I'll be giving you the basics of all of these concepts. So that's what we'll be learning. All right. Okay. And then default and non-default VPCs. So if your account was created after 2013-12-04, so it comes with a default VPC. So if it was created before 2013, so in that case, you would have already created a default VPC by now. It's been so many years. But if you have created, most probably most of you would be creating your account after 2013. So in that case, your account will already come with a default VPC and a default subnet. So once you create your own AWS account, AWS themselves create a default VPC and a default subnet within the default VPC for you. So that's what they do. So if you have a default VPC, you don't have to specify any subnet when you launch an instance. So in the previous AWS tutorial, AWS EC2 tutorial, you can see that when I'm launching an instance, I'm not going to specify any VPC or subnet. If you just launch it in the default VPC, it will launch it in a random subnet, whichever it chooses. You don't even have to provide your preference on which subnet you want to launch it to. So you can do that without even understanding what VPC is. You can get started with EC2, Elastic Compute Cloud, without even understanding what VPC is or what default VPC is. So later you can get a better understanding of what VPC is. So that's what we are doing right now. So again, if you've not watched the EC2 tutorial, please go watch it, do the demos over there, and then come over to this particular tutorial. All right. Okay. So you can also create your own VPC and configure it as you need. So this is known as a non-default VPC. Subnets that you create in your non-default VPC and additional subnets that you create in your default VPC are called non-default subnets. So basically any VPC which we are creating is called a non-default VPC, and in the non-default VPC we'll be creating certain subnets. Okay, so those subnets are non-default subnets. That's the only difference between default and non-default. Default is created by AWS, and it will be already available when you create an AWS account. Later, if you are going to create and configure your own VPC, that would be a non-default VPC. Right? Okay. So now VPCs and subnets. So I already gave you a brief about what a VPC is. So virtual private cloud is a virtual network dedicated to your AWS account. I already told this. So now it is logically isolated from other virtual networks in the AWS cloud. There are going to be a lot of virtual networks, right, in the AWS cloud. So maybe in just your account, you might have 4 to 5 VPCs. So let's consider all the customer base in AWS. So in one particular region, there can be, let's say, 100,000s of VPCs. So now your VPC will be completely isolated from all the other VPC unless you have made a connection with another VPC. Okay, but until then, everything will be isolated. Your VPC, the resources within the VPC would be isolated from all the other virtual networks in the AWS cloud. So you can launch your AWS resources such as EC2 instances inside your VPC, and VPC will make sure your EC2 instance, that is your resource, is isolated from all the other instances and all the other resources and all the other VPCs. So when you create a VPC, you must specify a range of IPv4 addresses for the VPC in form of a classless inter-domain routing block, CIDR block. For example, 10.0.0.0/16. So this is the primary CIDR block for your VPC. And also a VPC spans all of the availability zones in the region. Okay. All right. Okay. So now let's come to the first point again. So here you can see that they're asking us to specify an IPv4 address range. So when you provide this IPv4 address range, that would be the complete IP address of this particular VPC. So the range of IP addresses. So the range would last from 10.0.0.1/16. So it would go to so it is 16, right? So 16 in the sense 10.0 would remain stagnant. It would be the same. Only the last 8 bits will change. So this total 10.0.0.0.0. So let me just make it clear. So these, right? So the total is 32 bits. And they've provided the subnet mask as 16. So when it's 16, that basically means the first 16 bits will remain unchanged. Okay. So now that basically again means only these bits, these 16 bits can be changed. All right. So in that case, so what happens is, so the range of this particular IP address would be 10.0.0.1. So, okay. And so that would be the starting IP. And the ending IP would be 10.0.255.255. So there are so many possibilities within that particular IP address range. Okay. So this is what you'll have to know. Okay. So yeah, so this is how you provide an IPv4 address. And so also when you create one, it will automatically show you how many IP addresses are possible within that particular IP address range. Okay. And then there is VPC, availability zone A, B, and C. Okay. So in a region, there are, let's say you've created a VPC in a region. So let's say I've created a VPC in the North Virginia region. And if the North Virginia region has 3 availability zones, the VPC will span across all the availability zones. If that particular region has 6 availability zones, the VPC would span across all the 6 availability zones. That is, if I launch an EC2 instance in availability zone A or availability zone C, it doesn't matter. I can still launch them within the same VPC, even though they are in different availability zones. So availability zone is a logical divide in an AWS region. Okay, so that's basically what availability zone is. There will be multiple data centers, so that let's say you can have your application running in multiple availability zones. If one availability zone is down or has some issues, you can basically redirect the incoming traffic to your application to the other application which is running in another availability zone. All right. Okay. So this is basically what VPC is. And then coming to the next point. So this particular following diagram shows a VPC that has been configured with subnets in multiple availability zones. So 1A, 2A, and 3A are instances in your VPC. So over here you can see 1A, 2A, and 3A are instances in the VPC. Okay. And one more thing you have to know is, so as I told you here, so let's consider this is the same VPC. So 10.0.0.0/16. All right. So we are creating 3 subnets within the VPC: subnet 1, subnet 2, and subnet 3. And over here you can see subnet 1's IP address range, that is the CIDR block, has been provided as 10.0.0.0/24. This is 10.0.1.0/24. Again, same thing, it's 10.0.2.0/24. So the thing is, the IP address range you're providing for your subnet cannot, so it will be within the IP address range of the VPC, but it cannot be the same as the IP address range of your VPC. So if your IP address range of the VPC has been provided as 16, so you cannot use the same subnet mask as 16. It should be more than that. It should be 20 or 24 or 30 or something like that. Okay. So in this case, 10.0.0.0/24. So this basically means that the first 24 bits will remain unchanged. Only the last 8 bits will be changed. Okay, because total 32 bits, it's 24 bits. So the first 24 bits will remain unchanged. The last 8 bits can be changed. All right. Okay. So same thing goes here. One of the address, let's say 10.0.0.1, it would be 10.0.0. Let's say 10. So that can be an IP address. So here again, so the first 3, that is the first 24 bits will remain unchanged. So all of the IP addresses will start with 10.0.1. Yeah, so that will basically be the distinction between subnet 2 and subnet 1. So subnet 3 again, it will, all of the IP addresses within the subnet will start with 10.0.2, and the rest will follow. Okay, so this is basically subnets. And about route tables, we're not yet there. We'll talk about later in this particular session. And yeah, so these are basically the subnets. And over here you can see there are 3 instances launched, right? 1A, 2A, and 3A. So now you can see the IP address of the 1A instance. Okay, so it's 10.0.0.5. So as I told you, it would be within this IP address range. So now let's see the IP address of 2A. So this is the private IP address, not the public. Public IP address would be totally different because it should be globally accessible, the public IP address, and globally unique. It cannot be a repeating IP address. So this is within the subnet, that's why it can repeat. All right. Then the private IP address of 2A is 10.0.1.5. You can see the first 24 bits are unchanged. Same thing coming to subnet 3, 10.0.2.5. So again, first 3, that is the first 24 bits are unchanged. All right. Okay, so these are subnets. Basically, it's a segregation, or it's a range of IP addresses within the VPC which you have created. All right, that's it. Okay, next is default VPC components. So default VPC components. So basically, I would just wanted to share with you guys what are the components in the default VPC which AWS will create for us. So as I told you, once you create an AWS account, default VPC will already be available in your account when you start working with it. You can start with EC2, you can start launching instances directly because a VPC would be already available and you don't have to create any. So in the default VPC, what are the different components available? So the first one is obviously the VPC itself. So it will be provided by this particular address 172.31.0.0/16. So this particular IP address range, it allows 65,536 private IP addresses. All right, so these many IP addresses are possible in this particular IP address range. So now create a size/20 default subnet in each availability zone. So then they create let's consider North Virginia itself, the North Virginia region. So there are 6 availability zones in the North Virginia region. All right, so in the North Virginia region, they are creating, in each and every availability zone, they are creating a subnet which has the size as /20. That is, the subnet masking as provided as /20. Okay, and when it's provided as /20, it allows 4096 addresses per subnet. So out of 65,000, so let's say there are 6 subnets, so it would be 4096 into 6. So there would be these many IP addresses available in those subnets, in those individual subnets. So there would be an individual subnet for every single availability zone. Third, they would be creating you an internet gateway, so that if you create an instance in any of the subnets, that instance should be able to access the internet, or from the internet you should be able to download something over the instance. Okay, and then add a route to the main route table that points all traffic to the internet gateway. So what this basically means is, in the route table, in the main route table which has been created, they are adding a route which is targeting all traffic. So what it basically means is, all kinds of traffic from the instance can go through this particular route and reach the internet using the internet gateway. So it's routed to the internet gateway, so that particular resources, that is these instances which are launched within the VPC, get access to the internet via the internet gateway. So over here you can see, right, in the main route table, so this is the internet gateway connection. Okay, coming to the next one, Yeah, create a default security group and associate it with your default VPC. Once the VPC, let's say you are creating one, you'll also have to create a security group eventually. But here they already have created a default security group and associate with your default VPC. So security group is created and attached with your default VPC automatically. And when you're launching an instance, you can still use the default security group. And then there is create a default network access control list, ACL, and associate it with your default VPC. So network access control list is more of rule. It's a rule set like a firewall where you can basically control the access, whether it's coming from a different IP address or whether it's coming from one particular range of IP addresses. Let's say you want to take off access to this particular VPC for a range of IP addresses. You can do that with network access control list. Or if you want to only allow access to a certain number of IP addresses, let's say it's an internal application, you only want to allow the IP of the company's network, the IP addresses of the company's network to be able to access your particular application. So in that case, you can use a network access control list even for that. And finally, associate the default DHCP options set for your AWS account with your default VPC. So the DHCP options are basically the domain name, the domain names, complete host name. So all of that details would be in the DHCP option settings, and that the domain name for the VPC, everything will be associated to your default VPC once it's done. So these are the default VPC components, guys. So the thing is, when we create a VPC, we can manually create all of this as we want. So if we want an internet gateway, we can create an internet gateway and attach to it. If we want to change the route to in the route table, we can do that. If you want to create another security group and attach it to your VPC, you can do that. If you want to create a NACL, you can create that. If you want to create a NAT gateway, you can create that. So we can do a lot of things with VPC. So that's what we'll be doing in the demo. And before that, let's just figure out and finish up all the concepts so that we would know what exactly we are doing in the demos. Okay, next comes the internet gateways. So the internet gateway is a pretty simple concept. An internet gateway is a horizontally scaled, redundant and highly available VPC component that allows communication between your VPC and the internet. So now the VPC, as I told you, it's an isolated network. So now the isolated network, what if it needs, let's say, had to communicate with the internet? So let's say a resource within the VPC wants to communicate with the internet, or some entity or some third-party application from the internet wants to integrate with an AWS resource within the VPC. So in that case, you would need an external entity, right, to allow this communication to happen. So that communication is basically internet gateway. So internet gateway lets this happen. So internet gateway makes sure that the resources within the VPC are able to access the internet and vice versa. So an internet gateway serves two purposes. To provide a target in your VPC route tables for internet routable traffic. So it will create a target for your resources. So when a resource is trying to access the internet, it can use that route, and that route would be the IP address of the internet gateway, which can be used to route and communicate with the internet. And the second one is to perform network address translation for instances that have been assigned public IPv4 addresses. So for the instances which has public addresses, public IP addresses, for those particular instances, internet gateway can do NAT, that is network address translation, in order to make sure it communicates with the internet. All right. Okay. Coming to the next one, which is NAT gateways. A NAT gateway, again, from the name itself, it's a network address translation gateway. Okay, so you can use a NAT gateway so that the instances in the private subnet can connect to services outside your VPC, but external services cannot initiate a connection with those instances. For example, in internet gateway, it is both ways. That is, the resource in the public subnet can access the internet, and a third-party tool or a user from the internet can access the AWS resource within the subnet. So that's basically an internet gateway. Now coming to a NAT gateway, let's say you want to configure your resource. So what if you just wanted the connection to be one way, that is, only the resources in your subnet, in your VPC, needs to access the internet, but the entities of a third-party entity from the internet should not be able to initiate a connection with those instances in the private subnet. So that's where NAT gateway comes in. So NAT gateway, so from this diagram you can see, so this is the internet gateway, right? And this is the NAT gateway, which has the elastic IP address. And okay, so let's say, so this is These two are subnets, okay, and these are instances. Okay, so you can see elastic IP addresses are provided for these instances, and there is no elastic IP address provided for these instances because these are private instances. Private instances only have the private IP address because they are not publicly accessible. Only if they are publicly accessible, they would have a public IP address. So elastic IPs in this case are public IP addresses. Okay, so now so this is basically the NAT gateway, right? And now let's say this 10.0.1.5 instance, this particular EC2 instance wants to access the internet. So now it only has the private IP address. It cannot use the internet gateway because internet gateway only does network address translation for public IPv4 addresses. It does not do it for private IPv4 addresses. So that's where NAT gateway comes in. So now this instance, while it's trying to access, it will be routed to the NAT gateway, and the NAT gateway would understand that, okay, this is a private instance, and it would basically translate the private instance's IP address in order to access the internet, and then it goes through the internet gateway and access the internet. So with the NAT gateway, the private instances can access the internet, but the third party entity can only access the public instances which has public IPv4 addresses. They cannot access the private instances which do not have public IP addresses, which only have the private addresses. Okay, so I think it's pretty clear here what is the distinguish between internet gateways and NAT gateways, right? Okay, so when you provision a NAT gateway, you're charged for each hour that your NAT gateway is available. So once you create it, so if you leave it like that, for each hour it will get charged, even though if you're not using it, because it's not a service you can stop or start. It's just an entity which is created and it's available in the subnet. So if you're not going to use it, after some time, after practice, delete it because you will get charged, and each gigabyte of data that it processes. So when the private IP addresses are trying to access something from the internet, let's say if they are downloading 2 gigabytes of data into the instance, so you would also have to pay for that particular network packets which are coming in. So that's what they are saying here. And finally, the NAT gateway replaces the source IP address of the instances with the IP address of the NAT gateway. Okay, I think this particular sentence makes it pretty clear. For example, let's say this instance 10.0.1.5, the IP private IP address. So this instance wants to access the internet. So now, as I told you, it will be taken to the NAT gateway, and the NAT gateway will do network address translation, translates the private IP address of the instance, and it attaches the IP address of the NAT gateway itself, which will be able to access the internet via the internet gateway. Alright, so this is basically how internet gateways and NAT gateways work. So now moving on to the next topic, which is network interfaces and elastic IP addresses. So network interfaces is a separate thing, elastic IP addresses are a separate thing. So now let's see what is a network interface. So an elastic network interface is a logical networking component in a VPC that represents a virtual network card. So usually in a regular hardware system, so every particular network would have, or in every particular server would have a network interface, or a network card. So in this case, it's a virtual network card. So what does this network card have? So that's what they're listing here, the attributes of this particular network interface. So again, every EC2 instance would have a network interface attached to it. So there would be a primary private IP address. There would be one or more private IP addresses if we want. There would be one elastic IP address associated to it, a private address. So then there would be one public IP address, one public IPv4 address. So if we enable this, there is an option called auto assigned IP address, public IP. So that is enabled, it will automatically launch an instance and provide it a public IP address. If it is not given, then it will only have the first three, that is the private IP addresses. Then later, if you want, we can attach another elastic IP address. So that doesn't come with the network interface by default. And then one or more IPv6 addresses. Again, if enabled, we would get IPv6 addresses. Security group, most probably at the beginning you would have one security group. Then if you attach multiple security groups, then obviously there would be more. And then a MAC address, and then the destination check flag, source or destination check flag, and finally the description of what that particular resource is. So these are the attributes which will be available in an elastic network interface in AWS, so in VPC. So this will be attached to EC2, and these are the IP addresses which will be available. These are the description. These are the at different types of attributes which will be available. Okay, and then the next one is elastic IP address. So an elastic IP address is a static public IPv4 address designed for dynamic cloud computing. So you can associate an elastic IP address with any instance or network interface in any VPC in your account. So with an elastic IP address, you can mask the failure of an instance by rapidly remapping the address to another instance in your VPC. To put it very simply, let's say you have two instances, EC2 instances running. Both of the EC2 instances have the same application running inside of them. Okay, so now let's consider, so we have not attached any elastic IP address to this. So now this particular instance will have a different public IPv4 address, and the second instance will have a different public IPv4 address. So if, let's say, the first instance is the primary instance and the second instance is the secondary one, so the primary instance will be running all the time. If the primary instance is down or there's any maintenance going on, then the secondary instance would be running in behalf of it. So now if there's a failure in the first instance, the IP address of the second instance is completely different, so there would be a minor downtime for that particular IP address change to be made. Okay, but what if you can use an elastic IP address which is static? It won't change even when your instance restarts. Let's say you terminate an instance, elastic IP address will still be available. You can attach it to another instance, it will still be the same IP address. Okay, so what I'm meaning here is, if you attach that elastic IP address to that particular subnet or that particular instances, so if this particular instance fails, there would be another instance running, but the IP address of that instance also would be the same, because you have attached an elastic IP addresses, and that would basically rapidly remap the address to another instance in your VPC without any delay. So that's why we have to use an elastic IP address. But the thing is, if you create an elastic IP address and attach it to an instance, there is no cost to it. When it is attached to an instance, there is no cost to it. But if you do not attach it to any instance, there would be a cost. So you would get billed for it. So if you create an elastic IP address, either use it or delete it. Again, this is if you are practicing it. Later you can use it however you want, but obviously if you're not using an elastic IP address, delete it if it's not integral to any of your services. Okay, all right. And the next topic is route tables. So a route table contains a set of rules called rows, and that are used to determine whether network traffic from your subnet or gateway is directed. So already we discussed about this, right, when we talked about internet gateway. So in route tables, there are various components. So the first one is main route table. When you create a route table, there would already be one. So the route table that actually automatically comes attached to your VPC when you create it would be the main route table. So if you see the default VPC, there would already be a route table available. You can create another one later if you want to, but that default route table which gets created when you create your VPC is your main route table. So it controls the routing for all the subnets that are explicitly associated with any other route table. So that is, it basically means if there is a subnet which is not associated with any other route table, it will control the entire routing for those subnets. Then there is a custom route table which you can create for your VPC. It's in your hand. Then destination, the range of IP addresses where you want traffic to go. For example, external corporate network with CIDR 172.16.0.0/12. So if you want the IP address range within this, so this would be an IP address range. So it's an external corporate network, and you want only the systems, that is the computers with these IP addresses to access your particular resources in your AWS VPC. Okay, so in that case, you can set it up like this by providing the destination with the appropriate CIDR block. And then the target, the gateway, network interface or connection. So whatever is the target. So for example, this would be the target, and this would be the IP address which you'll have to provide. Okay, in this case, the target is internet gateway, IP address is all traffic. Okay, and then comes route table association. So the association between a route table and a subnet, internet gateway or virtual private gateway. Again, so this is the route table. So it has been associated with the internet gateway. So that's basically is the subnet route table association. And then subnet route table, a route table that's associated with the subnet. So when you associate a route table, especially to a subnet, that basically means that is associated with the subnet. So that would be called a subnet route table. And there is something called a local route, a default route for communication within the VPC. Within the VPC, you can provide the IP address of the VPC and connect it to the VPC. That would be for all communication which is happening within the VPC. Okay. All right, guys. So now to understand even better what is a route, each route in a table specifies the destination and a target. So the destination is the range of IP addresses and the target is the target component in VPC. So in this case, the target component is internet gateway and you want to allow all traffic through the internet gateway. So that's why you are providing this particular destination. Okay, for example, to enable your subnet to access the internet through an internet gateway, add the following route to your subnet route table. So this is basically what they are telling us to do. You can also do this. So that's, again, I'll be showing that in the demo. The destination for the route is 0.0.0.0/0, so which represents all IPv4 addresses. The target is the internet gateway that's attached to your VPC. Okay, so basically the internet gateway is attached to your VPC and that would be the target, and the destination would be the IP address range, which is 0.0.0.0/0, which represents all public IPv4 addresses. So that basically means it provides access to all internet. Okay, so the next topic is VPC peering. So VPC peering is one of the main concepts in VPC. Again, it's a really easy concept to understand. So a VPC peering connection is basically a networking connection between two or multiple VPCs, mostly two, that enables you to route traffic between them privately. So if you do not want to use the internet, let's say you have two VPCs and there is an instance in VPC A and there is an instance in VPC B. So now the instance in VPC A has a private IP address. The instance in VPC B will also have a private IP address and a public IP address. Okay, so now let's say you want to basically make sure this instance communicate with this instance. You want to like establish connection, or you want to log in into this instance from this instance, or log in into this instance from this instance. So now if there is no VPC peering connection, in that case both of these instances should be public. Only then they can access each other, only then they can communicate with each other. But in this case, with the VPC peering connection, they can communicate with each other with just their private IP address without even having to go to the internet. So instances in either VPC can communicate with each other as if they are within the same network. So to establish that, you will have to do a VPC peering connection. It's pretty simple. You just choose a VPC as your requester and another VPC would be the acceptor. So VPC A would request VPC B to get into a peering connection, and then once VPC B accepts it, the peering connection is established, and then all the resources in VPC A can communicate with the resources in VPC B via a private connection between them. Okay, so the same thing, you can connect multiple VPCs. So over here to the right side, you can see VPC A has a peering connection with VPC B as well as peering connection with VPC C. So you can have multiple VPC connections as well. So in this case, you can also create a peering connection between VPC B and VPC C if you want to. There is also multi-region peering, that is a VPC in one particular region, let's say North Virginia, can connect or can create a peering connection with another VPC which is in, let's say, Ohio region. You can also create a peering connection between VPCs in two different AWS accounts. So a VPC, I have a VPC and I have an instance, and let's say there is a friend of mine who has a VPC in his AWS account, and there is a database, and I want to access that database from my AWS account, and I don't want to do it publicly. I want to do it privately within the AWS network itself. So in that case, you could create a peering connection with that particular account, and then you can use your instance to access that database resource within their VPC. So that can be done using VPC peering. So this is one of the most important concepts, and also a really easy concept to understand, and also a really easy concept to start working on. Okay, so these are the different components and these are the different topics in VPC, guys. So now let's just move on and let's get started with the demo. We'll be starting off by creating a VPC. I'll be showing you what are the different components once you create a VPC. Then I'll be showing you how to create a subnet, that is a private subnet and a public subnet. And I'll be showing you how to create an internet gateway and attach it to the VPC, how to create a NAT gateway and attach it to the VPC, and then also how to create a VPC peering connection. And yeah, so these are the things we'll be covering in this particular tutorial session, guys. So now let's move on to the demo. So guys, now we're going to start off with the demo. So first, open the console. I hope you already have created your AWS account and already have done the EC2 demos. So right now we're going to straight up start off with the demos in VPC. So the first thing you'll have to do is again open the so basically in EC2, I just wanted to show you guys. So as I told you, while you're creating the EC2, the second option is basically to select the VPC you want. And over here you can see there are security groups, elastic IP addresses, network interfaces. So these are concepts which we learned in the theory part. So these also combined with the VPC module. Okay. So now I'm going to search for VPC. So isolated cloud resources. This is basically the VPC service. So once you open VPC, again, there will be a dashboard which will show how many VPCs are available, how many subnets are available, how many route tables are available, internet gateways. There are no NAT gateways, no peering connections. There are 3 network ACLs. There are 92 security groups. So no elastic IP addresses. So every single thing is provided in this particular dashboard, and also it will show that whether Amazon EC2 is working properly or not, because VPC is the networking side of EC2. Okay, without the networking side of EC2, you cannot launch an EC2 instance because you need a network to launch an instance, right? So here you can see you can either launch an EC2 instance or you can open the VPC wizard. So let's create a VPC. So that's the first thing we're going to do in this particular demo. So launch VPC. So here you get an option to launch using the configurations which they already have. So this will basically create a VPC and a public subnet inside of it already for you. So it's a ready-made setup. So you can do that VPC with a single public subnet, VPC with a public and a private subnet with a NAT gateway can also be created without anything. You don't have to put any effort. You can just select this and it will create this exact same thing for you. And then VPC with public and private subnet and also hardware VPN access. So when do you need this? Let's say you are in an on-premises setup. So now if you want to access your on-premises servers as well, so to access that you need a certain connection, and obviously your on-premises setup, it's not VPC. VPC is only available in AWS. So in this case, you would need a VPN connection, a virtual private network connection, which creates a secure connection between the on-premises network and the AWS cloud, which allows you to basically transition and connect to your corporate data center so that you can basically communicate with the servers in the corporate data center from AWS and vice versa. And finally, VPC with a private subnet only. So this is just for communication between the corporate data center and the AWS resources. There is no public activity. There is no internet activity in this case. So you can use the VPC wizard. Okay, if not, you can open your VPCs and click on create VPC. And you can see I already have tried long back. Let's just see this. Yeah, so again, you can see this is not the default VPC because I created it. So this is the default VPC. You can see default VPC. Yes. This is again another VPC. And again, this is not the default VPC. So to delete a VPC, it's the same thing. You can just select it and delete VPC. So if you delete a VPC, it will show what are the other resources which are associated to it, which will get deleted. So in this case, one subnet and one security group will get deleted. So if I give delete and click on delete, so it will delete the VPC, the security group and the subnet associated to that particular VPC. So so it's that simple. So now let's start off with creating a VPC. Click on create VPC, provide a VPC name. So let's say VPC, and then you can provide a CIDR block. So I'm just going to provide a simple 10.0.0.0/16 so that it will allow lots of possibilities for me. So only these two would be closed, and then basically if I so I can change this as well. If I want to, I can change this like this. Okay, so it doesn't matter. Okay, so we'll create another VPC with a different CIDR block. For now I'm using this, and I don't want any IPv6 CIDR block, and I'm going to keep the tenancy as default. So what tenancy means is if you use a dedicated one, it'll give you a dedicated VPC in one particular physical hardware. So you can run instances in your VPC on single tenant dedicated hardware. So that's the only difference. But if you choose dedicated, that will cost you even more than the default one. So the default one is basically common for everyone. Your VPC will be created in a hardware in which there are other people who also have created VPCs. Even though they are logically separated, even though they are logically isolated, even in that case, they are all in the same physical hardware, right? So that's the only difference, and also it will cost you more. Dedicated will cost you more. And then if you want, you can provide the tags. So I've already provided the name for it and it automatically took it as the tag. So I'm going to use that and I'm going to create the VPC. So that's it. A VPC has been created. Okay, so now let's just look into the configuration, which is here. So the CIDR block which we have provided, all right, and then DNS host names are disabled, DNS resolution is enabled. So a main network access control list is created, a main route table is created, DHCP option set is created, and yeah, so pretty much whatever we need is created. So let's look at the DHCP option set. Over here, as I told you, it will have all the information like the domain name servers and all that. So the EC2.internal domain name, Amazon provided DNS. This is the domain name servers. All right. Okay. So this is DHCP, and then also the main route table. So as I told you, a main route table will be created later. If you want, you can create another route table and associate it with the VPC. Again, I'll also show you that later in the demo. So now this is the main route table. Yes. You can see which VPC it is associated with, the scalar VPC which we just created. Okay, so we can see the routes, and there is only one route, which is the local route. So we also looked into it. So the local route will allow communication between the VPC itself. And if you want to edit, you can just click on edit routes and you can add route. Yeah, so you can basically change it over here. So you can see instance, network interface, gateway, load balancer, endpoint, local. Yeah, so you can add a route and you get more options. So the thing is, you cannot remove the local target, you cannot remove the main route. The thing is, if you remove the main route, that will basically remove the communication between the VPC. So basically Amazon or AWS themselves do not allow that. So you can see the thing, right? There is no option to remove this particular route, remove this particular route. Okay, later if you want, you can add routes. If not, it's fine. Okay, so this is the main route. Okay, and then there is a main network ACL. So again, as I told you, this is more like a rule set. So there are inbound rules. So all traffic is allowed, and outbound rules, all traffic is allowed. So there are certain things which you'll have to know in network access control lists. So the rule number will basically tell you what is the first rule which has to be executed. So if it's 100, then it will be executed first, then it's 50, it will be executed second, and if it's star, it will be executed at the last. So basically you'll have to know what is that hierarchy, or which has more power. So that will be provided in the AWS documentation itself. So we can just have a look at it. Network ACLs. So this is the documentation. And yeah, so optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of more or one subnets. Okay. Yeah, so here is the rule. So this is the default network ACL, and coming to the next part. So the network ACL has outbound rules 100 and 110 over here. HTTP and HTTPS are allowed out of the subnet. There's a corresponding inbound rule that enables responses to that outbound rule, inbound rule 140. So you can see, right? So according to the order you provided and according to the number you provided, that will basically determine the hierarchy, or it will basically determine when should what be executed. So for more info, again, you can check out the documentation. You can go through this entire thing. So you can see here, right? They've also provided comments. You can allow a certain port number from a certain IP address. You can deny a certain port number from a certain IP address. Yeah, so this is basically network ACL. Again, you can learn about the basics and all of it in the documentation itself. All right. Okay, so now going back. Okay guys, so we've created a VPC right now, but this particular VPC does not have any subnets. And let me just go to your VPCs. And now you can see, so we've created a VPC right over here. Yeah, so this is a VPC we've created. This is a VPC ID. The VPC is available. And over here, CIDRs, we can see the associated CIDR is this. We do not have any IPv6 address. And yeah, so pretty much we've created it. Okay, so the next step is creating a subnet. So again, to start off with, you can also use the VPC wizard, where you can create a complete, like a private subnet with a public subnet with a NAT gateway automatically. But it would be better if you learn by doing it manually, so that if you understand and do it manually, and if you know the concept and how it works, then you can use the wizard and create it whenever you want. So there's no issues with that. Okay, so the next thing, we have to create a subnet. Let me click on subnets. Okay, so now you can see there are already around 6 subnets. So all of these subnets are default VPC subnets. So why are there 6 subnets? Because in North Virginia, in this particular region, there are 6 availability zones. So if I click on this subnet, you can see this is for 1F, right? This is for 1B, for 1D, for 1E, 1C, and 1A. So these are basically for the default subnet. And over here you can see the IPv4 CIDR is provided as 172.31.48.0/20. Okay, so this basically means there are 4091 IPv4 addresses available. So also it should be actually 4096 total addresses, but the thing is, for 5 IP addresses would be blocked by AWS themselves. So like the first 0.0, 0.3, 0.2, 0.1. So few of the IP addresses will be blocked, and some of it will be already taken. So that will not be covered. So it would be -5. And yeah, so that's basically it. Okay. Yeah, so this is a subnet. So now let's start creating a subnet. So there is no separate way of creating a public and a private subnet. The only difference is when you create a public subnet will have internet access. It will be connected to the internet gateway. There would be a route to the internet gateway. A private subnet would not have a route to the internet gateway. That's the only difference between a private and a public subnet. Okay, the resources in public subnet would have access to internet. Resources in private subnet would not have access to internet. Only if NAT gateway is connected, they will have access to internet. But again, internet, there won't be communication or there won't be a two-way communication. There will be just one way. Okay, now let's create one. So the first step is to select the subnet, and I'm going to select the subnet we've created. All right, and I'm going to name it as scalar subnet 1 availability zone. We can choose one if we want to. If not, we can just leave it. I'm going to choose US East 1A, and CIDR block I'm going to provide as 10.0. So let's say we can make it 1/20. So this is one subnet which I'm creating. So if, let's say, if this particular subnet's IP address overlaps or goes outside of the range of the CIDR block of the VPC, it will throw an error. For example, if I do this, yeah, so let us. So now you can see the CIDR address is not within the CIDR address of the VPC. Why? Because the CIDR address of the VPC is 10.0.0.0/16. That basically means the first 16 bits will remain unchanged for any IP address which is within the VPC. So in that case, we can only change the last 16 bits. So that's why if we do 1 over here, so this won't be any problem now. We can create a subnet. Okay, so but before that, I want to create another subnet because I want to have a public and a private subnet. Okay, so to create another subnet, you can just add a new subnet over here, and I'm going to name it scalar subnet, or let me do one thing. I'm going to name it public subnet 1, and I'm going to name this private subnet 1. And that was 1A. This is going to be 1B, and this is going to be 10.0.20 and 24. So I'm going to give a different CIDR block So you can see CIDR address overlaps with existing subnet CIDR. So basically, this particular CIDR block cannot overlap the subnet, cannot overlap the IP addresses of the other CIDR block. So for example, let's say if I make it 20, so again, it still overlaps. So we'll basically have to change a few things. So the problem here is the first, so if it's 20, right? So this basically means the first, how to say that? Yeah, so 20 bits. So in this 8 bits are there, right? So in the 8 bits, 4 bits remain unchanged and the other 4 bits can be changed. So now in this again, if I give 2, this basically means then the 4 bits will remain unchanged and 4 bits will change, but it will still overlap with the IP addresses in this. So what I'm going to do is I'm going to make it this 0. I'm going to make it 1. I'm going to make it 0. I'm going to make it 2. Let's make it 24. Yeah. So I'm going to make this also 1, 0. Yeah. So now basically this first 3 characters, that is the first 24 bits, will remain unchanged. And over here again, the first 24 bits will remain unchanged. So that basically means they cannot practically overlap. The IP addresses will not overlap. So that was the only problem, and now it is resolved. So you'll basically have to select the CIDR blocks accordingly so that they do not overlap each other. Okay, so now I'm creating the subnet. Yeah, so done. So 2 subnets are created. Yeah, so you can see, right? The other subnets without the name are the default subnets one, and the other 2 are this. So I'm going to do one thing. I'm just gonna give the VPC ID and just gonna keep my subnets available to show them. Okay, it'll be much easier to navigate, right? All right. So public subnet, private subnet. We've created 2 subnets, guys. But the thing is, still it doesn't matter. Both are not. It's not a public subnet. It's not a private subnet yet. Because over here you can see, so if I go to root tables, again even here I'm going to do one thing. I'm going to select the VPC. I think this is a VPC, right? Okay, so this is the 017. So I'm going to just 085. So this is the VPC, yeah. Okay, so this is a route table. So if I go to routes, so only the local connection has been established. So in this case, you will have to establish a connection to the internet gateway, which will be attached to the public subnet, right? Okay. So now subnets are created, guys. So later we'll be making them public and private subnets. So to do that, first we would need an internet gateway. So let me create an internet gateway. Alright, so there is already internet gateway, but this is the internet gateway of the default VPC. So first we have to create an internet gateway. So to create an internet gateway, just click on that, and I'm going to just put scalar internet gateway, create internet gateway, and attach to a VPC. So internet gateway has been created. Now we'll have to attach it to our VPC. So I'm going to click on it. I'm going to select the VPC which we've created and attach internet gateway. So we've attached it to the VPC. Okay, done. Okay, so this is the internet gateway which we've created. It's been attached to the VPC of our choice. So now we'll have to go to the route tables, and in this case, scale a VPC. So this is a route table. We can go to routes. So subnet associations, again, we'll have to associate a subnet, right? So to make, so we've created the internet gateway. Now we are set to make the public subnet an actual public subnet, because the public subnet should have access to the internet, private subnet should not have. So to provide access to the internet, first thing we'll have to do is create a route which will allow all traffic via the internet gateway. So to do that, click on edit routes in the route table, in the main route table. I'm going to click on edit route, add route, and I'm going to make it all IP addresses 0.0.0.0/0 means all IP addresses. Target would be an internet gateway, and it will basically search for the internet gateways available, and the only internet gateway which is attached to the VPC of this particular route table is scalar IGW, scalar internet gateway. So I'm just going to select it and save changes. That's it. So we've attached the internet gateway to the VPC. So now the VPC has internet access. Now how to make the subnet a public subnet? So to do that, we'll have to associate the subnet to this particular route table. So we should not, so for example, so yeah, so we can do this. Yeah, so public subnet should be the only subnet which should be associated with that route table. Private subnet should not be associated with it. If it is associated with it, then that would basically mean it will also have internet access. Okay, so now going to route table and selecting the route table, going to subnet associations and edit subnet associations. So explicit subnet associations, subnets without explicit associations. So these are the only subnets which do not have any associations. So I'm going to associate them. So edit subnet associations, select the subnet which you want to associate and save association. That's it. So now we've attached, we basically associated this particular subnet and to this particular route table which is connected to the internet gateway. Okay, so now what I'm going to do is let's create a EC2 instance inside the VPC we've created. Okay, so we have a public subnet. So one thing we'll have to change is go to the subnet. So one thing you will see is if I click on this, you would see auto assign public IPv4 addresses is disabled. So we'll have to basically edit this into allowing that, because when we create an EC2 instance within the subnet, it should basically create a public IP address for it. Okay, so to do that, we'll have to change it. We've selected the subnet. Let's see if there is an edit option here. View details, action, edit subnet settings, and we're going to enable auto assign public IPv4 addresses. So any instance which is launched within the subnet will automatically have a public IP address. Okay, done. Okay, so that is enabled. Now going back to the EC2 management console. So I'm going to launch an instance. So I'm pretty sure you guys know how to do this. If not, please check out the previous tutorial, because I'll be just rushing through this. Okay, so it's the same step. So I'm just gonna go ahead and create an instance. So the only step you'll have to know is this particular step 3. So in this case, you'll have to change the network. So network, first scale a VPC and the public subnet. Okay, and you can see there are 251 IP addresses available for the public subnet. Got it? Okay, and then so use subnet setting enabled. So in the subnet, the setting was enabled, so that's why it is using the subnet setting. That is, the public IP address is enabled. So when you create an instance, it will automatically create the public IP address for you. Okay, so these are the only things which we'll have to do. These are the only changes which we'll have to make in creating an EC2 instance to create an EC2 instance in your VPC, in your subnet which you've just created. Okay, so one more thing which you'll have to know is the network interface. So it will automatically create a network interface. You don't have to do anything. If you have a network interface already, you can create it. If not, you can leave it. It will automatically create one. And also you can associate a elastic IP address to it. So I'm not going to do it right now. I'm just going to create an instance. Because I just wanted to show you guys, we've created a VPC, we've created a public subnet, we've created an internet gateway and provided the route. So now once we connect to it, it should let us download something from the internet. So basically the instance, right, which you are creating, the instance should be able to download from the internet. If it's not able to download from the internet, then we've not created a public subnet. It is not able to access the internet. Okay, so now next, add storage. I'm just going to leave everything in. So I just need SSH. I don't need HTTP or anything else. So I'm going to review and launch and launch. So I already have a key pair, which is it's tutorial key. Now acknowledge and launch instances. Yeah, so the instance is being launched, guys. So I'm just gonna so this is the IP address. So it will take some time to create it. So let it create, then we'll open the terminal and connect it and check if the internet is working or not. Okay, so now coming back, so we've created a VPC, we've created subnets, we've seen how to change routes in route table and how to associate a subnet to the route table. We've seen how to create an internet gateway. Okay, so now I'll also show you how to create an elastic IP address and how to allocate the elastic IP address once the instance is created. And so I'll also show you how to create a NAT gateway. So okay, so now let it create. it won't take much time. Yeah, so it is running right now. Let's first finish this part of this session and move on to the next part. Okay, so I'm going to click on connect. I'm going to click on SSH client. I'm going to copy this and I'm going to search for terminal. I'm increasing the size. All right, so now the file, the key pair file, is available in the downloads folder. So that's why I'm going to the downloads folder and then I'm hitting enter. So if it's successfully working, then it'll basically log in into the instance which we've created within the VPC which we've created and within the subnet which we've created. So it's taking some time, so that I think it's still creating the instance. So it's still initializing. So maybe that's why it's delaying. So let's wait until it initializes, guys, so that we could just connect it instantly. Okay guys, so now you can see the status checks have been passed. So now we can start off with connecting the instance. So I'm just gonna click on this, click on connect, SSH client, copy the command and paste it over here. Let me just check. Oh, sorry, I'm not in the downloads folder. My mistake. Yeah, so what's the problem here? Yeah, so it's connected, guys. So it's successfully connected. I'm just going to clear the screen. Okay, so now we are in the instance. So now this instance should allow internet access, right? So that's what we've done. We've created an instance in the public subnet, and also internet gateway has been attached to the VPC, and we've also associated the subnet. So this particular subnet should allow internet access. So that's what we're going to figure out. So we'll see if it's able to update. So it's able to update, it's able to fetch data from the internet. So that basically means we've successfully created the VPC and a public subnet, and we've attached an internet gateway and provided internet access to the server. So you've successfully done that. Okay, so one part of the demo is done. So I'm just going to exit this instance. Okay, so let's just go back. Okay, so let this instance be, and let's go to the next part. So the next part would be basically NAT gateways, where we'll be creating a private subnet. So to create a private subnet, what are the things we need is we'll have to basically associate the NAT gateway to the public subnet, and the private subnet within the same VPC will access the NAT gateway in the public subnet, and that will do the network address translation of the private IP into the elastic IP which is attached to the NAT gateway, and then it will allow us to connect to the internet. Okay, so that's what exactly will happen. So that's what we're going to do. Alright, so the first thing we'll have to do right now is create a NAT gateway, and let's do that. Move to NAT gateway, create a NAT gateway, scalar NAT gateway, selecting the subnet. So the subnet should be the private subnet. Okay, remember that you will have to select the private subnet. Selecting the private subnet, connectivity type, select the connectivity type for the NAT gateway. The NAT gateway should be public, but you're attaching it to the private subnet. Okay, and then elastic IP allocation, you can associate an elastic IP or allocate one, or yeah, so basically you will have to create one, right? So I don't have an elastic IP, so that's why I was not able to select one. So for that, you'll just have to click on allocate elastic IP. It will automatically create an elastic IP and associate with the NAT gateway, because without the elastic IP, it would not be able to network address translate the private IP addresses into the IP address which just has been allocated to it. Okay, so now create NAT gateway. So NAT gateway has been created, guys. It has been connected to the private subnet. Alright, so NAT gateway has been created. We've connected it to the private subnet, but there is one problem, because it's not associated directly with the VPC. So it's associated with the VPC, but it does not associate directly with the VPC. So that's what we'll have to do right now. Okay, so I just realized, so one small mistake we've committed is that we've associated the private subnet. So that's not the case. We'll have to associate the public subnet, because the NAT gateway should be created in the public subnet, right? So it's available right now. So I'm just gonna delete it. Delete. So we'll create another one in the public subnet. Okay, because it should be available in the public subnet. Then we'll have to create a route which will let the private resources to access the internet via the NAT gateway. So that's what we're going to do. So I'm just going to create the same name and change the name a little bit, scalar NAT gateway 1, and select the subnet. Subnet will be public subnet. So we already have an IP address which already got allocated, so I'm just going to reuse it and create a NAT gateway. So again, first the NAT gateway would show status as pending. Alright, so then it will become available. Okay, so let it get created. So the next thing we'll have to do is we'll have to create a custom route table. So we cannot associate the private subnet to the main route table, because that will make the private subnet a public subnet, because the main route table has an internet gateway attached to it. So for that, we'll have to create a custom route table. So I'm going to route tables, create route table, scalar route 1 VPC, scalar VPC, and then create route table. So we've created a route table, guys. Okay. So next we'll have to do is we'll have to associate a subnet. So in this case, the only non-associated subnet is a private subnet. So I'm going to select that and yeah, associate with custom route table. So subnet association has been successfully done. Okay. So now I'm going back to routes. So if the NAT gateway is created, we can create a route. Let's see. So it's still in pending state. Let's go to route tables, and also so we've allocated elastic IP address, right? So which got created, so that will be visible here. You can see that here. You can allocate IP address, you can release the elastic IP address, you can associate the elastic IP address to a certain instance. Right now, this particular elastic IP address has been associated with the NAT gateway. So if you want to associate it with an instance, you can just click on associate. Once you've created the elastic IP, then select the instance which you want to associate it to, and that's it. That particular instance will have the elastic IP associated to it. So let's check if it's been created again. Yeah, so the NAT gateway is created, guys. So the next step is to go to the route table and create a route. And so one more thing I wanted to do is, so this one I just want to rename scalar main route. The main route. I'm just going to leave space. Okay, so this is scalar main route table. This is the custom route table. So now subnet has been associated. So the only thing we'll have to do is change the route in scalar route 1. So edit routes, add route, all IPs. We'll have to select the NAT gateway. So this is the NAT gateway. We deleted this, so I'm going to select this and save changes. So we've created a route for the private IP address. So now let me just, I'll do one thing. I'll just give this particular CIDR and NAT gateway. So anyway, we're going to allow only the IP addresses from the private subnet to access the NAT gateway, right? So I'm just providing the same CIDR block as the private subnet to avoid confusion. So that's provided, and save changes. Okay, so we've created the NAT gateway as well, and yeah, so it's successfully created, and you can see this association also has been made. Okay, so I think it's already was created. I'm just going to remove this then. Okay, so done. NAT gateway has been created. So now the only thing we'll have to do is we'll have to create a private instance and try to access the private instance from the public instance. And then once we do that, then the next step would be to try to access internet from the private instance. So now the private instance should not allow internet. Let's say basically it should not allow internet if there was no NAT gateway available. So if there is a NAT gateway available, it should allow. So what I'm going to do is, to show that, I'm just going to remove this. So first let's create a private instance and connect to it, and let's see if internet works in that or not. And then we'll associate an NAT gateway, and then we'll see whether the internet works or not. So that basically will prove, that will be more of a proof of concept, right? Okay. So now I'm going back to the management console. I'm going to create an instance, which would be again Ubuntu the free tier 1. Instance details, again scale a VPC, but in this case it would be the private subnet. Done. So in this case you can see it's in disabled state. Okay, next. Okay, I'm just going to leave it like this. Next, review and launch, existing key pair, tutorial key, and launch instances. Okay, so we've launched the instance. So this instance will not have a public IP address, it will only have the private IP address. Okay. So the first thing we'll have to do is we'll have to log in into our public instance. So only via the public instance we can connect to the private instance, because they are within the same VPC and they can communicate. So even though they are in different subnets, doesn't matter, they are within the same VPC, they can communicate without any issues. Because you don't need internet to connect these two instances, because they are within the same logical network. So in that case, they could communicate, and they could these resources could connect with each other without internet access. So I'm just gonna connect to my instance again, and I'm gonna go back. So the thing is, it will take some time because it's a new VPC and a new subnet. So usually when it's a new subnet, then the status checks will take some time, because that is the first status check happening inside that VPC, inside that subnet. So that's why it takes a little bit time. Okay, so why is this not connecting now? So I think it's the terminal issue. I'm just going to open another. Yeah, so it connected. So it was the terminal issue. I think it got stagnant. Okay. And yeah, so we'll just click on this. So now if we click on connect, again, it does not have a public IP address, so we cannot connect to it, but we can connect to the instance via the private IP, but only we can connect to the instance via the private IP via a resource within the same VPC. So we've already logged in to a resource within the same VPC. So we can connect to the private instance only from the resources available within the VPC. So that we can do. I'm just going to paste this. Okay, so one small thing we'll have to do is that we'll have to upload the tutorial key to this. So I'm just going to do one thing. So as I told you, the first thing we have to do is connect it to the private IP address. So connect it to the private instance. But the thing is, we do not have the PEM file. So the thing is, I copied the PEM file using a copy command, and it has successfully worked. So I've already have the file. So the copy command would go like this. So I'll just show you guys. So it would be scp-i, and here you will have to put in your PEM file name of the public instance which you want to copy. Then here you will have to put in the file path. So this is the file path and the file name. It's actually tutorial key, right? Not tutorial, my tutorial. Yeah, so tutorial key. Okay, so then you will have to basically provide Ubuntu at the IP address 239.226.236. So what this basically does is it accesses the instance, and it does not log in into the instance, it just accesses the instance. So I'm just going to put a sudo also, so once it accesses the instance, it basically will copy the file into the default folder. So you can also mention the default folder, like for example, where do you want to copy home and Ubuntu. So this is where I want to copy the file. Okay, so then I can just put this. So this would be the command, guys, to copy the file. So you can just hit enter, and as I put sudo, it's asking for the password. I'm putting in the password. So so it's showing permission denied. So only thing you'll have to do is you'll have to change the directory and then copy it. That's it, it will work. And this will be the command. So if this doesn't work for you guys, what you can do is you can basically I'll show you something. FileZilla. So in FileZilla, you can basically download the Mac OS client. So this is the Mac OS client. So you can download this and you can connect the thing via this. Okay, so you can basically just download this, install it, and yeah, you can connect the instance to this and just upload the file via FileZilla. So this is one option, but I'm not going to show FileZilla in this because that's again a bigger topic. Okay, all right. So we already have the tutorial key.pem file in our public instance. So the only thing we'll have to do is connect to our private instance. I'm going to copy this and paste it. So now we are in the private instance. You can see that, right? So now we are inside the private instance where we connected it from the public instance. We cannot directly connect to the private instance because it doesn't have a public IP address, but we can connect it via the resource which is already within the VPC. So that thing we've done. So now there is no NAT gateway attached. So let's do one thing. Let's try to do this. So you can see, right, it's at 0%. It's not able to connect to the internet. Okay, so I'm just gonna stop it. Okay, so let this just be here. Let's just go over here again and let this be. Now let's do one thing. Let's now create this route to the NAT gateway. So add route, NAT gateway, choose the right one, save changes. So the route has been added, guys. Okay, it has been added. So now let's try to run the same command. Could not get logged. Okay, so let's try again. Okay, let's do one thing. Let's just log out. Okay, so now we are in the public instance again. So let's try to. So yeah, so we are in the public instance again, guys. So now let's try to connect back to our private instance. Okay, so now the NAT gateway is attached. The route has been created to the VPC, to the private subnet. It is associated with the route table. So now we can basically try to, and now internet is working in the private subnet. So we can just try, we can install sudo apt-get install apache 2. It's downloading, guys. So basically now we've established internet connectivity in the private instance as well. So we've established internet connectivity in the private instance because you can see it's the private instance as IP address, right? So that's what we've done. We've successfully created an architecture. So what architecture we've created? This is the architecture we've created. Let me just open this. So this is the architecture which we've created manually. So there is a public subnet in which we have an instance. There is a private subnet in which we have an instance. In the public subnet, we have a NAT gateway which is associated with the private subnet via a route table. Public subnet is associated with the internet via the internet gateway, again via a route table. So this is the thing which we created manually. So now if you select this, you can automatically create the entire architecture just using multiple steps. So you can basically provide the CIDR block over here. You can provide the VPC name, public subnet's name, private subnet's name. More than enough, it will automatically create everything for you. So but the thing is, if you don't do it by yourself, if you don't practice by yourself, you would not get the point. All right, so these things we've done, guys. I think you understood, right, how to do the public subnet, the private subnet, how to connect from one instance to the other instance, how to make sure if the internet is working or not. So everything we've done. So now what I'm going to do is I'm just going to terminate this because I don't need these anymore, and I'm going to close this. So the last part of this particular tutorial, the last demo, would be the VPC peering demo. So for that, we need to create a VPC. So let's just create a VPC using the VPC wizard. So I'm just going to select, let it be the same. I'm going to make this, and I'm going to make this, and I'm going to give preference as this, and that's it. So I'm going to create the VPC. So it created the VPC, it created the internet gateway, it created the public subnet, it created everything which we required for us. Okay, done. So now if I go to VPC, a VPC has been created. I'm going to name it as scalar VPC 2. So why did I create this? I just created this so that I can show you the peering demo. So going to peering connections. So we're going to create a peering connection between this scalar VPC and this scalar VPC 2. We're going to create a peering connection between these two VPCs. I'm going to go back to peering connection, create peering connection, and so name we can provide as peering practice. So the local VPC to peer with would be scalar VPC. So it's my account, another account. As I told you, you can also associate or connect to VPCs in another account, in another AWS account, but this is going to be my account. It's in the same region. You can also connect to a VPC in another region altogether, but it's in the same region. The acceptor would be scalar VPC 2. Okay, and then create peering connection. That's it. So this is more than enough to create, and then what you have to do is you'll have to accept the request. Done. So to send and receive traffic across this VPC peering connection, you must add a route to the peered VPC in one or more of your route tables. Okay, so let's modify the route table. This is the main route table. You'll have to go to routes, edit route, add route, same thing. So here it would be peering connection, peering practice, save changes. So this could be basically the IP address of that particular peering connection as well. I'm just gonna go back. And I'm gonna copy this and go back to route tables, scalar main route table, routes, edit routes, add route, add the IP, select peering connection, select the peering name and save changes. That's it. So now one more thing you'll have to do is, so this established one-way connectivity. Now one more thing you'll have to do is we'll have to basically do the connection for the other VPC. So this is what? Scalar VPC 2. So this is the, we just check. Scalar VPC 2 route. No, so this is the main route table of the scalar VPC 2. I'm going to name it scalar VPC 2 main route. Done. So in this again, I'm going to make a rule change. Edit routes. Peering connection, peering practice, save changes. So done guys, so that's it. So now if there are any resources in either of the VPC, so let's say there is an instance in this VPC and there is a database server in this VPC. So this instance could access the database server, and if there is an instance in this VPC and there is also another instance in this VPC, they can also connect. So basically like how we connected to one private instance from the public instance, same way we can connect to the instance inside VPC2 from VPC, or we can connect to the instance in VPC from VPC2. So vice versa, we can do anything we want. So these are the things guys. So we've learned about VPCs, we've learned about subnets, we've learned about route tables, we've learned about internet gateways, we learned about elastic IP addresses, we learned about NAT gateways, peering connections, and security groups we've already learned in the EC2 tutorial. And one more thing. What was the one more thing? Yeah, so the network interfaces. So we've learned a lot of things. I hope you guys understood what exactly was going on over here. So now what you can do is, so let's say I can just delete this, but it has a peering connection. So the first thing you'll have to do is delete the peering connection. So if I delete the peering connection, I think it'll ask me to remove the routes. Delete related route table entries. Yes. So now we are deleting the peering connection and also deleting the routes. So it has been deleted successfully. So now let's try to delete it. Yeah, so now we can delete it, and it will basically delete all the resources associated with it, so you don't have to worry about it. Done. It's all deleted. Okay, so now scalar VPC is there. Again, we can also delete this as well. I'm just going to click on it and delete it. So again, there is one issue because there is an elastic IP address attached to it. There is an NAT gateway attached to it. The first thing you'll have to do is go to elastic IPs, and so yeah, it's attached to the NAT gateway, right? So first we'll have to delete the NAT gateway. Delete, and then go back to elastic IPs, refresh this. So it's allocated. I don't think we'll be able to dissociate it right now. So it has to be completely deleted. Only then we can disassociate. This is a network address card. It's connected to this NAT gateway. So is it deleted? So NAT gateway is deleted. Okay, so it takes some time, so let it be. So now let's just go to VPCs and try to delete it. Yeah, so it's still saying there is a network interface. So as there is a network interface, it's not letting us to delete it. So I'm just going to open this and let's delete the network interface. Okay, so again, the network interface is attached to the EC2 instance. So in that case, we can delete the EC2 instance altogether. So done. We have terminated the EC2 instances. Okay, so now going to network interfaces. So I'm just showing you how to clean up. So the network interface has been deleted. So why it was not allowing us to delete the VPC is because there is a resource within the VPC. So if we delete the VPC, that basically means we'll not be able to use the resource. So it cannot be done. So once you don't have any resources within the VPC, only then you can delete it. Now let's try it again. Delete VPC. So it still thinks it's in use. That's the problem. Yeah, so now we can delete it, guys. And so it will delete the public subnet, the security groups, private subnet, the internet gateway, and the route table. Delete and done. Okay, so we've created VPC subnets and we've also deleted them. An elastic IP, as I told you, if you create an elastic IP and do not associate it with anything, then it will charge you. So now the NAT gateway ID has been removed from here. That basically means it's ready to be deleted or released. So I'm just going to click on release. Done. So basically we've created everything and also cleaned up everything. So this is one of the important steps when you're practicing, because as I told you, if you just leave it like that, you might get billed. So to avoid getting billed, to just practice in the free tier limit, always clean up the resources once you're done with it. So guys, let's start by first understanding what is Elastic Beanstalk. So first of all, AWS Elastic Beanstalk is a platform as a service. So that's what you'll have to know first. It's a PaaS. And why it's a PaaS, that's why we're going to see. So it's an easy to use service for deploying and scaling web applications and services deployed with Java, .NET, PHP, and other programming languages and other ways of deploying your code like Docker. And you can use various servers like Apache Nginx, Passenger, and IaaS. Okay, so you can do this with Elastic Beanstalk without having to worrying about the provisioning part, that is the infrastructure part. So you can simply upload your code to Elastic Beanstalk and it will automatically handle the deployment of your code for you. So it will basically, so capacity provisioning, that is launching servers for you, load balancing, making sure that the incoming traffic is balanced, the load is balanced and sent to the servers accordingly. Auto scaling, the number of servers are increasing whenever there is an increase in your traffic, and the number of servers will automatically decrease when there is a decrease in your traffic. Okay, so these are all done by Elastic Beanstalk itself. And then application monitoring. So after that, you can also monitor. So you can deploy your application then it'll automatically handle all the IT stuff for you. That is, it'll provision your servers, it will install everything for you, it'll balance your load, and also it'll auto scale for you. And also once that is done, the CloudWatch will also be connected to it so that you can monitor your running application and the IT infrastructure connected to it. So there is no additional charge for using the Elastic Beanstalk tool, because you're using the Elastic Beanstalk tool, but the Beanstalk tool is launching other AWS services like EC2 instances or an RDS database or CloudWatch metric or auto scaling, load balancing. So you pay for these resources. You do not pay for Elastic Beanstalk itself. Elastic Beanstalk is just a tool which lets you do this, but in the background you will get these services, right? Your servers and everything. So you're going to pay for that. So you will have to know about that. So know about that in the sense you can basically select whatever an instance you want. It's not like entire control is with AWS. You still have control to choose that. So you can select that and you can reduce the cost accordingly as well. Okay. And looking at the features, first of all, fast and simple to begin with. So the management console, so the console itself is very simple. You can just start off by working with it. So you can upload your code, or you can connect your Git repository directly to it, or you can upload directly from an IDE like Eclipse or Visual Studio. You can connect your AWS account and upload it directly from there. So it doesn't matter how you upload it. You can upload it with as a zip file. You can connect it to your Git repository, or you can upload it from your IDE. And it's also very simple to begin. That basically is, you just need the code file. You just need to know how to package the code file and then upload it. That's it. So you don't have to do anything else. Develop productivity. Elastic Beanstalk provisions and operates the infrastructure and manages the application stack for you. So you don't have to spend the time or develop the expertise. So basically, you don't have to learn how to create servers. You don't have to learn how to create databases. You don't have to learn how to load balance or auto scaling. So you can have a theoretical idea of how exactly this is going to happen, but you don't need to learn all of these because Beanstalk is handling for you. You can concentrate more on your application's code, on how to make it better, how to make it more secure, and also how to make sure your application's data is always available. So these are things you can concentrate on. That's basically developer productivity. Impossible to outgrow. So Elastic Beanstalk automatically scales your application. It doesn't need anything else. You'll just have to enable auto scaling and it'll do everything for you. And so basically, for example, you can use the metrics, CPU utilization metrics, which is already available in CloudWatch, which is connected to your Elastic Beanstalk environment, which you just created. So you can use that to trigger auto scaling actions. That is, if the CPU utilization of all your instances go above 90%, you would need another instance to handle it. So that's what you can do. So basically, it's impossible to outgrow. That basically means you will always have a server running and your application will be always available. It won't go down. Complete resource control. You have the freedom to select the AWS resources such as Amazon EC2 instance type, processor type to run the workload on that are optimal for your application. It's not that they completely select whatever server they want, whatever instance type they want. You still have the freedom to select the type of instance, type of the RDS database, type of the load balancer, how exactly you want auto scaling to work, the scaling policy, everything you can decide. But the thing is, only thing which AWS controls it, creating them, provisioning them, and deleting them and scaling them up and down. Other than that, nothing else. You can select what type of servers or what type of instances you need. But Elastic Beanstalk takes care of provisioning and managing it. Okay, so these are the Elastic Beanstalk features, guys. Moving on, let's look at the workflow of Beanstalk. This is exactly how you do it. It's very, very simple in Beanstalk. So first of all, you create the application. So that's done by you. So when you create an application, that would be, let's say, version 1. Okay, so now you're uploading the version 1 to Beanstalk. Okay, you're creating a Beanstalk application and uploading the application you created to that particular application which you have created. Okay, so you've uploaded the version. So once you uploaded it and you provided all the details like name of the application, what type of an instance you need, if you need auto scaling, how to trigger it, if you need load balancing, what type of a load balancer you need. After providing all the details, you would be launching the environment. So once you launch the environment will be up and running. Your website will be hosted automatically by provisioning a server in which your application is running on. Okay, so now Once it's running, then you will be given a console where you can manage your application, manage your complete environments, every single detail. You can manage every single parameter of your environment, and also you can connect to CloudWatch and monitor your application, monitor your entire Beanstalk application to gain better insights on how your application is performing. Okay, so now let's say you are making another addition to your application, another feature, or you're solving a bug, or you're creating another small upgrade into your tool. So in that case, what you can do, you can upload it as another version of the tool. So version 2. So let's just name it version 2. So now once you upload your version 2, version 2 would be launched into the environment, and that would be the current running application. So whenever you upload a new version, the older version would be saved and the newer version would be deployed. So if you want to roll back to your older version, you can still do that. That's why the versioning is existing. So that's exactly why we need Beanstalk. For example, let's say you are uploading like the 10th version of your application, but there is an issue, the application is not working properly. So now what can you do? If you just leave it, then people would start losing interest in your application. So you can roll back to the previous version so that you have the last stable version up and running and it's working properly. And you're now working on what exactly is the issue going on in your 10th version and making sure you rectify it before re-uploading the version. So this is exactly what you can do with Beanstalk. So this is the simplest process of Beanstalk, how you can start with Beanstalk. Okay, so now the concepts in Beanstalk are pretty basic, mostly theoretical and logical. For example, an application is what you create in Elastic Beanstalk. The application consists of all the other components. It's just one major, it's like a folder with all the other components inside of it. So for example, the environments, the versions, the environment configurations, so everything comes under the application. Application version refers to the labeled iteration of deployable code. So as I told you, every new upload of an application would be considered as a newer version. So every single upload would be considered as a newer version, as I told you, and that particular application version points to a Amazon S3 object that contains the deployable code. So you can store that code in Amazon S3, or you can just upload it from your local system and it will be stored in S3 for you. Okay, so that's what application version is. It's pretty simple. Next, coming to the environment. So even though application is the complete logical collection of everything, environment is where your application is actually going to run. You create an environment which is compatible for your application to run. For example, so it's a collection of various AWS resources. So it could have EC2 instances, load balancers, auto scaling policies, RDS instances, S3 storage, Redshift, data warehouse, so all kinds of AWS resources. And each environment runs only one application version at a time. So even though your application might have 10 versions, every single environment will have only one particular version running at any point of time. However, you can run the same application version or different application versions in many environments simultaneously. So this is where blue-green deployment comes in. So let's say you have an application, you can create two different environments. So let's say now you're launching the second version of your application. So the first version can still be running in another environment, and the second version can be run in another environment, and that could be basically sent for testing in public. So if the public feedback is fine, then you can basically keep the second version for running, and then you can basically upload a third version in the first environment. To put it simply, so let's say when you're launching your version 1, it will be running in the blue deployment. Version 2 will run in the green deployment. If version 2 in green deployment is successfully running and working and everything, and you're successfully transitioned all your customer base into green, that's the green deployment, this is version 2, then you can implement your version 3 into the blue deployment. So that now there would be another version running. So two versions would be running at the same time, and you can basically change, you can make version 3 your beta testing. You can just give access to certain users, and then once it's successfully running, then you can shift complete access to version 3, and then you can start working on the version 4 and upload the version 4 to the green part. So this is basically blue-green deployment, and that you can do with multiple environments in a single application. Next comes a platform. So a platform is basically what is within an environment. So within the environment, you can create this particular structure, all the AWS resources. So inside the AWS resources, so environment is a collection of AWS resources. It's not one AWS resource, but the platform is basically the resource itself. The platform is the operating system of the server. inside which a programming language runtime is running, a web server is running, an application server is running, and the other Elastic Beanstalk components. So it could be load balancing, it could be auto scaling, it could be S3 buckets, it could be RDS database. So all of these combine together to form the platform in which your application is going to run. Okay, so there are more concepts to Beanstalk actually. So it's a big list. You can just check out the Beanstalk documentation which AWS has provided to learn every single terminology. So I'm not going to cover every single terminology here, but obviously I'm going to show you the demo in which I'll be explaining every single step of the process so that you can understand it even better. And then you design and target your web application to a platform. So in this case, to put it very simple, so you basically design your application completely and target the web application to a platform. So that basically means you have the application already available, so you run it on a platform. So for example, if it's a PHP application, the programming language runtime you would select would be PHP. If you built it on a Linux machine and you want to run it on a Linux machine, you choose your operating system as Linux machine. If you're running it on Apache web server, or if you're running it on Nginx web server, you can select it accordingly. So the platform is up for you, so you can select whatever you want to use, and rest everything else Beanstalk will take care of. So you just select everything, and then once you upload your code and launch the environment, everything will get set up by Beanstalk. So these are the very basic concepts in Beanstalk, guys. So moving on, the Beanstalk environments. So essentially there are two different environments: web server environment and the worker environment. Okay, so once we've done with the environments, we'll be moving on to the console, and we'll be looking into how to navigate through the Beanstalk console and also how to create a Beanstalk application. So first we'll start off with a very simple application in Beanstalk, and later in the end of the session we'll also be looking into a simple project where we'll be covering all of these tools. Okay, so web server environment is the heart of the application. In the diagram, the environment is shown within the top level solid line. When you create an environment, Elastic Beanstalk provisions the resources required to run your application. AWS resources created for an environment includes one Elastic Load Balancer, an auto scaling group, and one or more Elastic Compute Cloud instances. So this is basically pretty simple. So if you look at the diagram provided over here, so this is the Elastic Beanstalk environment which is created. The Elastic Beanstalk environment's URL is myapp.elasticbeanstalk.com. So it's a simple URL, will be completely different according to your application name. Okay, so then you have your various EC2 instances. So in this case, there are 4 EC2 instances in which a web server is running. Web application server is running. Your application is successfully running within these servers. So those servers will already obviously have a security group which will act like a simple firewall, which has a set of rules which allows certain traffic inside and certain traffic outside. So you can have a security group. If you want to know more about security group, you can check out the EC2 tutorial, or you can check out the VPC tutorial, which is already available in our channel. Now coming to the next part, which is the auto scaling group. So now these instances will be created within an auto scaling group. Why? Because if they are individual instances, in that case you cannot scale them up. You will have to create it manually. You'll have to increase the number of instances by yourself and decrease the number of instances by yourself. But you do not want to do that. You want to automate that. Whenever your CPU utilization of your current instances are increasing above a certain level, you want to increase the number of servers. Okay, so for that you can use an auto scaling group, and these instances are created within the auto scaling group. Okay, and then the auto scaling group is connected to Elastic Load Balancer. So why do you need an Elastic Load Balancer? So let's say inside your auto scaling group there are 10 different EC2 instances running. What if all of the incoming connections go to just one single server? Other 9 servers are still running, but they are idle and nobody is using them. So it's a waste of money for you, and also once a particular server will be getting loaded with your incoming connection requests, and your application might crash. Okay, so because of that you need an Elastic Load Balancer which provides you various options. Again we'll be looking into Elastic Load Balancer separately in this particular course, so don't worry about that. So load balancer has multiple options and you can choose from them. So the basic task of a load balancer is to balance the load within the auto scaling group. Okay, so it basically, whenever a new connection comes in, so let's say there are 4 instances here, and let's say 100 requests are coming in. A traditional load balancer will basically work like this. The first incoming request would go to the first instance, second would go to the second instance. So in this case, if there are 100 incoming requests, each server would have received 25 requests. So that is basically a traditional load balancing, but this doesn't work in really high traffic environments, like for example Amazon.com. So there, this particular traditional environment wouldn't work. So what if somebody refreshes the page, it goes to the next server. So if there are more people on one single server, that's not a good idea. So for this, you can have a different kind of approach in Elastic Load Balancer. There is Application Load Balancer, and there is Gateway Load Balancer, which is recently introduced. There is Network Load Balancer. So Application Load Balancer simply gives you a different approach in which you can create multiple auto-scaling groups. So each auto-scaling group will have multiple servers. So each auto-scaling group can be concentrated for one feature of your application. So inside the first auto-scaling group, let's say the blog site of your website is available. In the second auto-scaling group, the video, the streaming service is available. So let's say example.com/blog will be in auto-scaling group 1. Example.com/videos would be in auto-scaling group 2. So now whenever somebody is searching for example.com/blog, they should be taken to the auto-scaling group number 1. Whenever someone is searching for example.com/videos, they should be taken to the auto-scaling group number 2. So in this case, you successfully balance the load of incoming users for particular features of the application. This way you would know how many users are using a particular feature, and also you would basically load balance it even better because they're already in an auto scaling group. If the incoming requests are increasing, the number of servers will also increase, but also as you're segregating with them as features, in that case your application would be completely balanced and it will be completely working fine. If once one particular feature is not working properly, then the other one would be working, the other users would working with that particular feature without any troubles. Okay, so this is basically a simple web server environment. So this is basically the environment which is the heart of the application, which is told without a web server environment, you cannot have a Beanstalk environment. But without a worker environment, you can still have a Beanstalk environment. But again, worker environments are basically used for backend processes. This is completely the application's front end. So you create an application. So this is to access the application. Your application is running within the EC2 server, and everything else is happening. So an incoming connection is coming. It goes through the Route 53 domain name. It does the DNS resolving. It sends the request to Elastic Load Balancer. Load Balancer figures out where it should send the request. It sends to that particular auto scaling group, and within the auto scaling group, it chooses the EC2 instance to send the request to. So once that is done, the application will be shown to the user who has searched for it. Okay, but when it comes to the worker environment, in this case, what happens is it's the background process which happens in the application. So let's say this application is a image conversion application. You're uploading an image and you want the image to be converted into a black and white image. So now once the person uploads the image and clicks on make some changes to this particular thing, so there is a button to change, so he's clicking on the change button, and then you can have a background process, that is the worker environment, which is running to make sure this particular file runs. For example, include an auto scaling group, one or more EC2 instances, and an IAM role. For the worker environment, Elastic Beanstalk also creates and provisions an Amazon SQS queue if you don't already have one. I'll tell you what exactly it is used for, don't worry. When you launch a worker environment, Elastic Beanstalk installs the necessary support files for your programming language of choice and a daemon service on each EC2 instance in the auto scaling group. So basically what exactly happens here is it creates you an Amazon SQS queue. So why do you need an SQS queue? SQS queue will basically align your incoming requests. So for example, let's say there are 100 users currently trying to change, basically requesting for an image conversion in your particular website. So now all of those requests would be added to the queue as individual messages in a particular sequence. So now that particular sequence, then the queue would be pushing one by one into the worker environment. Okay, so this is the web server environment. So once the application is running inside of this, and when they upload their image and click on it, it creates an SQS message which is stored in the SQS queue, which is sent into the worker environment one by one. And here, whatever process you have mentioned will automatically run, and then it will send back the SQS message that this particular task has been done, and then the application would be shown in the website. All the other processes can be done in the EC2 application itself in the web server environment. That is, your background processes also can be done in the same server, but again, that will cause more load on the server, right? So running the front end and the back end on the same servers will cause more problems. So in that case, it's better having a worker environment or just configuring another server just for the purpose of backend. Okay, so this is basically a worker environment which is used for the daemon and background processes. So this is basically the worker environment. It's not connected to the internet. So if you see the Elastic Beanstalk application, the web server environment should be accessible from the internet because people are going to view your website. But the background one, which is the worker environment, is not connected to your internet. Okay, so it's connected to the CloudWatch and our scaling groups. And yeah, so basically it's internal within the AWS environment and it does not go out. So this is basically the environments, guys. So that's it for the theory. If you want to learn more theoretical concepts of Elastic Beanstalk, there is a lot to learn actually. You can basically learn all the concepts directly from the Amazon documentation. As of time constraints, we will not be covering every single topic. So I just wanted to give you the brief of all the important topics in Beanstalk. And so one of the most important topics is the environments, because without the environments, nothing else could work in Beanstalk. And then I gave you the basic concepts about Beanstalk. And then we also looked into the basic architecture, right, and the basic workflow of Beanstalk. So now this is what we're going to do. We're going to open the management console, and what I'm going to do is I'm going to show you how to navigate to the Beanstalk console. Once that is done, we would be creating a Beanstalk application. So inside the Beanstalk application, we would be creating an environment which would run a sample application which is already provided by Beanstalk. So this is the first thing we'll be doing. This is to show you how to create an application, how to run, create an environment, and how to basically monitor, how to manage, how to configure your application, your Beanstalk application. So after that, we can see a manual creation, that is uploading your own code into Beanstalk. So we'll be uploading a simple hello world or a simple PHP file into Beanstalk and checking how it works. Okay, let me open the management console now. So guys, I've opened the management console. Now let's start with the demo. So the first thing you'll have to do is search for Elastic Beanstalk, or just go to all services. And over here under compute services, you would find Elastic Beanstalk, because Beanstalk is a PaaS service, but again, it comes under compute, because using Beanstalk, you're uploading your code and it will create you servers and other AWS resources. And that basically comes under the compute part, right? So compute, so you can just select Elastic Beanstalk. Okay, so this is the page which you'll arrive at. To the left, you can see there are environments, there are applications, and change history. So applications are the one which you'll have to create first. So environments are within the application, because application is the logical entity which holds the entire application, and multiple environments can be within an application. So applications should be created first, and inside the application we will create environments. And then there is change history. So this is basically about what exactly was changed in the Beanstalk application, in which environment, what exactly was changed by which IAM user. If you have multiple IAM users, I'm directly using it from the root account right now. I'm not using it from any IAM user. So that is the change history. Okay, so also you can see right now AWS Graviton, it's a instance type, which is a very powerful instance type, and it can offer up to 40% better price performance over the comparable x86 processor. So if you are going to host an application, a really powerful one, if you are going to do it for a project, so in that case you can go with AWS Graviton, but please check the prices. These are pretty expensive instances. If it's just for a practice, you can just go with the basic one, T2.micro or T2.medium or something similar. If not, if it's for a project, then you can check out the prices very carefully and then choose the type of instance you need. Okay, so then you guys know about the regions. So I'm just gonna select create application. So this is the first thing you can do. So you can see getting started, launch a web application. You can learn how exactly to do that over here. So that's what I'm going to take you through. Okay, so first click on create application. So the first thing you'll have to do is provide an application name. So I'm just going to provide it as Scalar App 1. So this is the application name I'm providing. So up to 100 Unicode characters, not including /. So / will automatically be included in the application. So you should not include that in your application name. Just provide a normal name. So why slash? Because your application would be hosted in a Linux server. If it's hosted in a Linux server, it'll have the path slash in your application's name, right? So that it'll automatically have a forward slash. So do not provide slash in your application's name. So that's the first thing. Second is the application tags. So this is more of an optional thing. You can provide one, or if not, it's not required. I'm just going to provide one, name and app. So let me provide something like HP app. Okay, so just a simple one. All right. Okay, so this is basically the application tag, guys. Okay, next option is the platform. So this is the important part. So you'll have to choose the right platform which you need to host your application. So let's say your application is going to be run in Docker. So then you'll have to select Docker. So if your application is going to run, the runtime is Java, then select Java. If it's Node.js, select Node.js. If it's PHP, select PHP. So according to your runtime requirement, select the platform. So there are so many different platforms available. So these are the available platforms: Tomcat, Ruby, Python, PHP, Node.js, Java, Go, Glassfish, Docker, and .NET on Linux and .NET on Windows. So I'm going to go with PHP. And then you can select the performing type. So which version of PHP? So let's say your application supports an older version. So you can still select the older version. It's deprecated, but it still will work for some time until it's completely closed. And then there is 7.4 as well. And then PHP is the same thing. You can select the version which you require. Okay, so I'm just going to go with the latest version. And then platform version. So this is the platform version. There is only one version available. So there is no other type of versions in the platform. So why do you have a platform version is because let's say they might make an addition, or they might install another package, or they might update the platform, and then they might have another version of the same platform of PHP 8.0. And in that case, it would be 3.3.9, which would be the recommended version, and 3.3.8 will still be available. So accordingly, you can choose the version which you need. But right now there is only one version, so there is no need to choose anything. You can just go with the one version available. And then the sample application. So I'm just going to select the sample application because I don't want to create my own application right now. I'm just going to show you how to do the entire process. Then later, if you want, you can upload your own application, right? So sample application, and then that's it. This is the information required, much more than enough. And then create application. So there are more options actually. So I want to show it to you. So let this be creating. So let me go back and let me click on create application. So scalar app 2. Sample application. So let this everything be the same. I just want to introduce you to more configuration options. So it's not that you can only select these configuration options while you're doing it at the beginning. You can also select it once the application is created. So we created scalar app 1, right? So later, once the application is created, you will still have a configuration option. You can go to the configuration and you can modify the configuration settings once your environment is created as well. So no problem with that. So let me just do one thing. So an environment is being created, right? So this is the application we've created, and the application has created an environment within itself. So you can see there's the configuration option. So this is the option where we can go and change up the settings, modify the settings. So it's launching the environment. So that's why we are able to see. So these are the things. So it has checked the health. So the environment is creating. S3 storage bucket has been created. So why do we need this? Because all the logs will be stored over there. And a target group has been created. So why target group? Because Beanstalk will be having a load balancer. So as we know about the architecture, there will be a load balancer which is connected to an auto scaling group which has all the EC2 instances within it. It can have one or more EC2 instances, but the point of contact for anybody would be the elastic load balancer. So that's what is getting created first. Right now there are no instances. New instances will be created. Okay. So now let's go back. Scalar app 2. So this was not created. So I'm just gonna let's 1 second. I'm just gonna delete it and create a new one. Scalar app 2. Sorry, Scalar app 3. Now let's come from the start. So here you can create an application, then you can open the application and create an environment. So that also can be done. Okay, so Scalar app 3, create one new. Okay, so which web server we need? So do we need the web server environment or do we need the worker environment? So I'm going to go with the web server environment. So you can see the difference also provided. Web servers are standard applications that listen for and then process HTTP requests, typically over port number 80. Workers are specialized applications that have a background processing task that listens for messages on an Amazon SQS queue. So worker applications post those messages to your application by using HTTP. So you can select whichever environment we want. We already discussed about these two. So I'm going to go with web server. Okay, so now you have the other options. So this is the options we got right. First, you can provide your own domain name over here. If not, you can just leave it. Then select the runtime. So I'm just leaving it at sample application for now, and then configure more options. So this is what I wanted to show you. Okay, so the first option is presets. So usually when you create an application at the beginning, the application will be launched in a single instance format, that is the free tier eligible format. So the load balancer, the auto scaling group, the EC2 instance, everything will come under the free tier eligible category. So you won't be billed or you won't be charged anything for creating a Elastic Beanstalk application, right? So that's basically it. And then you have single instance using spot instance. So spot instance is basically buying an instance or having a dedicated spot instance which you can purchase from AWS. So we don't have that, so you don't have to use that. If you do have a spot instance, then go with that, or you can just select it and it will automatically create one or get one for you. And then high availability. So these are again presets, guys. So high availability in the sense there will be multiple instances. High availability using spot and on-demand instances. So it will be a combination of spot instances and also on-demand instances which will get created whenever you need it. And then there's a custom configuration. So custom configuration is what you're going to select. You can basically edit whatever you want over here. You can select the type of instance, you can select the capacity, you can select whatever you need. So for example, let's say if I select single instance free tier eligible, so the available EC2 instance types are T2.micro and T2.small. If I'm going to go with high availability, 1 to 4 instances, so let me select this. Yeah, so capacity, right now there is no, so because there is only one instance. Single instance using spot instance. Again, there is nothing, but the fleet composition is spot. To go with high availability. So again, load balancing, auto scaling will be created, and on-demand instances with the fleet composition, and there would be 1 to 4 instances minimum. And then high availability, it would be combined purchase options and instances. And then finally, custom configuration. You can go ahead and edit everything you need. Okay. So you can select the type. Is it going to be a single instance, or do you want it load balanced? So once your application launches, what should be the minimum number of instances running? So let's say you want at least 2 instances running all the time behind your Elastic Beanstalk application. You can provide the minimum as 2, and according to the increase in traffic, you want the maximum to be 10. You don't want more instances than 10. If you have peak traffic, the number of instances can maximum go up to 10 instances. And then here you can select the fleet composition. You can go with on-demand instances, or you can go with a combined option of purchasing a spot instance and also having on-demand instances. So let's say I want 5 on-demand instances, on-demand above base. So again, I don't want T2.small, I just want T2.micro, because T2.micro is the only instance which is under the free tier eligible category. So if you're practicing, do not select any other instance type, just go with T2.micro for practice. Okay, so default the on-demand price for each instance type. So it will automatically figure out what instance, what cost is already set for that particular instance. So, or you can just select on-demand instances, it will automatically choose everything over here. So the maximum number of on-demand instances that your auto scaling group provisions before considering spot instances. So what basically means is, so let's say according to the increase in traffic, so for now the minimum has been provided as 2 instances. At the beginning, once you launch the application, there would be 2 instances running. So let's say the traffic is keeping adding up. So in that case, right now there are 5 instances created, on-demand instances. So the 6th instance in this case would be a spot instance. It would not be an on-demand instance. Okay, so that's basically it. Okay, so now capacity rebalancing. So specifies whether to enable capacity rebalancing feature for spot instances. This option is only relevant when enable spot is true in the AWS EC2 instances namespace, and there is at least one spot instance. So if you are going to enable this, it will only make sense if there are spot instances in your auto scaling group. If not, it doesn't make sense. You don't need it because it doesn't rebalance the capacity. Okay. All right, so I'm just going to click on let it be because we're not going to create it. I'm just showing you. And then there are two types of processors available now. Usually there was only the x86 processor available, but right now the ARM64 is also available, the Graviton processor. So now you can select what type of a Graviton instance you need. Okay, but again, remember that this is much more expensive than the x86 processor, but it provides you a better performance. But again, if you're going for only practice, just go with the T2.micro instances. Okay, so then the AMI, you can select the AMI over here. You can provide the AMI ID. So the AMI ID decides what instance, what operating system is going to be launched. So you can provide the Ubuntu instance, you can provide the Amazon Linux, you can provide the CentOS, you can provide the SUSE Linux. So whatever AMI you need, you can provide it over here. You can just copy the AMI ID from the documentation and paste it here according to the AMI you need. And then availability zones. So let's say you can provide it as any or any three. So in North Virginia, there are 6 availability zones. So if you want to use any 3 of them, then you can provide as any 3. But I'm just going to provide as any. And then you can select the types. So placement, specify availability zones to use. Okay, so you can select whichever availability zone you want. You can select all 6, or you can select 3 of them, or you can select just one of them. It's totally in your hand. Okay, so you can select any 3, and then you can select all the availability zones, and it will only use 3 from this 4 which you have selected. Okay, so that's basically what any 3 is. Then if you select any 2, it will only take 2 from these. Okay, so I'm just going to provide any, and I'm going to select like these 4. Okay, so now metric, scaling triggers. So this is one important part. So how will Elastic Beanstalk know when to increase the number of servers and when to decrease the number of servers? So that's where scaling triggers comes into place. So you'll have to select a metric which will be monitored constantly by CloudWatch, and accordingly it will increase the number of instances or decrease the number of instances. So I would suggest you to go with CPU utilization. You can select the other ones. You can select latency, you can select network in, network out, so whatever you want. So I'm going to select CPU utilization over here, and the statistic is going to be average. So if the average of all the instances, so you can also select the maximum or the sum, the total CPU utilization of all the EC2 instances available in the auto scaling group, or the average of all the instances available in the auto scaling group. I'm just going to go with average. You can also select maximum. So maximum will basically be if one particular instance has above 90% of CPU utilization, it will automatically create another instance. So you can go with maximum, or you can go with the minimum value as well. So I'm just going to provide average, and the unit is going to be percentage. Okay, because why it should be percentage is because it's CPU utilization, it's measured in percentage. And let's say whenever the average CPU utilization goes above 85%, I want a new instance to be created. But whenever the CPU utilization goes below 25%, I want an instance to be reduced. So, and again, you can select the period. So it will monitor it for a 5-minute period. If the value stays above 85% for 5 minutes, only then it will create another instance. So that way it is cost optimized. You can decrease the number of minutes it takes to evaluate that. You can increase the number of minutes as well. If you know how your application works, if you think it will be the hike in traffic would last for 5 minutes and then go away, and then there won't be any not much traffic for another hour, in that case you don't need to create another instance. You just need to survive that particular 5 minutes. So for that 5 minutes, you can basically increase the period and it won't create one. Breach duration, the amount of time a metric can exceed a threshold before triggering a scaling operation. So again, so this is the period between metric evaluations. So let's say if it's 5 minutes, so the first time it records the evaluation, it will be right now, and after 5 minutes there will be another evaluation, and then after 5 minutes there will be another valuation. So you can reduce it up to 1 minute, so it cannot go below 1 minute, so the minimum is 1 minute. And the breach interval, so this is the time which decides if the CPU utilization stays above 85% for 5 minutes, only then a new instance will be created. If it stays above 85% for 4 minutes, a new instance won't be created because the breach duration has not been achieved. So these are the configurations which you can modify. Okay, so then I'm just going to save this. I want to show you other configuration options. So database, you can create a database right from here. If you have a snapshot to create the database, you can select it. If you do not have a snapshot, then you can create a new database instance directly from here, which will be attached to your EC2 instances which are getting created in the Elastic Beanstalk application. Okay, it's pretty simple. You don't have to create an external RDS instance and then connect it. So let's say if it is in a different VPC, you'll have to do VPC peering. So it's you don't have to do that. You can just create an RDS instance within the Elastic Beanstalk application itself. So if you want to know how to create an RDS instance, check out the RDS tutorial from our channel. And then, so this is the instance type, and then you can select the software. So here you can provide the environment properties for your application. Okay, so I came back, so it's fine. And then we'll view more configuration options. Sorry, just want to go with Java. And then there is a load balancer. Right now it's not required. Okay, security, you can basically provide a key pair, right? You can provide a key pair. So if you provide a key pair, that will let you log in into your EC2 instances which are launched beyond the Elastic Beanstalk, which are provisioned for your Elastic Beanstalk application. You can select it accordingly. Okay, and then there is change platform version. So this is we've already seen. And monitoring, it's enabled. Enhanced monitoring is enabled over here. Managed updates, notifications. So you can provide an email over here whenever there is an important event happening. Let's say a new instance got created, an instance got deleted, the RDS database is down or something like that. All those notifications will be sent to that particular email address. Network. So this environment is not part of a VPC yet. So you can select the VPC and you can select the subnets for the instances and the databases accordingly. Okay, so these are basically the settings, guys. So now let's go back to the environment which we have created. Okay, so this is the environment name. Let's open the environment. So the environment is successfully running. Okay, so you can see here, right? Okay, so if the health is okay, that basically means the environment has launched successfully and it's running successfully. So this is the URL which you get. So this is the name .us east 1, which is the region it is running in, and .elasticbeanstalk.com. So the name is scalar app 1 and the environment, and this is just a particular version ID for your particular application which you uploaded. So then you can just select it, and then you can see a PHP application is running in your Elastic Beanstalk application. So your AWS Elastic Beanstalk PHP application is now running on your own dedicated environment in the AWS cloud. You are running PHP version 8.0.8. The environment is launched with Elastic Beanstalk PHP platform. So if you want to learn more about it, you can just click on these things here. You will get, so this will basically take you to the documentation, right? Okay, so here then if you want to modify this, you can modify everything right from here itself. If you want to start, let's say you made a minor change in your modifications and it's not reflecting in your servers, you can restart the application servers right from here. If you want to rebuild the environment from scratch, you can do it right from here. Let's say if there's a problem while creating, the Amazon went down or something. And then if you want to create an environment which is very similar to this, then you can just click on clone an environment, provide the name, and you can clone it. It will create a very similar instance. Similar application. Okay, so this is basically it. And also you can save the configuration which you have created with all the applications and stuff. Okay, so now let's do one thing. Let's just get a very simple PHP code which just says hello world, and then let's upload it and see how it works, right? Okay, so now I have this simple code which is just a simple HTML file with a h1 tag, which is a PHP code. So okay, so our file could just be this, or it could be this HTML file. I just saved it as index.php. So I'm just going to upload that file. But before uploading that file, what you'll have to do is you'll have to zip this file and then upload it. Only then it will work. Okay. So that's what I'm going to do right now. So let me just open. So the file is here. So what we'll have to do is we'll have to compress it. So index.php.zip. So you'll have to directly compress it. You should not basically put it in a folder and then compress it. So it has been zipped, right, guys? So now what we'll have to do is I'm just going to upload this file. So upload and deploy. So choose file. So I'll have to go here and select the zip file. Okay, selected it. You can change the name if you want. I'm just going to provide hello world 1 and deploy. And now the application will take some time to deploy, and over here you can see all the recent activities which are happening, or you can just click on view events and again environment update is starting, right? So the thing is, if this goes red and if there is a caution or a problem, then the application isn't working. So that's basically what it means. If not, the application is working. So if it comes back to a tick and a okay, then that basically means it's working. So right now it's in the info stage. Info stage is when there is an application update which is in progress. Okay state is when everything is fine. And then there would be a third state which would show a red, which would be the caution state. So deploying new version to the EC2 instances which are available. So in this particular application, there is only one EC2 instance, so that we can check out in the configuration as well. So you can see over here, let me go over here. So max is 4. Okay, so it has created a load balancer. It has used a multi-load balancing. So T2.micro and T2.small load balancing, auto scaling. So that's what you'll have to make sure before you start. Make sure that you provide the right type of configuration you need. If it's a single instance, provide it as a single instance. If you just want to go with easy way, you just want to create it and see if it works or not, then go with the way I did. Okay, so now the application, it's showing health, it's okay. So if it's okay, that basically means it's successfully running. So we can just click on this and the new application would be shown. So now you can see hello world is being shown. So that basically means we have successfully created our application and hosted it. So now this particular application could be any application, right? So I just hosted a simple static hello world website. So it could be any dynamic application. Yeah, so that's basically it, guys. So it's very simple. So you can also do the same thing. You can practice and go through with this particular demo. You can also do it. It's pretty simple, as I've already shown you guys. So that's it for the Elastic Beanstalk particular session. So we've covered all the theoretical parts and also we've covered the practical parts. I hope you understood all of this. And few things I wanted to show before I end this particular session is that the logs and the monitoring. Okay, so these are the things which I wanted to show to you guys, and also the application versions. So let me click on application versions. So here you would see every single application of the version which has been uploaded. So if you want to go back to the sample application, so let's say you have uploaded hello world 1 and let's say you're uploading hello world 2 now, and then hello world 2 is not working. So you can just select hello world 1 and click on upload, and it will do a rollback to this particular one. So you can deploy it or you can upload a new one. So you can just select it and deploy, and it will automatically deploy the older version of your application, right? So you can save the configuration as well. So right now there are no saved configurations. If you want, you can save this particular configuration. So just click here and save configuration. So what happens is, so let's say you can delete the Elastic Beanstalk environment, and later you can just open the configuration and select the configuration and launch the instance. So you can just launch the environment over here without even having to run your Elastic Beanstalk application. And then application environment, so you can just click on the environment to check out the website. This is the first option. Second one is the configuration, which we've already gone through. Third one is the logs. So right now there are no logs. You can request logs directly from here, the last 100 lines, and it will provide the log file directly over here. And you can just download the log file and check out the logs to understand what exactly went through. If there is a bug, if there is a issue, if the application is not running, in that case you can download the log file and see what exactly is the problem in your code, or what exactly is the problem in the server. And then health, so this is basically okay, or so what particular state it is, right? So it could be in okay, it could be in info, or it could be in the red one, which is the caution. So that basically means it's not working. And then monitoring. So over here, it provides you a very detailed metrics are provided, right? So detailed explanation is provided over here. So this comes under enhanced monitoring. If you have not enabled enhanced monitoring, this won't show. So I'm just going to use 1 hour time range, and it's in 1 minute. Okay. So healthy host count. So there was only one. So target response time. So whenever we launched the website, the target response time took 740 microseconds. So it was pretty quick, right? Because it's a simple website, it doesn't take long time to read. Some requests, the total was 5. Right now the CPU utilization is only 0.7% because the application is not CPU intensive, it is not memory intensive. And how much network came in, how much network went out. And over here, environment health. So over here you can see it was an OK, and then it was an info, and then it went back to OK once again. It was not in any other health code. Okay. Response time is shown here. What is the response time? So the sample application took this much, and then this one was the first time which we selected, so it took a little more time, but the second time was much quicker because the application has been already loaded for us. CPU utilization is shown here. Some requests has been shown here. When was the request being made? So this will give you a better idea of how many requests are coming into your Elastic Beanstalk application. Max networks in, max networks out, everything is provided here, and you can edit it and add another resource over here. So okay, so you want to check how the auto scaling group is working, and you want to check, say, the disk read bytes. So you can just select that and add that, and so that particular thing would be added over here. So there were 0 bytes read, so that's what is showing over here. So you can add more, and you can also delete them if you don't need it. You can just click on the X and it'll get deleted. And yeah, so this is basically the monitoring part. And then you can set up alarms. Right now I'm not going to go into it. We'll check out that in the CloudWatch tutorial. And then you have managed updates and you have events. Okay, so events are basically, which I showed you, right? Events will show you what exactly is going on in the environment. These are the different types of events. So debug, there is info. So most of it was in info, and there is OK, which already our application is in info and it's not a particular event. And then there is warn. So warn basically means there is some error, but your application is still working. But error or fatal basically means, so error basically means your application is not working at all. Fatal means your application is completely not running. So these two are the severity. Okay, done. So tags, we already know what tags are. So I've provided certain tags. Over here, this is the environment value. So you cannot change that. You cannot change the environment name. You cannot change the application name. You can add other tags to it. Okay, so this is basically it, guys. I think I've covered everything under Elastic Beanstalk, how to upload, the health, monitoring, platforms, versions. Yeah, so I've basically covered everything in Elastic Beanstalk. That's it for this particular topic, Elastic Beanstalk. We'll be covering more topics in this particular tutorial. So guys, the next tool we're going to look into is CloudWatch. So CloudWatch is basically a monitoring tool. So we'll be learning this, and then we will learn about auto scaling and elastic load balancing. So we just completed Beanstalk. So while we were learning Beanstalk and other tools like EC2, RDS, we saw the monitoring tab which had some metrics, right? So you get the metrics from CloudWatch. So that's the tool we're going to look into. So CloudWatch basically monitors your AWS resources and the applications you run on AWS in real time. So you don't have to set up your own monitoring tool. AWS already has an inbuilt one, which is CloudWatch, and it monitors all the AWS resources in your AWS account in real time, and you can basically get those metrics and track those metrics from the CloudWatch dashboard. So the homepage automatically, so once you open CloudWatch, the homepage will automatically have all the metrics for every AWS service you use. So you can select the AWS service and then go to one particular, let's say you want to check metrics for all the AWS services used all together, you can check that. If not, you can select a particular resource and then check that particular resource's metrics. Also, you can additionally create custom dashboards to display metrics about your custom applications and display custom collections of metrics that you choose. Then you can create a dashboard which will have various metrics which you just want to be there in those particular dashboards. For example, let's say you created an application which is using around 4 different AWS resources. So you just want to see around 2 to 3 critical metrics in the dashboard of every single service. So you can create a custom dashboard in which all of these metrics are shown and are available. Okay, so that's what you can do. So this is basically CloudWatch. There are certain concepts within CloudWatch that we will discuss. So this particular diagram pretty much summarizes the entire operation of CloudWatch, right? So Amazon CloudWatch, there is collect, monitor, act, and analyze. So Amazon CloudWatch, complete visibility into your cloud resources and applications. It's the tool which gives access to the AWS resources. Okay, and then collect. The first thing CloudWatch does is it automatically collects the metrics for you and the logs for you, and it stores in. So basically, it keeps showing that in real time. And then, so by using CloudWatch, from the collected metrics, you can monitor and track the services. So while you're tracking the services, if you want to create a trigger or create, which is provided here as an act, an automated response to a certain task, you can do that. For example, CloudWatch events or auto scaling. So auto scaling in this case, what will happen is, let's say whenever the threshold goes above, let's say 80%, the CPU utilization, you want one more server. If the CPU utilization goes lesser than 20 to 30%, then you don't need that one more server. Okay, so you basically want to terminate it. So that's what act is. And then comes analyze. So use 1 second metrics, extended data retention, and real-time analysis, and CloudWatch metric math. So you can also enable analyze. So basically what happens is it will charge you a little more. There is something called enhanced monitoring, which will provide you even more metrics and better analysis of the tool. And so with this particular data, you can send this data to an external source and use it there. You gain application monitoring through CloudWatch, which is running in AWS. You gain system-wide visibility. That is the entire AWS account can be monitored using a CloudWatch tool. Doesn't matter which region, it works for every region. Resource optimization. So according to the metrics and the tracking, you can understand how a resource is performing, and accordingly you can set up your resource like that. You can optimize your resource for that particular task. And then unified operational health. So this particular thing is, once you gain all this, so unified operational health is the entire operation, the entire architecture is working properly without any fault, and it's not going to crash, or it's going to be highly available. So this is the basic of CloudWatch. So now, how does CloudWatch work? So Amazon CloudWatch is basically metrics repository. So it basically is that a repository which has various metrics of all the AWS services which you are using. So it automatically collects and has the metrics. You can just go to CloudWatch and view those metrics. For example, over here, let's start from the left side. No, I just wanted to say this. Okay, an AWS service such as EC2 puts metrics into the repository, and that particular metrics can be retrieved using statistics, okay, from the management console or the consumer statistics, or you can use these metrics in order to set up an alarm which could send an email, or which could basically create auto scaling. Okay, so now looking at the diagram, it starts off with the resources or your custom data. So let's say you are connecting your own on-premises data, on-premises server. CloudWatch can still be used to monitor it. So those metrics will be available in CloudWatch. So once the metrics are present, you have various things to do. You can generate logs, you can create an alarm, you can use the available statistics and put them all together and create a different statistic and download it. And yeah, so you can do all of this. So this is the basic architecture. The metrics comes in from the resources which is stored in CloudWatch. Using the metrics, you can create certain triggers and alarms, or you can download them as statistics where you're putting multiple metrics together. So this is basically how CloudWatch works. CloudWatch components. Some of the important components are namespaces, metrics, dimensions, and alarms. So coming at namespace is a container for CloudWatch metrics. For example, let's say EC2 is a resource, right? For EC2, there would be a namespace. So it would be like AWS EC2, or there would be a namespace under which you can find all the metrics for the EC2 resource. So that's basically namespaces. Metrics in different namespaces are isolated from each other. So the metrics from different applications are not mistakenly aggregated into the same statistics. Okay, so even though it's AWS EC2, inside that you will have segregations of, let's say you have 10 servers. For all those 10 servers, you will have different set of metrics so that you don't get it jumbled. Okay, and then metrics are the fundamental concept in CloudWatch. A metric represents a time-ordered set of data points that are published to CloudWatch. So the time will be provided here, and the data points will be provided here. So accordingly, it will give you a graph. And think of a metric as a variable to monitor, and the data points are representing the values of variable over time. So whatever variable it is in the y-axis, the x-axis is always going to be time. So everything is going to be compared with the time, right? And yeah, so you're basically monitoring a particular value which is against time. That's it. And then coming to dimensions, dimensions is a name or value pair that is part of the identity of a metric. You can assign up to 10 dimensions to a metric. So inside a metric, you can assign multiple dimensions from various different resources. So let's say there are 10 EC2 instances. You want to compare CPU utilization of all of those instances. You can now put all of them together. So there would be 10 dimensions within one particular metric. So that's basically it's a dimension. And finally, coming to alarm. So from the name itself, it's waking up something or triggering something or initiating an action. Normally an alarm is used so that you wake up, get up. So that's basically it, initiating something. So you can use an alarm to automatically initiate these actions on your behalf. And an alarm watches a single metric over a specified period of time. So let's say you want to watch CPU utilization for 5 minutes of time, and whenever the CPU utilization goes above 80% and stays there for 5 minutes, then you want to create one more instance. So this particular statement could be converted into an alarm. An alarm could be created for this exact same purpose, and it performs one or more specified actions based on the value of the metric related to the threshold over time. So these are the very basic components. We'll learn about more components when we are basically doing the demo. We will understand it even better. CloudWatch homepage. So this is how it's going to look, but they've used a lot of services. So that's how you are gaining all these Lambda aggregation, duration, error report. There is a custom metric which is in the default dashboard, custom metric 2, custom metric 5, and then RDS Postgres, right? Throughput, CPU on application. What is the CPU utilization in the application? So basically we can change the name over here also. So you can give any name you want to the alarm. And yeah, so this is the basic dashboard which will be presented with, and then you can create your own dashboard separately, which will be an option in the left side once we open the dashboard. So yeah, so that's what we'll be covering in the demo, guys. So yeah, so the next we'll be looking into the demo. So before that, I hope all of this is clear. And so now, which is the tool which we'll be using for logs in AWS? Basically for API tracking, API management and logging, which tool do you think would be used? Okay, I'll give you a few options. So is it CloudWatch? Can we use CloudWatch for API logging? Or is it CloudTrail? Or is it Athena? Or is it Redshift? CloudWatch, CloudTrail, Athena or Redshift. So that's it, guys. So we'll look at the demo now. So guys, let's start with the CloudWatch demo. Let me first open the CloudWatch console. So CloudWatch, monitor resources and applications. Okay, so now in the North Virginia region, obviously it will show all the metrics for the North Virginia region, but I do not have any services or any resources running currently. So because of that, you cannot see if any recent services are available there. And one more thing is that, so this is a new interface. Let's see what's different. Okay, it's pretty much minimalistic version of it. So yeah, so if you have any recent alarms, that and all will be shown here. If you have any metrics which you wanted to be shown here, which can be shown directly right here. And then the other things which we'll have to discuss. The first one, we already know about dashboard. So over here, you can see that I have some dashboards which are available. Monitoring dashboard, succeeded builds, failed builds, and YouTube live dash. And yeah, so basically these are old dashboards, very old dashboards. Let me just show you. So I'm just going to delete it. Okay, so dashboards where you can create a dashboard and add multiple metrics in one single dashboard. You can increase or decrease the size. You can add relevant metrics. You can add metrics for a particular EC2 instance, and you can do all of that. Okay, so I'll do one thing before we move on. I'm just gonna create an EC2 instance so that I could show you how it is reflecting in CloudWatch, right? So I just wanted to do that. So I'm mostly gonna leave everything to default. I'm not gonna change anything. Review and launch. I already have a key pair tutorial key in my laptop, so I'm just going to use the same. If you want to know about key pairs, how to create them, how to use them, then check out the first part of the video. If you watch the first part, which is the EC2 part, and then you can come back over here. So I'm launching the instance. Let it be. Okay, now let's go back to CloudWatch. Alright, so now then there are alarms. Let me explain them one by one. I already gave you a simple explanation about alarms, but let me give you a better one. Okay, so now alarm has three different states: alarm state, insufficient state, and OK state. So alarm state is when the threshold which you have provided has increased or decreased, so according to the condition. If the condition you have provided in the alarm is true, then that basically means it's in an alarm state. And then coming to insufficient, let's say the resource is stopped. If the resource is stopped, then metrics won't be getting generated because there is no way of monitoring a stopped resource, right? So if there is no data to evaluate, then in that case, but still the services or the resource is available, then that is insufficient state. Or when you start or create any alarm, it will automatically be in insufficient state, because once you create an alarm, it won't have the right data points to start with. So first it will take a minute or 5 minutes to gather all the inputs, and only after it gathers all the data, it will change to a OK or an alarm state according to the condition. So if it is within the threshold limit, in that case it will be in an OK state. So alarm state is when the trigger happens. Okay, so these are the three different states in alarms, and you can check out if any alarm which you have created is in a alarm state, it will be in the alarm state. Then you can check out alarms which are in OK state and which are in insufficient state. So yeah, any state is basically, you can see all alarms. And what type of alarm is it? Is it a composite alarm or a metric alarm? And there is one more type of alarm, which is a billing alarm. So let's say your company has decided that $1,000 per month is the budget for AWS after certain considerations. So now let's say you want to exactly know when you are nearing $1,000. So you can set up a billing alarm which will notify you when it's at $800 or notify you at $850. And yeah, so basically whenever you want to get notified, you will get notified in email notifications. So you can provide the email where you want to get that particular mail. So now I'll be also showing you how to create a normal alarm and also a billing alarm. Okay, and then next, coming to logs. So logs are basically groups of logs generated for every single aspect of a resource. So over here I was running a Lambda function, and let's see. So these are basically the logs. Whatever is provided in the code will be run. So these are older events, so that's what it's showing here. So as they are older events, it's not able to process it because it's very old, it's 2019. So let's see if there is something which happened. Let's see this 1 month ago. Even this looks pretty old. Okay, retention period is 1 month. These never expires. Let's see this. Okay, so this is a log stream. So within a stream there will be multiple events. Yeah, so basically if you give the time, all the logs will be shown. So it's according to the date when you run it, right? So if you run it from the November of 2020 to January of 2020, all the metrics will be available only within that period. So that's why it's not being shown here. And log insights: from the derived logs, you can basically run queries in order to find certain, let's say if there is an error and you want to check what are the different types of errors, you can create a query for that and you can run a query. And when you're running a query, you can select on which log group you want to run. So there will be a log group. Inside log group there will be multiple log streams. Inside each log stream there will be various log events which are individual tasks, and you can basically query an entire log group, or you can query multiple log groups. So that's what you can do using log insights. I think it's a really useful tool when you have lots of logs getting fed into CloudWatch and you want to basically query them. Before, the case was that you can download them and then query them using another tool, but now as AWS themselves have brought in the logs inside, so it's pretty simple for you to just create a simple query. You can just check out how to create a query and then just use it over here. Okay, so let's say right now there is nothing, so I don't think there will be any result. Let's see. Yeah, no data found. So as there is no, so the last 1 hour there would be obviously no data found. Let me do one thing. So let's provide it as 2019 0601. I will provide the same over here, but it will be 2020 and 06 again 07. Okay, so let it be the same. Let's apply and run the query once again. Let's see if there is any data at that particular point of time. Yeah, so there was data at that point of time. Now you can see all the logs are getting run, and so fields are timestamp and message, sort the timestamps according to, so they are taking all the timestamps, they're checking out all the descriptions and basically sorting them according to the description, and this is the size. So this is the size of the files. Over here we can basically quickly zoom in and check. Let's look at the visualization. So those are the logs. I think we can add this particular command. Let's see. Yeah, so you can create a visualization with that particular simple thing, and you can also change it accordingly. So you can provide a line graph, a stacked area graph. So I don't think pie chart would work with this. Oh, it works. Okay, but the thing is that it would be individual queries, so it's not useful. A pie chart won't be useful in this case. Okay, so this is basically it, guys, in this case. Now moving on from logs, you have metrics. So in this case, you can check all the metrics. So I'm running the EC2 instance, right? Let's go inside and check. So if you click on EC2, it will give you two options. It could be the EC2 instance could be within an auto scaling group, or the EC2 instance could be within an individual instance, per instance metrics. So right now we have individual instances. We do not have auto scaling group. So now let's check out the instance ID of the instance we created. It is 2B46 at the end. So let's see if there are okay, so 2B46 over here. So you can see this one, right? So you can basically add that to search the instance ID of your instance which you just want to see the metrics for, and it will only show the metrics of that particular instance. Okay, so that's what we are seeing right now. And for example, like if you want to see, if I click on CPU utilization, let's see the CPU utilization when it was created was 0.169%. Now it is at 0.067%. Okay, and then network in. So you can select multiple metrics. It will anyway, as it is according to the time, it doesn't matter. So the network input goes from 391 to 781 bytes. Let's compare it with the network output. So the network in goes to 781, and the network output from 160 went to 523 bytes within this particular time. So it was created at like around 448, and within 5 it went to this. So the thing, one more thing you'll have to understand is this particular timing is UTC, not the local time zone. So according to your time zone, you'll have to increase it. So I should basically do plus 530 from this particular time, current time, which will show here. Basically you can use the GMD. And then explorers. So again, so this is basically exploring every single aspect, and you can create, yeah, so over here you can create a metric. So basically choosing an aggregate, choosing a resource, and over here you can see it will create a graph over here according to the incoming data. So you can basically create charts right in the CloudWatch Explorer itself, and you can add these charts to the dashboard. So before, the option was to only add the metrics directly to the dashboard. You could not add these kinds of charts or graphs or anything. So in this case, you can start doing that. You can create a graph over here, and you can add that graph to the dashboard which you have. Okay, so and then there is streams. Yeah, you can create a metric stream as well, like how you create a log stream, and you can store all that data in one single entity. And then there is events. So events has been renamed to event bridge. So it's basically like creating an event, and when this particular event occurs, another event will be triggered. So that basically is CloudWatch events. So I'm not going to cover events in this particular session because we'll have to look more into important topics, because that's what this particular tutorial is about. I wanted to give you guys a short and crisp course or a video which will make it easier for you to learn and follow through the entire AWS course. Okay, so application monitoring, over here you can see again they are checking for traces. If there is any application running within the account, so it will basically check and show over here, and trace status, response time, HTTP method. So this is basically taken in from X-Ray. It's a new service provided by AWS, which is AWS X-Ray. So what they basically do is you can connect them, or you can attach them to a particular application. They'll monitor your application, this particular tool, and it will give you all these details back. So you can understand how your application is performing, and accordingly you can make changes if you want to make. Okay, so this is basically it in CloudWatch. And resource health, you can see over here. So you can see all the EC2 instances over here, and if there are any EC2 instances which are in alarm. So if there are list view, so currently there is only one EC2 instance with a very less CPU utilization. So this is that particular EC2 instance. So if let's say there are hundreds of EC2 instances, you can see the entirety of EC2 instances over here, and you can see the CPU utilization each of these instances right here. Okay, so you can apply the filter, you can apply multiple filters, like you just want to see the instance state, that's the running instances or pending instances, and then you can sort according to the CPU. That is, it will show the lowest CPU utilization to the highest, or the highest to the lowest. So accordingly you can check out over here, and yeah, so you can basically check out EC2 resource health completely over here. I think this is a really useful tool if you have multiple servers running and if you want to constantly have monitor on them. So if you're an administrator, this would be a really helpful tool for you. Okay, so now I'm going to show you how to create a dashboard, and then once we do that, then I'll show you how to create an alarm. So once we've done that, we'll move on to the next topic, auto scaling. So we'll learn that, and then I'll show you how to create an auto scaling group, which in turn will be connected to an alarm, which will help in creating more or lesser instances. Okay, so create dashboard. I'm going to name this dashboard as, say, practice number 1. Create dashboard. So dashboard creation is pretty simple, guys. Do not worry about it. So just provide the name and click on create dashboard. It will create one. Then you will be provided with multiple widgets. So there is line, stack area, number, bar, pie. So if it's a resource and if you just want to check out the latest number for that particular metric, go with number. Otherwise, number is just a single number which will get displayed over here. And if you want to compare two resources, or if you want to compare a similar metric of the same resource, go with a bar chart. Again, same thing. If you want to compare 2 different or 3 different resources on one metric aspect, let's say you want to compare the CPU utilization of 3 different instances, something similar, so you can go with the pie chart. And then a custom widget, you can code widgets using Lambda. You can create your own widgets and connect over here. And then there is text, free text with markdown formatting. So this is just the text. Logs table, you can see the entire logs table over here. It will keep on updating. And if you have multiple alarms, you can also have the alarm status over here. It will show if it is in an alarm state or OK state or insufficient state. So let's say I'm clicking on line. Let me go to next. So what do I want to choose? Where do I want the data to come in from? Do I want it from the metrics? Do I want it from the logs? So I want it from the metrics. So I'm going to configure. Okay, so first one I'm going to provide it as EC2 metric. Okay, so I'm going to the EC2 instance, per instance metrics. I want it for the instance which is currently running. So this is the instance which is currently running. I'm adding it to search, and what I'm going to do is I'm going to add network in and network out over here. So you can see, right, network in went up and came down within the last. So you can basically reduce the timing. Custom, let's make it 15 minutes. We can make it 30 minutes. Yeah, so you can see metric over here. Once you added the right metrics, let's say you want to compare it with another EC2 instance. If that particular EC2 instance is available, so right now there is no other EC2 instance available. There is one which is a really old one. So let's say I'm adding this to search, and I'm adding this particular data in. So you can see this, right? So it will be in this color, but again, this particular data is not available because this server is not running right now. So accordingly, you can just put in the required metrics and create the widget. So the widget will be shown here. Then you can increase the size of the widget, you can do alterations, you can delete it, you can enlarge it. If it's completely running and you want to see the data in values, you can download it as a CSV file. If you want this legend, you can keep it or you can hide it. You can change the type as well, so you can give a number, it will show the latest number, and then again stacked area, bar chart. So bar chart won't be helpful in this case because it's not against time. Pie chart, so how much network input and network output, so the percentage could be seen here. So this is pretty helpful if it's a instance which is having a lot of network input and output. So you can add more widgets, that's by clicking on add widget, and once you've added all the widgets, you can basically save the dashboard. And over here, live data, do not override or on or yes. So you can basically make sure that you also only use live data, or if you don't want to use live data, if it's fine for you if there is a slight delay, but more accuracy, in that case you can just go with just do not override, it will be fine. You can make it the favorite dashboard, you can share the dashboard with another user via, so if you want to share it publicly, it will basically create, let's say, a URL which can be viewed by everyone, so you can just do that and share it with people who want to view it. Okay, so yeah, so then you can just click on save dashboard, it will be saved, and under dashboards you will always see this one available. So you can share it as I told you. So this is basically dashboard, it's pretty simple just for you. Okay, so now let's create an alarm. So to start creating an alarm, so before moving on with that, I just want to show you how to create a billing alarm. Okay, so to create a billing alarm, just come to the billing part and click on create alarm. Let's say I want to see I don't want to see the estimated charges. I want to use a different metric. You can just provide a different metric over here. Let's say the actual cost. If you know a metric, you can just check out and put it over here. Yeah, so what I'm going to do is I'm going to go back and go to metrics. All, there will be billing metrics here. I'm just going to close this. There will be billing metrics. Where is that? Yeah, by linked account and service. Yes, I want it by the linked account. Not, you can also check out the cost for individual services. Over here you can see, you can check out the cost for individual services as well. You can check out the total estimated charge as well for your account, how much it's going to be. So you can see, right, it was at $0.17. Now the estimated charge has went up to $0.29 according to the usage which I'm doing. Yeah, so then here it's according to the linked service. Then there is linked account. You can check out the estimated charges connected to the linked account. So yeah, so this is basically the actual charge which you see here, the orange one, and the blue one is the estimated charge. So it's pretty similar, I guess, even though there's a small there are small gaps here and there, but they are pretty similar. But again, yeah, so this is basically it. So now let me go back to the billing alarms. Create alarm, estimated charges, USD. I wanted to constantly monitor it for let's say 1 hour, not even 1 hour. So as soon as the point hits a certain limit, I want it to be the threshold to be working. So I'm just going to select 5 minutes. So then you can select, so you can select the type of statistic, whether it should be average or maximum or minimum. So it's just going to be maximum for me. So whenever it reaches that particular category, it will basically stop. It will basically send a notification. So you want it to be a static value or an anomaly detection. So let's say if it's going like $1, and the next day it is $2, the third day it is $3. So that's a constant increase if you're using the same similar services. But if there is suddenly a rise to $50, then that basically is an anomaly, right? Yeah, so that's what you will have to check in anomaly detection. Accordingly, you can provide the anomaly over here. So let's say there is a sudden increase in like $15 from the estimated charges chart, then it will automatically use the greater or lesser than threshold, or if it just to be greater than or just to be lesser than. So you can use an anomaly detection if you're not sure about it. But if you're not sure about the maximum, let's say $1,000 is the highest for me. I don't want my budget to cross $1,000, so I'm going to provide $800 here. So whenever it goes equal to or greater than $800, I'll immediately get notified. So data points, yeah, it's 1 out of 1. Okay, next. So now I can, as I told you, right, you can provide an email notification. So you can send a email to a particular user. So whenever it's an alarm state, that is the thing goes above the estimated count, then that will basically trigger an alarm. So now to show that, what I want to do is I want to remove this. So the estimated charges provided here, maximum is 0.29, right? I'm going to make this 0.2. So that will basically automatically trigger my alarm. So I want to show you, right, if it's working or not. So yeah, so that will automatically trigger my alarm, and I can show you the outcome if I got the mail or not. Okay. So yeah, so you can see, right, it's over here and the maximum is over here, and I want to make it 1 minute. So the data point will be checked for a minute, and if it's greater than or equal to 0.2 USD, then it will automatically trigger the alarm. So next, you will have to select an SNS topic. So right now I don't think, let me check if there is an SNS topic connected to my email ID, older email ID. Let me check. No. So let's just go back here. Let's just create a new topic. I'm going to name it as scalar topic, and I'm going to provide the email ID over here. I'm just going to provide my personal email here, and I'm going to create a topic. So the topic is the main topic, and under the topic you can have multiple subscribers. So subscribers are basically the email IDs. So I'm creating this topic, and this topic, so this is the mail ID where I'll be getting the email sent to. So now one more thing you'll have to do is, so if I come here, you can see the pending confirmation, right? I'll have to open the mail and confirm subscription. Okay, so you would have received a mail and you should just click on confirm subscription, and that is basically it. So now if I refresh this, it should show it has been confirmed. Yeah, so once it's confirmed, you are good to go. So you can see here, right, add auto scaling option. So this is what we'll be doing using auto scaling. We'll be adding that auto scaling action. So coming to next, alarm name, I'm going to give it as billing. Next. Yeah, so we provided pretty much everything. So if it is beyond for a minute, then I'll be sent a mail to that particular topic which we've created. So I'm creating this alarm. Okay. As I told you, immediately after an alarm is created, it will be in the insufficient data state. So the estimated charges are being checked for an entire minute, and if it's greater than or equal to 0.2, in that case I will be getting a notification right here. Okay, so let's see. So we've created it. We'll see if there is a new mail coming in. So I'll start with the next alarm, the regular alarm. Okay, so I'm going to click on create alarm, select metric. So then you can select the appropriate metric you need. You can also directly create a billing alarm from here. Then there is EC2 per instance metrics. So I want to create an alarm for the CPU utilization of the instance which is running. So select metric. So right now you can say 0.16 to then 0.08, right? Yeah, so we were here. So now let's say it's been time. Let's see if there's a new notification which I have received. So it's still in insufficient data, estimated charges. So the estimated charges is higher than the current limit. So there should be a mail being sent once it goes to alarm. Okay, so now let's concentrate on the in alarm. Let's do that, and then let's basically move on to the next part. Okay, so now, yeah, create alarm. Sorry, I closed that. EC2 per instance metrics, CPU utilization, not this instance, CPU utilization, select metric. So CPU utilization suddenly increased in the server, like from it went to 0.22%. Now I want the period to be 1 minute. So if it goes above, let's say in this case, let's make it 0.1. If it goes above 0.1, then in that case I want it to be, if it continually stays above 0.1 for 1 minute, then I want it to do something, some type of an action. But in this case I'm not going to add an auto scaling action because I do not have an auto scaling group. So I'm going to use a EC2 action, and whenever it does that, I want to terminate the instance automatically. Okay, so that's what I want to do. And also at the same time, I want to send an email to the topic which I created regarding this particular action. So if it's terminated, then I need that. Okay, I'm just going to name it as terminate instance next and create alarm. Okay, so this alarm also has been created. So this is the billing alarm is still in insufficient state because there is not enough data for it to conclude that these are going to be the charges, because I don't think there is much charges in my account. So that's the exact problem. But again, let's say you can create an alarm, you can increase the data points as well. So accordingly, it will basically, yeah. So let's say if your maximum budget is $1,000, if it goes above $800, you want it to send you a mail. So now accordingly, if it goes above $800, it will send you a mail. So this is how you can create a billing alarm. You can create a billing alarm with various, you can create another one also. You can create multiple alarms, so it doesn't affect you in any other way. So then you can just click on actions and delete it if it's not required. Then even this is an insufficient data right now, so it will take around 5 minutes in order to show that. So if there is a increase over here, so if you have an auto scaling alarm, if you want to hide it, you can hide it if it has an auto scaling thing. So this is basically a metric alarm. We do not have any composite alarms, so you can also create a composite alarm if you need it. So any type. Okay, so we created an alarm, guys. So basically if it goes to alarm state, then it will send me a mail and it will terminate the instance which is running. So it's still running. That basically means it has not yet done. So now there is an alarm here which we created and attached it to the instance, right? So now that would be shown in the monitoring part. So CPU utilization is given here and we have attached an alarm. So one alarms has been is successfully running, but let's see, I think it will be in OK state. Yeah. So why is it in OK state? Because so this is the limit we've given, right? 0.1, but the alarm went below that, so it is under the threshold value. So that's why it's not getting terminated. So let's do one thing. Let me go to edit. Let's make it even lesser than 0.066. Let's make it 0.02 and update alarm. So it's much lesser than this and it won't go below that. So now once it keeps checking and once the data stays above this threshold value for a minute, so in that case then it will start, let me close this, then in that case it will terminate the instance and also will send me a mail over here. Okay, yeah, so let's wait until that happens because it will take a minute. So I'm just going to pause my recording and then we'll meet once it is in alarm state. And if you see here and it's showing again, the alarm status has been changed. So let's see what is happening. So it's an insufficient data, it's trying to collect the data. So this is, you can see what is happening. So this is the part. Right now there is insufficient data. It's still waiting on data to be given to it. So once data is available, then there would be a change in the alarm state. Okay. Yep. So whenever there's going to be a change, it will start terminating. Okay. So now you can see the data point is available. So it will most probably go to an alarm state soon. So now you can see it is shutting down, right? Because the alarm is in alarm state. Let's refresh this. Yeah, so it's an alarm state. Why? Because the limit we provided was 0.02 and this is above 0.02. So that basically means it understands that the CPU utilization for the instance is above this. So according to that, it will do the action which we've told it to do. The action we told was to shut down the instance, that is terminate the instance. So that's what is happening over here. So this is basically the benefit of an alarm, guys. So I hope you understood. Let's see if we got a mail as well. I don't know if it is in the spam. No, the mails are not sent here. I think it will take some time to get sent, but we know the alarm is working in this case, and you can basically check the alarm for a certain time period. You can keep watching. Okay, so this is basically it. So again, it went to an insufficient data state because for another 5 minutes you won't be able to see new data. And yeah, so it automatically terminates the instance, so I don't have to terminate it. Okay, so now let's move on to the next tool or the next service in this section, which would be the auto scaling, EC2 auto scaling service. So guys, now let's start with Amazon EC2 Auto Scaling. So we discussed about CloudWatch, we saw alarms, right? So the next possible topic which we should learn, and that's what I think about, is auto scaling. Because using alarms, you can create certain scaling options, right? I told you that according to the alarms, if the threshold is over this, new instances will be created. If the threshold is below this, new instances will be deleted. The oldest instances will get deleted. So these are the things which we'll be doing in auto scaling. So now using CloudWatch alarms and combining it with auto scaling, we can achieve that. Okay, so now Amazon EC2 auto scaling helps you ensure that you have the correct number of Amazon EC2 instances available to handle the load for your application. You create collections of EC2 instances called auto scaling groups. So one auto scaling group is a collection of EC2 instances. It could be 2 or more EC2 instances. Sometimes it can be even 1 as well, but it would be inside an auto scaling group, so that whenever more instances are getting created, everything will be, all the instances, all the EC2 instances will be in the same auto scaling group. So why auto scaling group is because if, let's say, in the auto scaling group there are 4 instances and each instance can handle 100 users, so there are 400 users using the, let's say, the website, and it's working fine. Now there is another 100 users trying to access the website. So now there are 500 consecutive visitors in your site. So now 4 servers cannot handle 500 users. So auto scaling group, according to the CPU utilization which is being held, it will automatically create another instance to accommodate the incoming extra traffic. Okay, so now, so this is within the group, that's why you are able to do this. And now let's say now it's only 300 users, then it will monitor it for like 5 or 10 minutes according to the time you provided. And if it's lesser than, if 300 users, 200 users have reduced, in that case the CPU utilization will come a little down, right? So accordingly it will terminate those instances. So this is exactly what will happen in Amazon EC2 auto scaling. Okay, yeah, so basically this is auto scaling, guys. And now auto scaling, explore your applications, discover what you can scale, choose what to optimize, and track scaling as it happens. So basically, according to the application, you can use various methodologies, like you can implement your own architecture and making sure that it's highly available and even looking even better, and discover what you can scale. So if you can scale your EC2 servers, if you can scale, so in EC2 auto scaling you can only do that, but there are scaling for every single AWS tool which is a compute tool. Like let's say RDS, you can you can scale the storage. You can, same thing goes to S3, you can scale the storage. In Beanstalk, it will automatically scale the number of EC2 instances and storage or whatever services or resources you need. It will automatically scale it. Choose what to optimize. You can optimize the cost by like strictly maintaining your rules. If it's more of a internal based application, then you can strictly maintain cost, because it's an internal application and there are not going to be many users using it. Only the company members would be using it, so that it could be, let's say, you can cost optimize it. So in this case, if you want to provide the best experience to your customers, then you have to performance optimize it so that your application is working really well. And finally, track scaling as it happens. So scaling, you can see that a new instance is getting created. You can see the older instance is getting terminated. So you can see all of that live in front of your eyes in the AWS console. That's what they mean. So coming to the second one, you can specify the minimum number of instances in each auto scaling group. And Amazon EC2 Auto Scaling ensures that your group never goes below the size. If you specify scaling policies, then Amazon EC2 Auto Scaling can launch or terminate instances as demand on your application increases or decreases. So this is pretty simple. In this case, what they mean is, so you can provide the minimum number of instances. So let's say in the auto scaling group, you at least need 2 instances running at all time. You can provide the minimum number as 2. So even though nobody is using your website, there would still be 2 servers running at any time, because the minimum number you provided are 2 instances. And if you specify scaling policies, then EC2, according to the scaling policies, they will launch or terminate instances on demand according to your application's need. So if there is demand for the application, if it increases, then it will automatically require more servers. It will launch more instances. If the demand decreases, in that case, they will terminate the older instances. Okay, so this is basically the introduction to auto scaling. Coming to the next point. So let's take an example. Let's say as a minimum size of 1 instance, okay, and a desired capacity of 2 instances. So desired capacity is different from minimum size. Why? Because desired capacity is the optimal number of servers. So at any time you would want optimal number of servers to be running, but if the CPU utilization or any other metric is at the very lowest, the minimum size could be 1 instance. There could be 1 instance running at that particular time, and a maximum of 4 instances. So 4 instances, so basically there will always be a maximum of 4. There won't be any more instances getting added, even though your application's CPU utilization is going higher or your demand for your application increases. If you provided maximum as 4, the number of maximum servers which will get created is 4. So now the scaling policies that you define are just the number of instances within your minimum and maximum number of instances based on the criteria that you specify. So the minimum size would remain still. Desired capacity, if it's running well, everything is fine, there will always be 2 instances running. So now you can scale out as needed. So let's say at any point there would be 2 instances running. Let's keep it like that. So now there are more users incoming, so you're increasing 1 more server. So it automatically will get increased due to the scaling policy which you have provided. Then after some time, more users are getting added. Then again, using the scaling policy, it will again create 1 more server. So now there are 4 servers. Again, let's say if there are more people coming in, even then there would be only 4 servers. It would not increase the number of servers because the maximum size which is provided is 4. Okay, so this is basically how one part of auto scaling which you will have to provide in the details for while you are creating an auto scaling group. Okay, so now coming to the components. So first of all, group we already saw. So Elastic Beanstalk is the fastest and simplest way to deploy your applications on AWS. So now coming to auto scaling components. So the first topic is groups. So I just explained to you about auto scaling groups. That's exactly it. So your EC2 instances are organized into groups so that they can be targeted as a logical unit. So even though they are separate resources, they'll be considered a single unit so that it will be scaled and downscaled according to necessary demand. Okay, so then you can specify the minimum, maximum and desired number of EC2 instances. In configuration templates, your group uses a launch template or a launch configuration. So not recommended, offer fewer features. So launch template can be used or a launch configuration can be used as a configuration templates for its EC2 instances. So before you launch an EC2 auto scaling group, first of all, you will have to provide either a launch template or a launch configuration. So what it basically means is it will provide an outline of the type of an instance which the auto scaling group should create. Okay, so that's basically a configuration template is. Using the configuration template, the auto scaling group will create the newer instances. So all the instances will be the same configuration. That's why you have to provide a configuration template. And you can specify information such as AMI ID, instance type, key pair, security groups, and block device mapping for your instances. So in the configuration template, you can provide the AMI ID. Why the AMI ID? So that specifies what operating system or what type of an instance do you need. So do you need an Ubuntu instance, a Mac instance, or a Windows instance? So that you'll have to provide the AMI ID for. Instance type, what type of an instance, what should be the RAM, what should be the storage, everything can be provided. key pair should be provided so that there is something going wrong, you can still open the server, one of the server within the auto scaling group and check it. Security groups will automatically, you will have to provide for every single instance, and block device mapping for your instances. So if you want to block certain IP addresses, you can also do that. And then finally, scaling options. So this is where auto scaling comes into play. Even though you create the auto scaling group, so without providing a scaling policy, there is no scaling in auto scaling, right? Because without the scaling policy, the number of instances will not increase or decrease. You can manually do it, but that defeats the purpose, right? Because it's auto scaling, not manual scaling. So for auto scaling, you would need scaling options. So now Amazon EC2 Auto Scaling provides several ways for you to scale your auto scaling groups. For example, you can configure a group to scale based on the occurrence of specified conditions or on a schedule. So there are two options. Either you can increase the number of servers or decrease the number of servers according to a particular metric which you create an alarm for. So if the alarm exceeds and if it goes to an alarm state, it will basically launch a new instance. If it's not in an alarm state and if it's working fine, then it'll basically descale, or it'll keep in the same. For example, there are 3 instances, it'll increase an instance. So 4 instances. If there is no problem, it'll stay at 4. If there is, it'll decrease the number of instances. Okay. Once that is done, there is a second option in which you can do this via schedule. So let's say you have used your application for a long time. So you know the peak traffic for your application is from 7 p.m. to 10 p.m. So within that time, you need 10 servers. So 7 p.m. you will basically, according to a schedule, there will be automatically new servers. Let's say automatically more servers will get created. Let's say there are only 5 servers before 7 p.m. Then after 7 p.m. there would be 10 servers. They would automatically create 5 servers for you. And then let's say after 10 p.m. again, so your traffic reduces a bit. So you are providing, you just need 4 instances. So it will be 4. And then again, let's say in the morning from 8 a.m. to 9 a.m. you suddenly have a surge in traffic. So in that particular time you can provide again. It doesn't have to be from 10 to 11 or something. It can be like 10:05 to 10:12. So it could be smaller intervals as well. Doesn't matter. But these are the 2 different types of scaling you can do. So dynamic scaling happens according to a specified condition. When the specified condition is true, it will increase the number of servers. If it's false, it will decrease. You can also make this vice versa according to the condition you provide. And on a schedule. On a schedule is not dynamic, it's static, because you know when the number of servers will increase and decrease, right? Okay, so these are the auto scaling components. Coming to the next topic, which is the auto scaling benefits. First of all, better fault tolerance. So EC2 auto scaling can detect when an instance is unhealthy. So that basically means auto scaling group will always keep a track of all the servers. If a server is not able to, so if auto scaling group it's not able to reach a particular server, it will automatically mark it unhealthy and then terminate it while creating a newer instance. So that's what they do it. So terminate it and launch an instance to replace it. Why? If an instance is unreachable, then there is no need for it to be running, right? You are still getting built for it. If it's unreachable, you're just paying AWS for a server which is not doing anything for you. Okay, so that's exactly what happens in auto scaling. It will automatically figure out if a server is unhealthy it will basically keep on sending health checks. If a health check doesn't come back, multiple health checks doesn't come back, it will mark it unhealthy, terminate it and launch a new instance to replace and handle the traffic which it was handling before. You can also configure Amazon EC2 Auto Scaling to use multiple availability zones. Multiple availability zones in the sense you can create an auto scaling group which basically goes beyond one availability zone. So you can have the same auto scaling group instances can be in availability zone A, in B and in C. So you can have multiple availability zones and multiple servers in various availability zones which all come under a single auto scaling group. That also can be done. So now, better availability. So Amazon EC2 Auto Scaling helps ensure that your application always has the right amount of capacity to handle the current traffic demand. If you provided the proper scaling policy, and according to that, it will always make sure there is an optimal number of instances to handle the incoming traffic for your application. So better availability. So fault tolerance is basically making sure that your application is always available. Also, whenever there is a fault in your architecture, in that case, it will automatically replace it with another instance so that the unhealthy or useless instances will get terminated, and so your architecture is also cost optimized. Second is better availability. Your application will always be available because of the current traffic demand, and accordingly it will increase or decrease the number of servers and make sure your application is always working and running. And finally, better cost management. So EC2 Auto Scaling can dynamically increase and decrease the number of servers you need. So this basically itself makes it cost effective, right? Because you only pay for the EC2 instance you're using at one particular point of time. If you're not using an instance, you're not going to pay money for it. Launching instances when they are needed and terminating when they are not needed. So this is basically you want to do. But if you want to do it manually, it's not even possible because you do not know when a server is not needed, right? But a computer which is constantly monitoring the metrics, each and every metric for each and every second, knows when to terminate an instance and when to launch an instance. So better cost management also is brought into place. So these three are the bigger benefits given by auto scaling. And then, so let's see some examples to understand auto scaling even better. So first of all, covering variable demand. So let's consider a basic web application to demonstrate how auto scaling will help. Okay, so this application allows employees to search for conference rooms that they might want to use for meetings. So this is a simple application. Just consider it's an application. It enables employees to search for conference rooms. Okay, so that you might want to use for later. So now, during the beginning of the week and end of the week, the application usage is minimal because it would be a off day for most of the employees. Let's consider that. So during the middle of the week, more employees are scheduling meetings, so the demand for the application increases significantly. Especially on Tuesdays and Wednesdays, you have the maximum demand. So the following graph shows that. So Monday there is high demand, but Tuesday there is even more demand, and Wednesday there is even more demand. So Tuesday and Wednesday are the peak traffic times. Okay, so this is the graph which shows that. Coming to the next slide. So there are two ways traditionally to solve this particular problem. So the first option would be to add enough servers. So that is, let's say on Sunday you have only this much, so you don't add the servers. And on Monday you have capacity has been increased, so according to the increase in the requirement, you automatically add servers. So this is what auto scaling will do. But right now what you're doing is you're fixing up the capacity to the top. That basically means according to the highest traffic or the highest usage you get, highest capacity you get is Wednesday. So that is the requirement, right, for that particular day. But if you keep the same servers running for all days, it will still work. But the problem is there is this much unavailability. So capacity is available, but there is no usage. So you're basically paying money for all these unused capacity. So this is completely waste, right? Because you're basically, as a company, you want to reduce the operational costs. And if you are stuck with operational costs for these small things, then that would be a major problem. This is the first way. That is adding steady capacity, which without any changes will always be available so that all your demands are met. Okay, so now coming to the second option. So the second option would be that is to have enough capacity to handle the average demand. So according to the calculations, you can take the peak of everything and calculate the average for the entire week, and according to the average capacity you can basically get the servers. So let's say this is the average capacity over here, but on Monday, Tuesdays and Wednesdays there is overcapacity. So that basically means the application will either get slow or you would create a really poor customer experience. So it will basically become much slower on these 3 peak days. So when most people are trying to use the application, it won't be working properly. So I think that would be a big problem, right? This is the traditional way. So these two are very, very traditional ways, because manually and nothing else is possible, right? You can either have enough instances or enough capacity to cover all the days, or the average capacity to cover most of the days, and also try to cover some capacity on the major working days. But with auto scaling, you get a new option, you get a third option. So you can add new instances to the application only when necessary and terminate them when they are no longer needed, right? So because Amazon EC2 scaling uses EC2 instances, and you have to only pay for the instances when they are running and when you're using them. So you now have a cost-effective architecture that provides the best customer experience while minimum expenses. So to be very simple, what exactly happens is auto scaling, EC2 auto scaling will automatically maintain the number of servers according to the capacity you have. So on Sunday, if there is this, if you need a capacity of around 2.8 servers, then there would be 3 servers running to handle it. So Monday again, there would be always a little bit of a server capacity which is more than which is required. So that's exactly what auto scaling will do for you. So it will maintain the demand, it will maintain the number of EC2 instances according to the incoming traffic and demand, which makes sure that the application is performing really well. Okay, so now coming to the next topic, web application architecture. So why web application architecture? To show you how exactly auto scaling group can be implemented in a web applications architecture, which makes it even better, right? So let's say in a common scenario, you run multiple copies of your application simultaneously. There is a web server fleet and there is an application fleet and a database fleet. Okay, so these multiple copies of your application are hosted on identical EC2 instances, each handling customer requests. So the web server fleet will basically have the front end, so basically the application. So there would be multiple copies of the same application, and let's say in web server fleet there are 100 servers. Every single server will have the same application running inside of it. But if you type in the website, it will take you to one of those servers. It won't take you to all of the servers. So it will take you to one of the servers and you will see just one. So you'll basically see the application in your thing. And the app server fleet will have the application itself, the features, the code, the backend code, everything will be available in the app server fleet. Okay, so that will also be multiple copies, but it doesn't have to be that every single app server fleet has all files of code. It can be that multiple certain fleets are just for certain feature, so you can create multiple fleets for that as well. And then finally there is a database. So let's say a user is requesting to retrieve some data back from the database, so that will go to the app server fleet, and so whenever they click the button, there will be some code which is connected to it, and that particular script file will run, and that particular script file will trigger, basically read the data from the database and give it back to the user, which will be visible in the website. So this is a simple basic architecture, but using auto scaling group, what you can do is you can basically manage the launch and termination of these EC2 instances on your behalf. So that is, you define the criteria. So you define the number of instances which will be available at any point in time, and you decide how many instances can be the maximum, how many can be the minimum. So that determines when the auto scaling group launches or terminates EC2 instances. So okay, so current capacity and current added only when needed. So in this case, there will always be those number of servers. Let's say there would be 10 servers here. The 10 servers will always be available. It won't reduce or increase the number of servers. But in this case, so current capacity is this. There are, let's say, 10 servers, and whenever there is more users coming in, traffic increases, it automatically will increase the number of servers over here. So that's basically the web server and app server fleet. Okay, and yeah, so this is simple web architecture where you can implement auto scaling. And yeah, so we've come to the final part of the auto scaling theoretical part. So I just wanted to show an architecture in which auto scaling has been successfully used, which benefits the application. So users are getting into the application, so their first point of contact is Elastic Load Balancer. So we'll be learning about load balancer once we complete auto scaling, so don't worry about it. So just imagine load balancers like a point of contact for you, which will take you to the appropriate instance you have to be taken to. It balances the incoming load. Okay, that's just know that much about load balancers. And now coming to instances, so let's say this particular VPC spans across 2 availability zones. So that basically means that it has subnets in availability zone 1 and availability zone 2, and it has instances in both of these availability zones. So now, as I told you, auto scaling group could span across multiple availability zones. So the auto scaling group of the web tier is spanning across the availability zone 1 and availability zone 2 and has instances in both of these availability zones. So this makes it even better and even highly available. Why? Because let's say auto scaling group is already a good thing. It will automatically increase the number of servers and decrease the number of servers according to a demand, so that your application is highly available. But let's say one of these availability zones goes down. that is, it has downtime for some time. So in that case, the users will not gain access to it because there would be only one fleet of servers, and if that particular availability zone goes down, all of the servers will go down. But if you have servers, if you have instances in two different availability zones for the same purpose, that will basically mean once if this particular availability zone is down, it will automatically take the requests to the availability zone 2 because it won't take the requests to an unhealthy instance. Okay, and then they have an internal load balancer. So whatever requests come in goes to the internal load balancer, which will take them to the application tier, which is basically business tier, and so business logic tier, where all the business logics are available. Whatever tasks which are asked to be performed goes through the app tier instances, and if there needs to be any information retrieved or any information is getting written, any data is getting written into the database, that will go through the app tier. And even in app tier, the same, you can see, right? So this is the availability zone. So one availability zone and two auto scaling group, and so it's the same architecture even within this. Okay, so this is basically a simple instance distribution. So because of the instance distribution, it will make it even better. So what makes it better? That I told you that it's highly available, right? Even if one availability zone goes down, that will make sure that the application is still running because multiple instances are distributed between various availability zones. So that's basically instance distribution. That's what I mentioned at the top. Yeah, so this is a simple architecture which I wanted to show you guys to make you clear of what exactly is going on in auto scaling group. So also one more thing we saw was, so we'll see more about load balancing in the next, once we completed the auto scaling demos, we will look into the load balancing theory and the load balancing practicals. So don't worry about it, and once that is done, we'll also combine all of these services and do a project, a simple project or a simple architectural project, which will get your understanding even better, right? So this is basically the instance distribution part. So this is done. So now let's go on with the demo. Okay guys, now let's start off with the auto scaling groups demo. So first thing we'll have to start with is by understanding where you'll have to go. So just open the EC2 dashboard and go to the auto scaling groups. You should not open the, I'll show you once again. Yeah, so this is basically the tool. You can just open it and you can see right here how it works, everything which we've seen in the theory part. So this is what we learned in the theoretical part, right? Okay, so the first thing we'll have to start off with is creating an auto scaling group. So, but to start with an auto scaling group, obviously you would need a launch template. So we'll have to create a launch template right here from launch configurations. So to create a launch template, you would need a AMI. So in the EC2 tutorial, we would have created an AMI, right? So that's exactly what we need here, because we don't need a default server. I want a server which already has all the software and everything installed in it. So first thing what I'm going to do is I'm going to quickly launch EC2 instance so that I could create an AMI. So also let me provide the, yeah, I want it to be in 1A, name web server, and launch. I have the key pair, I'm providing the same and launching it. Okay, so once the instance launches, I'll be installing a web server inside it, and so that and I'll be deleting off the index.html page, which is the default page, and I'll be adding a simple hello world page so that we can create an auto scaling group, and I can show you what exactly is the launch configuration. So if I open the launch, so if you have to create auto scaling group, so without the launch configuration you cannot proceed ahead, so that you will have to switch to launch configuration. So you can use the launch configuration which is already available. I have few, but I do not have those AMIs over here. Where is it? So let's say this web server, this is the AMI ID. Let's see if I have those AMIs. No, I do not. Yeah, so I have various launch configurations which are pretty old actually, so I'm not going to use them. I'm going to create my own, or you can basically create a launch configuration and select it, and you can copy it to a launch template. You can see over here, or you can basically create a launch template over here. So you can either go with a launch configuration or a launch template according to your need. So over here it will automatically show the AMI if there's a specific custom value which you want to provide, which would be the AMI which I'm going to create with this instance, with the instance which is running, right? Yep. So I'm gonna connect it. I'm just gonna connect it in the browser. Okay, so I'll provide that AMI over here. Type of EC2 instance I need, which would be, I would want t2.micro. Key pair, I could provide the key pair. I could provide the network groups, I could provide the storage, and all the advanced details. So this is basically a launch template. So there is not a much difference between a launch template and launch configuration. So a launch configuration, so let me create one. So you can see the name, AMI, instance type, the IAM role. So basically it's the same thing, but launch configuration is under auto scaling. That is only it will be valuable only for that. But launch templates, you can also use it for AWS. So you can use this particular launch template to do much more than just auto scaling groups. Okay, so close this. Let me first connect to the instance. Okay, so we are connected to the instance. Clear. Okay, I'm gonna first update my instance. And then I'm gonna install Apache 2. So this is a web server, so I'm installing it. Okay, so now one more thing we'll have to do is we'll have to allow HTTP access. So right now only SSH is allowed. So I'm going to add a rule for HTTP. Unsave rules. So done. Okay, so now if we open the public IP address of the instance, so it should have the default web page running inside of it, the Apache 2 default web page, because we allowed HTTP and also we've created the web server, so it should be running inside of it. Or I'll just copy this, and yeah, so the Apache 2 default page is running inside of it. So now I don't want the default page, I want my own index.html page. So the path would be var www html. So inside this you can see the index.html file, right? So I'm gonna remove the index.html file. So the index.html file is removed. So I'm gonna add over here, I'm gonna add an index.html file. So I'm gonna put it as hello world, or let's say I'm gonna name it as hello world. This is server 1. This is server fleet number 1. I'm saving it. It has been saved. So now if I refresh this, yeah, so hello world, this is server fleet number 1. So it's not in that format because I did not use HTML, I just put in plain text. Yeah, so hello world, this is server fleet number 1. So this is the one which is provided over here. Okay, so now let's create a launch template. So the server is available, we'll create a launch template. I'm going to provide it as server 1 template. So why I'm providing it server 1, because we'll be learning load balancing. So I would need 2 auto scaling groups to show you how exactly it works. Okay, so that would be the project once we've learned the load balancing tools. Once we understand it theoretically, then I'll be showing you how to create a load balancer, how to balance a load between 2 different auto scaling groups, right? So that's why I'm providing it as server 1 template, because later we would also create a server 2 template which will be helpful for it. Okay, template version description. Okay, so there is no version description. You can provide anything you want. I'm going to provide for a practice auto scaling session. Okay, so everything else can be the same. The AMI has to be a specific AMI, right? So now we are going to create an AMI of this particular web server. So this instance which we launched has a web server running inside of it, which has the web page, hello world, this is server fleet number 1. So for this to work, first you have to create an AMI of this. So create image. So I'm going to provide the name as server 1. Okay, and then I'm gonna leave everything the same and create image. So it will be creating. So the thing is, guys, AMIs will take a few minutes to create and to be available. So we'll have to wait until it gets created. So once it gets created, I will be using that particular AMI as the AMI in my launch template. Why? Whenever a new server is getting launched in my auto scaling group, I want that particular server should already have the web page which I want to be running inside the instance. I think you get the point, right? All the servers which will get launched will already have the software and the web pages already available inside of it. So because of this particular AMI, and accordingly it will create the same types of server again and again. If the threshold value and the metric value goes above the given threshold value. Okay, so that's what will happen. So now once it creates, I'll be providing the AMI, and let's wait until it creates. So basically I'll just pause my recording and then we'll continue once it's available. So basically it's still not available. Let me check. It's still pending. So what I'm going to do is I'm just going to copy the AMI ID because this is what we'll need. So we'll not launch the auto scaling group immediately, right? We are going to create the launch template first. So let it be in pending, no problem. I'm just going to use the AMI. Let's see if it is getting visible. It's visible here. Yeah, so it's visible here. So I'm selecting the AMI which I need. So whenever a new server will be launched in my auto scaling group, it will have server 1. Okay, instance type, I want it to be t2.micro. Key pair, I want it to be tutorial key. If I want to log in into any of the instance to just check how it's going on or to make some changes inside of it, then I'll go to, then I can use my key pair. Security groups, I'm just going to use this group. I don't want any network interface. So the thing is, the group should basically allow us to connect to HTTP, right? So let me check. So launch wizard 53, we can connect to launch wizard 53. Type 53. Yep. So it allows SSH and HTTP. So that's what we need. And then storage volumes, I just want the same volume. I don't want anything complex. I want the same thing, 8 GB. Delete on termination. I don't want it to be encrypted. I want it to be the GP2 type. Okay. So yeah, so pretty much it. Advanced details, they're asking more information about host name, the IAM instance, what should the shutdown behavior be. So whenever instance is getting shut down in this particular launch template, should it stop or should it terminate automatically? So you can provide all these if you want, but it's not required because we're going to create an auto scaling group with this particular template, right? So create a template. So template has been successfully created, guys. That's it. So now if the AMI is available, then we can basically create, yeah. So AMI is available now. So we can create an auto scaling group. So let me close this. Now let me go to auto scaling groups, create auto scaling group, provide auto scaling group name. So let me provide the name as server 1 auto group. Launch template, I already have one, so I'm selecting that and clicking on next. Then I want it to be in the same VPC. I want my instances to be in 1A, 1B and 1C. Okay, so I want my instance to be running in 1A, 1B and 1C. Next, so I don't want a load balancer right now because we get to learn load balancing in this particular tutorial. So let's keep that aside. Let's just concentrate on auto scaling for now, and then you can amount of time EC2 Auto Scaling performs the first health check. If you want, you can reduce time over here. I'm going to make it 100 seconds. You can enable group metrics. Usually you will get metrics for individual instances within the group, but if you want group metrics, that is for the entire group, if you want metrics, then you can go with enable group metrics. So I'm going to enable it. Next, so desired capacity, I want it to be 2. Minimum, I want it to be 1. Maximum, I want it to be, let's say, 5 instances. I don't want more than 5 instances. And then you can create a scaling policy. So if the average CPU utilization goes above, let's say 70%, and I want the instances, so this is target tracking policy, choose a desired outcome and leave it to the scaling policy to add or remove capacity. So target value is added, instances need this many seconds to warm up before including in metric. I just want like 10 seconds, so it can be included immediately. That's not a problem. So you can also disable scaling. That basically means it won't increase the number of instances, it will only decrease the number of instances accordingly. So you can use a target tracking policy, or you can just use none. So I'm not going to use a target tracking policy. I'll be using an alarm in order to set that up. Okay, so none, and next. So notification, if you want, you can add a notification. I'm not going to. And then review. Yeah, so everything has been added. So this is how you create an auto scaling group. So now to connect the auto scaling group to an alarm, so that you'll have to create an alarm first and then attach that particular attach that particular alarm to the servers. So in order to create more servers or decrease number of servers. Okay, so we already saw how it decreases the number of servers, right? So I'm not going to show that in the auto scaling group part, because I'm not going to feed in basically fake data or fake processing in order to increase the utilization, to simulate that there is CPU utilization, and in order to the current capacity, it will automatically increase or decrease the number of servers. So I'm not going to show you that. I'm just going to show you how to create this auto scaling group. So now inside this auto scaling group, we provided us the desired capacity as 2, right? So now it's launching 2 instances because the desired capacity we've provided was 2. So it launched 2 instances. If you want, you can view the instances over here as well. Over here you can see there are 2 instances running. This is the one which we have. So one thing which I wanted to show you in auto scaling groups is basically, so now you can see 2 instances are running. Desired capacity is 2. Minimum there can be 1 instance. So if there is a need, if 1 instance goes unhealthy, then 1 instance can still run. And yeah, over here you can see the activity. Automatic scaling, you can create a dynamic scaling policy once you've created it as well. So there is no problem with that. You can also create a predictive scaling policy. It will be based on a time limit. So basically, let's say you can provide CPU utilization, or you can do it based upon the timings, let's say custom metric. So total CPU utilization, and you can add another utilization and you can check it over here. And over here, pre-launch instances. So control the time when new instances are launched to ensure that they are ready to handle traffic. The scaling action will start earlier than the time in the hourly load forecast by this amount of time. So 5 minutes. So basically it will automatically pre-launch an instance before that particular period, so that when that particular period comes, it will automatically launch the instance because the instance will already be available. So this is predictive scaling. So you can basically create one and use historical data and use forecasted load according to the data which you already have and create a scaling policy over here. Or you can create a scheduled action. So scheduled action is more of, let's say the desired capacity you want to be 2, minimum is 1, maximum is 5, and you can make it an occurrence for every, let's say every day I want this to run. So tomorrow I want to be the start date. I want it to run at 5. Okay, so this is UTC, right? So it would be like 10 a.m. So it would be like 10:30 a.m. in India, so where I am. So this is the start time. You can also set an end time. Let's say you want it to be you want it to run every day, but you want to end it after 10 days. So you can set that over here. So at one particular point of time, at this point of time to that point of time, it will automatically have that specific number of servers. So let's say we can make it 3 or something. So in this particular time, let's say I want it to run 21 till 5. Let's say I want it to run every hour within this particular day. Okay, and end time I want to set it as 21 and 5. So within 24 hours I wanted to run it 23 times, and I wanted to keep this at a constant. Okay, so this would be a predictive one, right? So simple. I'm just providing a name so that you can just click on create and it will create a scheduled action. So at this time on this date, it will automatically make sure that the desired capacity of instances are 3, and if there is a high CPU utilization, it can take it to a maximum of 5 or a minimum of 1 according to the requirement. And the next day on 22 at 5, it will automatically end it. So 24 hours, it will start at 0, so it will basically run for 23 times. Okay, so you can create this particular one, or you can create a dynamic scaling policy. So that's what we'll be doing. Okay, so this is what we'll be doing. We'll be connecting metric type, and we will be connecting the alarm to it. So over here, step scaling is there, simple scaling is there. We can use a simple scaling policy or a step scaling policy. So step scaling policy is even better, because here we can create action to add instances and create an action to remove instances. So you see this, right? Add instance, remove instance. So we can provide a policy name. We can provide the alarm which we've created in CloudWatch, and then according to the alarms metric, according to the threshold provided there, this particular policy would work, and accordingly it would increase and decrease the number of servers in this particular auto scaling group. Okay, so this is basically auto scaling, guys. Yeah, so this particular part, the scaling policy, we'll be seeing once we learn about elastic load balancing right now. So please continue with this session. I just wanted to show you how to create an auto scaling group so that we can move ahead and learn elastic load balancing, so that I could show you the entire demo, where what we'll be doing is we'll be having 2 different auto scaling groups. So auto scaling group 1, which is server 1 auto. Yeah, so we'll have server 1 auto group and server 2 auto group. Server 1 auto group will have the website called this is server 1. Server 2 will have this is server 2. So we'll be creating elastic load balancer which will redistribute the traffic. So whenever one particular web page is searched, whenever the URL is pasted, it will take you to server 1. Whenever they are searching for a tutorial website, it will take them to the server 2. So that's what we'll be establishing. So this is why we learned EC2 Auto Scaling, CloudWatch in order to create the auto scaling group, and we'll also have elastic load balancer. So these are the things which we are building up to. So that's why we were going through all of these services in an order in order to do a complete demo at the very end. So make sure you follow through, guys. So that's it for the scaling part. So now let's move on to the load balancing. So guys, next let's look into elastic load balancing. So you understood what is auto scaling groups. Now let's say you made auto scaling group and the auto scaling group is working fine, and so it's increasing number of servers whenever more traffic is coming in, and whenever less traffic is coming in, it's automatically decreasing the number of servers. So now what makes sure that the traffic which is incoming is balanced across all these servers? So that's one of the important concepts, right? Because let's say if there are 10 servers in auto scaling group, and only 5 servers are given the maximum connection requests and the rest 5 are only given less, so that's not a proper optimal solution, right? Because if more requests have given to those 5 servers, the performance for the customers would become even better, become even faster. Lesser number of requests or lesser number of operations running in one particular server will obviously make the server or the request to be given back, it will work much faster, right? So that's exactly why we need load balancing. So there are various types of load balancing, but in the essential sense, this is the reason why we need load balancing. So ELB automatically distributes incoming traffic across multiple targets. So the multiple targets can be individual instances or auto scaling groups, such as EC2 instances, containers, IP addresses, and it could be in multiple availability zones. So no problem with that. It monitors the health of its registered targets and routes traffic only to the healthy targets. So it's pretty simple. It keeps on monitoring. So let's say you've connected instance to elastic load balancing directly, registering the target. So that it will basically check for that particular target, and it will see if the instance or the instances healthy or not. If they are not healthy, it will not redirect the users to that particular target. So only when it becomes healthy, or when the auto scaling group has deleted it and provided another server, only then it will request those incoming requests to those particular instances. Okay, so now elastic load balancing scales your load balancer as your incoming traffic changes over time. So it can automatically scale to the vast majority of workload. So it's pretty simple. Load balancing scales your load balancer which is getting created according to the incoming traffic changes. So you don't have to specify anything, you just have to create the load balancer, and you will have to basically set up the targets and set up the entire architecture. Then elastic load balancing will automatically take care of the incoming traffic. So how many ever requests come in, even 10,000 or 1 million or 10 million, so however increasing the number goes, elastic load balancing will be able to manage it because it can automatically scale for the majority of workloads. So that's exactly what elastic load balancing has been announced for. Okay. Now coming to the next one, which is elastic load balancing. In this case, what we are going to look into is the types of load balancers and also what exactly makes the load balancer working. Okay, so how a load balancer works. So you configure a load balancer to accept incoming traffic by specifying one or more listeners. So a listener is a process that checks for connection requests. So and also that particular listener will be configured with a particular protocol and a port number for connections from client to a load balancer. To make it very simply, let's say I'm trying to access a website and I'm putting in the website address. So let's say www.example.com. So once I hit enter, so there would be a DNS process which checks for the IP address of the given domain name, and accordingly it will basically like do the DNS resolving and take you to that particular IP address, the servers in those particular IP address. So then it'll hit a load balancer. So when you type in, the first point of contact for you with the application would be the load balancer, right? So that particular load balancer, what it does is it will have multiple listeners. So let's say the website is running on a web server which uses the port protocol HTTP and the port number 80. So now in that case, it will be listening for connection requests which are coming to the port number 80. Right, it will listen to that particular thing. If there is a connection request, that is I'm typing in the website name and there is a connection request which I am creating to that particular port number in this particular elastic load balancer, because this is what it is configured for. So when it hits there, then according to the listener, this is a valid request, and so when it's a valid request, then the elastic load balancer will allow that particular connection request inside the architecture to go and like access the servers or the auto scaling groups. So this is basically a simple way of explaining what a load balancer does and how it works in AWS, an elastic load balancer. Okay, so likewise it is configured with a protocol and a port number for connections from the load balancer to the targets. So now inside the load balancer to the targets, every load balancer and the targets will have this connections, that is it will have the listeners, the protocol and the port numbers, and accordingly it will work. So now when we do the demo, when I show you how exactly a target works and how exactly we make the connection between auto scaling and load balancing and how exactly we are making the difference in load balancing, it will give you more insights to how exactly elastic load balancer works. So it will be much better than learning it theoretically, but again understanding how it works before actually doing the practical would be much better. So that's why we are looking at this. So an elastic load balancing supports the following types of load balancers. So the top three, the application, network and gateway load balancers, are the current generation load balancers which are available. Classic load balancer is deprecated and it will be taken completely off Amazon or completely off AWS in 2022. So I don't know which month, so if you just check out the website when we are doing the demo, we'll get to know what is the date on which the classic load balancer is going to be deleted. But it's a traditional load balancer. Let me explain the classic load balancer right here, because in the next 3 slides we'll be learning about the application, the network and the gateway load balancers. Okay, so classic load balancer is pretty simple. The load balancer, you can register multiple instances to the load balancer. So the first request which is coming in will be sent to the server 1, second instance will go to server 2, third instance will go to server 3. So let's say there are 3 servers and there are 10 requests coming in. So the first request will go to the first instance, second, third, fourth, fifth, sixth, 7th, 8th, 9th, and the 10th will go back again to the first server. So if that particular person themselves refresh, they will be taken to the second server. If they refresh again, they will be taken to the third server. So it's basically a traditional route. So this is not optimal in most solutions, but if it's a simple application, let's say it's a simple blog which you want to just upload, in that case you can just go for a classic load balancer. It would still work. So classic load balancers, you can also hard code it into your application, so that will also work. If not, you can use the AWS classic load balancer, but the problem is it will be deleted or it will be completely taken off AWS in 2022. So 2022 is just in a month, not even a month, just a few days, so from the date where I'm recording this, and so in a few months it'll be taken off. Okay, so now before moving on with the application, network, and the gateway load balancers, let's first understand about cross-zone load balancing and how cross-zone load balancing works. Okay, so first of all, the nodes for the load balancer distribute requests from clients to registered targets. So nodes, in the sense, these are the nodes. So let's say there are 3 availability zones, then there would be 3 nodes. So each node is connected to a load balancer over here. So incoming client, so in this particular availability zone, there is a load balancer. In this availability zone, there is a load balancer. So now this is basically cross-zone loading enabled. Cross-zone load balancing is enabled in this particular diagram. So let me explain why it is enabled or how it works. So now, when cross-zone load balancing is enabled, each load balancer node distributes traffic across multiple availability zones and across all the registered targets. Okay, so when cross-zone load balancing is disabled, each load balancer node distributes traffic only across the registered targets. So let's say there are 2 load balancers and there is one more load balancer which will either choose this or this, let's say that, and a new request is coming in. So let's say the first request is sent here and the second request is sent here. Okay, so if cross-zone load balancing is enabled, there is a 10% chance of the request going to each of these servers, or let's say there are 10 requests coming in, there is a really good chance that each one of the server would get a single request. So it's not sure that every single server will get a request, but there is a really good chance, that is, each server will get 10% of the traffic, because it is cross-zone load balancing. All the registered targets across multiple availability zones will be considered as one single entity, even though they are not, but they will be considered as a single entity, and the incoming traffic will be shared equally among them. So basically, in this case, there are 10 servers. Each server has a probability of 10% of receiving the incoming request. Okay, so this is basically when cross-zone load balancing is enabled. Let's say it is disabled. Okay, in that case, what happens is each of the 2 targets in the availability zone A receives 25% of the traffic, and each of the 8 targets in availability zone B receives 6.2% of the traffic. So why? Because this particular load balancer is in a different availability zone, this load balancer is in a different availability zone. So the incoming traffic will be 100% for this load balancer and 100% before it divides. So in this case, even though it is 100 and 100%, they are considered as a single entity. So the overall requests which are falling into these 2 availability zones and 2 load balancers will be considered as one single form, and it will be divided equally among servers. But when cross-zone load balancing is not enabled, if there is a request going into availability zone A, the chance is that it can only distribute within the availability zone. Same thing goes to the second load balancer in availability zone B. So if a request is coming into availability zone B, there is only chances, or there is only options for the load balancer to send the request within the availability zone. It cannot send the request to the other availability zone. So because of that, there is a chance. So the 2 targets in availability zone A basically receive 25% of the incoming traffic to availability zone A, and in availability zone B, each target will be receiving 6.25% of the traffic which is coming into that particular availability zone. So this is basically it, because both are different load balancers, and the incoming client traffic is divided 50% among these 2, and so this is basically it. So total is 100%, 50%. So 50% is divided into these 2 instances, so 25%. Here 50% is divided into the 8 instances, so 6.25. So that's basically the ideology for cross-zone load balancing. So if you're going to have instances across multiple zones, then it is better to go with cross-zone load balancing, because if you think there would be equal number of servers in both the availability zones, if you have an auto scaling group which does similar actions, and if you think always there will be similar number of servers, then go with cross-zone load balancing disabled. But it's always better to make it enabled. Okay, so this is basically cross-zone load balancing. Okay, so now let's start with the application load balancer. To be very simple, application load balancer is used when you have multiple features within a same website. So let's say example.com/blogs, and there is another website, example.com/streaming. So the first site is for blogging, example.com/blogs, and there's second site which is for streaming videos. Let's consider streaming videos, and the path is example.com/streaming. So now let's say if somebody is searching for example.com, they'll be taken to the home page. So if they are searching for example.com/blog, or blogs, they'll be taken to the blog website. If they are searching for example.com/streaming, they'll be taken to the streaming website. Okay, so now if they're all in the same server, and in that case, if you jumble up them all in a single load balancer, I don't think that would be fast enough. So if you go with application load balancer, you basically get an advantage of searching through the headers and according to the incoming port numbers. So what you will be doing is, according to the incoming header, the HTTP header or the path, or the query, so according to the incoming request from the user, you can basically make sure that the traffic is redirected to different server groups. Okay, so let's say there are two auto scaling groups. The first auto scaling group has the example.com/blogs website. The second auto scaling group has example.com/streaming website. So now whenever somebody searches for /blogs, they should be taken to auto scaling group 1, which has that website. Whenever someone searches /streaming, they should be taken to the second auto scaling group. So because it has a website for that particular purpose. Okay, so now in the application load balancer, you can create a rule. So for example, whenever a request comes in, it will first have to go through the rule. So the rule is basically, you can create a path-based rule. So whenever somebody searches for example.com/blog or example.com/blogs, they should be taken to the auto scaling group 1. So you can create a rule for this, and then there will be another rule. So if obviously if they did not search for that, there you can add a second rule which says that if you're searching for streaming, so in that case you should be taken to auto scaling group 2. Okay, so this is the second rule. So let's say even the second rule is not, they did not search for streaming, they are searching for example.com/contactors. So example.com/contact is the website name. So now if somebody is searching for /contact, then they should be taken to another instance which has the contact us web page running inside of it. So these rules you can provide and save it. So now the incoming request will go through all of them. If it is someone searching for blogs website, they will be taken to the auto scaling group which has the instances for the blog website. If they are somebody who are having the who are searching for the streaming website, they'll be taken to the servers within the streaming website. Okay, so so this is basically the basic purpose of application load balancing, but within that there are so many different topics to discuss about. So this is the source. The request can come in from anywhere, doesn't matter. And Amazon Cognito, certificate manager, and WAF. So WAF can be used for a firewall. So application load balancer runs on the layer 7. So you would have a layer 7 firewall so that you could have security for unauthorized access in that particular level. A TLS offloading, you would get a certificate. You won't be provided with a certificate, but you can basically get a certificate so that it is much more secure for you. It would be HTTPS, so that it's much secure. And Amazon Cognito, commercial identity provider. So this is basically, let's say you want them to identify via commercial identity. That is, if you want them to log in into their Amazon site, or you want the login to be the Facebook one or the Google one, you can do that using Amazon Cognito. Or you can just create another application, custom identity provider. Okay, and then there is targets. So targets are basically the sites and the places where you will be connecting. The application load balancer will be taking the requests to, right? So you can have EC2 Auto Scaling group, Lambda, Fargate, EKS, ECS, or directly to an IP address. So directly to an IP address, that basically means it could be an EC2 server, it could be an Azure server, it could be a GCP server, it could be an on-premises server. It doesn't matter. So so these are the different targets which you can connect to the application load balancer. So this is basically application load balancer. You can do path-based routing, and so basically various kinds of content-based routing. It has multiple load balancing algorithms which you can use, and accordingly you can figure out the entire architecture. Okay, so now coming to the second one, which is the gateway load balancer. So over here you can see this is the source, internet or internal workloads, destination again internet or internal workloads. So this is mostly could be used for an internal application. So to be very simple, gateway load balancers are basically used for the virtual resources within the account. That is, a gateway load balancer is a balancer between multiple load balancers within the internal architecture. So let's say you have the EC2 Auto Scaling group over here. Okay, so custom firewall, so everything is basically set up over here. It could be anything. It could be, let's say, you are running inspector inside of it, or you are running a firewall inside of it, or you can create an intrusion detection and a prevention system. You can run that inside of the auto scaling group EC2 instances. So you can run all of that, and then you have the gateway load balancer to redirect traffic to this particular application. Okay, and then you use the AWS private link to establish connection between two different VPCs or two different, let's say, the on-premises and the network level, the on-premises and the AWS level. So you can connect them using AWS private link. So source and destination are unaware of where the traffic is coming from. So basically, let's say the source is me trying to access something from my local PC, but let's say I'm a private user who has access to the application. So I'm trying to access it and doing something, trying to send something to the destination. So now, before going to the destination, first the in-browse routing and route tables will check if I'm allowed, if I have access to it, and once they know that I have access to it, I will use basically the private link will enable connection between the destination. But now the private link is also connected to the load balancer, so I'll be taken to the load balancer. Okay, I'll be taken to the load balancer. Once whatever task which I'm sending is done, it will basically again redirect the traffic to the destination. So now the source and the destination do not know exactly where the traffic is coming from. So that's exactly why we need this particular setup, the gateway load balancer. This will especially work for if there are two private entities trying to contact, and in that case using a gateway load balancer to making sure that you are establishing connection between them without risking any access, unauthorized access, then go for a gateway load balancer. Okay, so this is done. And finally, a network load balancer. A network load balancer, again, it's a layer 4, you can see, application load balancer, layer 7 according to the OSI model. Network load balancer, layer 4, and gateway load balancer is basically layer 3 plus layer 4. So it works on both the layers because it does both load balancing and also making sure there is a security level, right? So that's exactly what. Okay, so now coming over here. Yeah, so source could be from the internet or internal workloads or AWS private link, doesn't matter. So where it can come from any of these. So AWS private link, in the sense it could come from an on-premises network, or it could come from another AWS account through the AWS private link. So our network load balancer does load balancing in the layer 4 using the protocol. So the TCP or the UDP connection base. So it could be a TCP connection or a UDP connection, and it also is very low latency. So the layer 4 load balancing is much faster than the application load balancing and also much safer. Okay, so again, AWS Certificate Manager is connected to the load balancer in order to provide extra basically security in this case. Okay, so now it goes to the network load balancer. So what it checks for is you can set up a particular networking balancer. So if you go for the application one, so in this case you can only set up for HTTP and HTTPS or WebSocket. So all these basic stuff. So HTTP, HTTPS, and gRPC and WebSocket. That's it. These are where the requests can come in from. These are the only places which application load balancer can get in requests from. But when it comes to a network load balancer, it could come from anywhere, and it could come from an AWS private link also, because it's going to listen to the layer 4. It would basically look for a connection based via a TCP or a UDP protocol. It could be any TCP protocol or any UDP protocol, but in these cases they have mentioned the TCP protocol which it can read. So it can only read the HTTP and HTTPS and HTTPS versions. Okay, these are the protocols which it can read. In this case, it can read all TCP and UDP protocols. Okay, so this is basically network load balancer, and again the targets could be the same targets as these. And also in this case, the network load balancer could also have an application load balancer as a target, because So I was showing you guys this, right? So there is another load balancer inside. So this is the let's say this is the application load balancer. Let's consider that, and then there is a network load balancer, and the network load balancer could have a target as an application load balancer, which is splitting the connections as well. So the network load balancer could be used for a different purpose, and in this case, a network load balancer could be used for the purpose of diverting the traffic in the internal traffic according to the protocol which is requesting from. Okay, so this is basically a network load balancer. And finally, let's just discuss the differences between these load balancers, and then we'll start off with the demo for the load balancer. And yeah, so once that is done, I think you would be covered with everything. You will understand all the concepts, because whatever services we've done, we've already covered the demos for it. We will just do a demo which involves auto scaling, which involves EC2 and few other AWS resources, and then so that would give you a better idea, right, what exactly we're doing. So that's what we'll do after network load balancer. So once this is done, I'll be showing you a quick demo involving auto scaling groups, application load balancer, EC2 instances, and few more services like CloudWatch, and like we can also say IAM, because everything will be involved in together. But we have not learned IAM yet, so remember that we have not learned IAM yet. I have not covered IAM, so I'm not going to cover it extensively. It might come in because it's one of the important services. Okay, so now load balancer type: application load balancer is layer 7, network load balancer is layer 4, gateway load balancer, the gateway is layer 3, and the load balancing part is layer 4. Classic load balancer could be either 4 or 7. Target type we already saw. Application load balancer only allows IP addresses, instances, and Lambda, and also it allows ECS, but again ECS also will only provide IP address. So these ones, ECS, EKS, Fargate, all of them will also provide an IP address, so that doesn't matter. Instances would be EC2, Lambda would be the Lambda function. The same thing, but instead of Lambda, it allows application load balancer. Gateway load balancer only works with IP addresses and EC2 instances. And can it terminates flow or proxy behavior? So application load balancer, network load balancer, and classic load balancer looks for and terminates proxy behavior, but gateway load balancer cannot do that because it's internal. The traffic is coming in from a source which it cannot know, so it cannot do that. But the other three will do that. And protocol listeners, as I told you, it only listens for HTTP, HTTPS, and gRPC. Okay, so these are the three protocols which it listens to, which is very limited because it's the application load balancer, application level. And but network load balancer listens to all protocols which come under TCP and all protocols which come under UDP, and also the TLS one, that is the certificate related. Okay, and then gateway load balancer, it only listens to the IP address, and classic load balancer listens to again TCP, SSL, and TLS, and HTTP and HTTPS. And finally, how it is reachable. The application load balancer is reachable VIP, route table entry. So VIP in the sense it can be reached just by providing the domain name of the load balancer, but gateway load balancer you cannot do that. You will have to provide it in the route table, only then it will work. So that's it about load balancers, guys. So we've seen everything about elastic load balancing. So now let's go ahead for the final demo which we'll be doing. So once that is done, we'll be done with the tutorial. I hope you had a good time. So now let's start with the demo. So guys, let's start with the demo. So this will be the final demo where we'll be clubbing together multiple services. So we will be using EC2, we would be using auto scaling, we would be using elastic load balancer, and also we would be interpreting CloudWatch alarms into it. So we are using 4 different tools in order to create this one particular project. So what we're going to do is we're going to create an architecture which will resemble the instance distribution part which we did right in the PPT. So basically there would be an elastic load balancer at the top, there will be 2 auto scaling groups, and the load balancer will take the user to the particular websites according to the input they've done. Okay, so that's exactly what is gonna happen. It will be even better when we do it, because that's what you're going to see, right? You're going to see the live output of what we're going to do. So if you want to do this project, please follow through. So first thing, we've already created an AMI which says hello world. This is server 1 page, right? So now we need another AMI which would be for the second page, okay, which will be for the second server. So first thing we'll have to do is we'll have to create a server. So I'm just going to do it quick because I'm pretty sure you guys already know how to do it. So I'm just going to follow through the same steps without wasting any time. And I need to allow rule HTTP because it's going to be a web server, right guys? You can select an existing security group also, no problem. Launch, I already have a key pair, and launch instance. Okay, so now what I can do is now I can log in into this, and I can basically launch a web server inside of it. And once I launched a web server inside of it, I'll be creating another folder within the web servers folder, and inside that folder I'll be putting another file. Okay, so basically it will be searching for that particular directory. So that's what we're going to do. Okay, so let this get created. Let's just wait until this is available. Once it's available, we'll connect it. Okay, so while it's getting created, let me just explain. So first we'll have two AMIs, right? So two AMIs, we already saw how to create a launch template. So we already have a launch template for server one. So for one auto scaling group, we already have the launch template. So now we'll have to create a launch template for the second AMI, which we are going to create right now. So once two launch templates are ready, now we can create two different auto scaling groups, which will have two different features of the same website inside of them. Okay, so now then when we have two different auto scaling groups, now it has one feature one, the second auto scaling group has feature two. So now we should make sure that the Elastic Load Balancer takes the user to feature one if they are searching for feature one, and it has to take the user to feature two if they are searching for feature two. Okay, so that's what we're going to do. And one more small addition I have to make is that this particular, I'm going to create another AMI because I might delete this because I want to include one more thing. So we can create two AMIs from the same server. You can do that. Okay, it doesn't matter if you are using the same instance to create two AMIs, but the only thing is you should change what is inside the instance before creating the server. Okay, so actions, connect. I'm just going to connect right here. I'm not going to connect it with SSH because I just want to install. And yeah, so I'm not going to extensively use it. If you're going to extensively use it, connect it via SSH because that's the much better option. Okay, so here first I'm going to update it, sudo apt updates. So then sudo apt get install apache 2. So I'm installing the web server in this as well. Okay, so the web server is installed. Let's see if this is visible first of all. Yeah, so the Apache 2 web server is visible. Okay, so now what I want to do is I want to go to the location where it is. Sorry, www html. So here I want to create a directory called tutorial, right? Okay, so there is a directory called tutorial. Now inside the tutorial directory I want to create a index.html file. Okay, so now sudo nano index.html. Okay, so here I'm just going to type hello world, this is server 2 tutorial page. So this is just to identify the difference. Okay, so yeah, so this is basically to identify the difference. So now let's do the same thing. Let me open this. Let's see if this particular website is visible if I search for the tutorial. Okay, now you can see, right? If we search for that particular path, it takes us to that particular path's web page. So that's the difference between this server and the previous server. So now what exactly will happen here is, so whenever people search for this, just the direct ELB Elastic Load Balancers URL, they would get the default page. So not this particular default page, this server which we've created, right? This is server 1 page. So that would be the default page. So that will be visible. But whenever people search for tutorials, they have to be taken to this particular server. Okay, so that's what we are trying to achieve. So in this case, in the demo, it won't be 2 servers, it would be 2 different auto scaling groups. Auto scaling group number 1 will have this is the server 1 web page. Auto scaling group 2 will have the server 2 web page. So whenever they search for the URL, it will take them to auto scaling group 1. Whenever they search for tutorial, it will take them to auto scaling group server 2. In this way, it is balanced. It is basically balanced using the application way. So we are going to use application load balancer because it is basically balancing the load according to the application which you are searching for, right? And also it is searching for the header. That is, it's doing a path-based routing. So that's what we are trying to achieve over here. Okay, so we've created this. So now I don't need this instance, but I just need the AMI of this instance. So let me create an AMI. And then once I've created the AMI, I'm just going to delete it. So I'm going to name it as server2 AMI and create it. Okay, so server 1, server 2, we have both the AMI. So server 2 is getting created. Okay, so now the AMI is getting created. Now let's create a launch template for this particular AMI. So you guys know why we need the launch template, right? To create a auto scaling group. So because we've already covered that in this particular tutorial. If you are new to this stream, please go back, check out the auto scaling part, or just come from the start, learn all the services so that you would get a better understanding of what you are doing here. Because without knowing EC2, there is no purpose of learning auto scaling or elastic load balancing. Okay, so I'm just going to name it as server. Okay, let me just see what is the launch template name here. Server 1 template. So I'm going to name it as server 2 template. This is for server 2 tutorial page. Come down, AMI, specify a custom value. I have to, let me open this in a new tab. This is the AMI ID, copying it, coming down, specify a custom value. Or I think if we just search here, it'll also show that. Let me do that. Yeah, server 2 AMI. I've selected it. Next, coming to instance type, I just wanted to be t2.micro because again, it's for practice. I don't need an expensive instance. Key pair name, I already have a key pair in my PC. It's tutorial key. If you already have a key pair, just use the same one. If you do not have one, create a new one and attach it. Security group, I'm gonna use 53 or 54 because launch wizard 53 or 54 both are allowed for SSH and also HTTP, so I'm allowing that. So everything else I just want to be the same, so I'm just going to create this template. So 2 templates are done, guys. So now we can create 2 different auto scaling groups with 2 different web pages running inside of it. Okay, so that's why we need 2 different templates. Okay, so now before we move on to ELB, let's create the auto scaling groups quickly. We know how to create auto scaling groups. Again, if you do not know how to do it, please go ahead to the auto scaling group part of the session and learn it, and then come back over here. So I'm going to provide the name. This is server 1 group. Launch template is server 1 template. Next, let it be the same VPC. I want the instances to be in 1A, 1B and 1C. The server 2 one, I'll put it in. Yeah, I want it to be across 1A, 1B and 1C. So when we are launching, right, you would see that the 2 instances are in 2 different availability zones, so that if one availability zone is down, the other one would be running, and that would make sure that there is some high availability for the server. Okay, high availability for that particular web page. Okay, so now I'll just make the health check grace period 100, enable metrics. Let me see. Yeah, so I need metrics for the group, so I'm just gonna provide group metrics collection within CloudWatch. Next, desired capacity, I want 2 instances, minimum 1, maximum of 4 instances. Right now I don't need any scaling policy. And next, I don't need a notification for now. Next. Yeah, so pretty much that's it. I'm creating an auto scaling group for server 1. Okay, so 1 is done. So next, let me see if this AMI is available now. If the AMI is available, we can create the launch template for number 2 as well. So the AMI is available. So let's go ahead and create the auto scaling group. Server 2 group, launch template is going to be server 2 template, and then everything else would be the same. Here again you can select different availability zones. Next, no load balancer for now. I'm just going to make this again 100 seconds. I need the metrics. Next, so why do we need the metrics is that you can analyze the auto scaling groups even better to get a better understanding of your tools. Okay, so you can understand how your auto scaling group is performing, and you can do it just using CloudWatch. You will be given all the metrics in the CloudWatch tool. You can just go ahead and create a dashboard for your auto scaling groups, and within just the one dashboard you can view every single thing. Okay, again, desired capacity I just want 2, maximum 4. Okay, next, I don't need it, so I'm just gonna skip to review and then create the second auto scaling group. Okay, so 2 auto scaling groups are created. So server 1 already has created 2 instances. Let's check the instances. Okay, so it has been created. So you can see the first instance was created in 1A, second instance was created in 1B. Okay, now let's see one more thing, what exactly is within this instance, right? So this is server fleet number 1, and this particular server does not have the tutorial directory. So that's the difference, right? That's the difference we are trying to achieve. So this has this feature, which is server fleet 1. Let's just assume this is one feature, server fleet number 1. Okay, and once our scaling group 2 is done, so both the instances are launched, both are healthy. So now if we view, okay, there are 5 instances running. I'll delete one instance which we created. This was that instance. Let me just delete it. This was an instance we created basically for creating an AMI. So I'm just deleting it because again it'll be getting built when it's running, so I don't want that to happen. Okay, so now just go over here, just 240. Okay, this instance, copy and paste. So this will have the Apache web server default page, but I don't want this to be visible. I want /tutorial page to be visible. Okay, done. Okay, so now we have both the auto scaling groups available. So now let's move on to load balancers. So that's what we need. Okay, so before moving on to load balancers, I just want to show one more thing, automatic scaling, where we can include a dynamic scaling policy. So here I want to show you guys how we can implement the CloudWatch alarm into this. So before we move on with this, let's say you have to go to step scaling. Okay, so now first let's create a CloudWatch alarm which will let us do this. Okay, first selecting a metric, going to billing. So I'm going to select the auto scaling group metrics. I want the auto scaling group number 1. I don't want any auto scaling for my group number 2, server 2. So I'm just going to use server 1 group. Okay, so this is not required. Let me go back, go to EC2 by auto scaling group. Okay, so I'm going to select CPU utilization. I'm going to come down. Yeah, over here I want it for server 1 group, right? Yeah, so I want to check the CPU utilization of server 1 group. Over here you can see this is the EC2 CPU utilization, those one, orange one, and green is the service capacity. Okay, so what happens here is if it has 4 instances, it will combine and basically check the average CPU utilization for all the instances. So within the server 1 group, how many ever instances are there, it will use the same metric. Okay, so go with this. Let me do one thing. I think I've selected one more in the auto scaling group. I'm going to remove that metric first. Yes, I've selected the metric CPU utilization server 1 group for a minute average. Okay, so now we already know, so it was at 36%, now it's at like 0.19% because there is no usage. So now let's say whenever the CPU utilization goes above 80%, I want another instance to be added. So that's what I'm providing over here. That's the condition. Whenever the CPU utilization goes above 80%, I want one more instance to be added. But right now I'm not mentioning that one more instance to be added. That we'll mention here. Okay. Okay. So if it's greater than or equal to 80, then we would basically add more instances. So right now the alarm is that whenever the CPU utilization goes above 80% and stays there for 1 minute, that basically means this particular CloudWatch alarm will go into the alarm state. Okay. Yeah, so it'll be an alarm. Whenever it's in an alarm state, it'll trigger. So I don't want any notifications. I'm going to remove this. And right now I'm not going to include an auto scaling action right here, because we'll be including that here. We can also do that here, but I don't want to do it right now. But again, it's the same thing. You can include it here, or you can include it in auto scaling group. I'm going to name it as server 1 CPU alarm. Next. So you can see here, right? So this is the percentage. So if it goes beyond this for a minute completely, then it'll basically go into an alarm state. But right now it won't go into an alarm state. It will be in the OK state only. So first it will be in insufficient data, and after a minute of collecting data, it will go to the OK state. Okay, so we've created the alarm. So now let's refresh. And right now you can see there is an alarm, right? So done. Okay, so now a scaling policy name is going to be capacity planning server 1. Okay, so now add one instance whenever the CPU utilization goes above 80, but not here. So whenever CPU utilization is lesser. Okay, so we've added this. Let me just do one thing. Simple scaling. Okay, so capacity planning CloudWatch alarm. So the action is add one instance when the CPU utilization is greater than or equal to 80, and yeah, and minus one instance. So I can't go minus over here because I can only go in plus, but I don't need this because we would have to create another instance policy. I'm just going to provide 100. Okay, so this is basically for adding more instances. Okay, this step scaling policy. So if it's above 80, then I want one instance to be added. We can add another step. So it can be 2, and this could be like let's say 40, or this could be lesser than that. This could be 40, and this could be 20. Okay, so it's totally your wish. So if it's 40, in that case I want one more instance to be added. So that's basically what this is for. So I'm not going to add it. So let it be. If it's above 80%, I just want one instance to be added whenever it is available. Okay, so I'm creating this scaling policy. So now whenever it goes above 80% for 60 seconds, it will automatically create one more instance. So now we can create another one. It doesn't matter, like it's not like there can be only one instance. So one scaling policy, there can be multiple. So if we go to scaling policy over here, I can create another one. Let's say capacity planning 2. I can choose another alarm which I'm going to create. So let me select this same alarm, remove instances. So again, so this is basically if it goes above 80%, it will remove one instance, but it will contradict with the previous scaling policy. But the thing is, this particular alarm I would have created it as if CPU utilization is lesser than or equal to, let's say 30% for one period of 60 seconds, then remove one instance. So that basically means I create another alarm and attach it. So I'm not going to create another alarm and attach it because, so I think you understood the purpose of this, right? Yeah, so this is basically how you can create scaling policies. You can create 2 different simple scaling policies, or you can have one-step scaling policy, or you can have a scheduled action at 5 p.m. You can create 10 instances or delete multiple instances. So that's totally your wish. So this is basically scaling. Okay, so now going back. Okay, so guys, we've done the first part. We've used CloudWatch, we've used EC2, and we've used auto scaling groups. Finally, we'll have to use elastic load balancers. Okay, so now going to load balancers. So again, we're going to use a application load balancer. We're not going to use the other ones. So I think I've already explained them, but I'm just going to give a very brief. So why we are using application load balancer? Because our applications which are running in the auto scaling group instances are using the web server which uses the HTTP protocol. So if you're not using any other protocol, if you're using the HTTP or the HTTPS protocol, you can directly go for the application load balancer so that you can load balance it according to the path. If you need layer 4 load balancing, then in that case you can go with network load balancers. So you can balance it using the TCP or the TLS or the UDP protocols. Most commonly TCP and TLS is used. And gateway load balancer, again, it's basically for internal purposes. So it is to redirect traffic from one source to destination so that the destination wouldn't know where this traffic is coming from. So we're going to use the application load balancer for this particular demo. So let me click on create. Okay, so now just follow me through. If you want to know how exactly it works, you can just read this. So your client makes a request to your application. So your application's first point of contact would be the application load balancer, right? The application load balancer is where the client's requests first comes in. So in your application load balancer, there would be listeners. So listeners are basically the port number and the protocol. Okay, so it could be HTTP port number 80 or HTTPS port number 443. So you can configure that according to what port number and what protocol you are using for your application. Okay, so the next thing is the receiving listener evaluates the incoming request against the rules you specify, and if applicable, routes the request to the appropriate target group. So a target group is what we will be creating. So there will be 2 target groups, each one for each auto scaling group. So a target group is the one which the application load balancer will take you to according to the rules you specify. So the rules is what we're going to specify. The rules basically would be, if someone searches for URL, they would be taken to server 1 auto scaling group, to the server 1 fleet of servers. If someone is searching for the URL/tutorial, which is a path based, they would be taken to the second set of servers. So that is the auto scaling group 2. Okay, so and our listener would be using HTTP port number 80 because we are using Apache 2, and Apache 2 basically runs on port number 80 and uses the protocol HTTP. Okay, so this is done. Healthy targets in one or more target groups receive traffic based on the load balancing algorithm you choose and according to the routing rules you have specified in the listener. Okay, so now we've already did this part, that is the auto scaling group is going to be the receiving end. So now we'll have to configure the load balancer part, where we'll have to create the load balancer and basically create a listener which will listen to port number 80 HTTP, and then we'll have to create rules in order for a user to be taken to the right server group. Okay, so that's what we're going to do. So to start with, we're going to provide a name. So I'm just going to provide as, let's say, Scalar AWS load balancer. It's going to be internet facing. So the difference between internet facing and internal is, internal you could only, so the clients will be taken to the targets using their private IP addresses, but internal is used for load balancers. You are creating an application for within your, let's say, a company within a closed environment. In that case, go with internal. Internet facing is when you're getting requests from the internet, like I'm giving a request to this particular application from the internet, that is I'm typing in the domain name or typing in the URL. Okay, so then that would be internet facing. And then address type, I'm just going to use IPv4. You can also go for dual stack, because if you have enabled IPv6 addresses for your instances, then there would be no problem, it will still work. Okay, so network mapping. Okay, so this is really important. So let's say if your auto scaling group has servers only on US East 1A and 1B, and let's say you've not selected 1A, if you only selected 1B, 1C and 1D, the instance which is running in US East 1A will not get any traffic in it. So it is better to select all the availability zones if you are not sure of in which particular availability zones you have instances running on. If you are sure, let's say your auto scaling groups only have instances in 1A, 1B and 1C, then you can just select these 3 and your load balancer will only get mapped to these particular availability zones. So availability zones that are not supported by the load balancer or the VPC are not available in the selection, but all the 6 availability zones in region North Virginia is available. So once the load balancer get created, all these subnets will get added to it. Okay, done. So then you can select the security group accordingly. It's just using the default security group, so I'm just going to leave it because I want all traffic. I want anybody to basically type in the domain name and get access to it. Okay, so the first thing is port number 80 protocol. Okay, so it should be forwarded to server 1 target, server 2 target. So there are 2 targets over here. So I'm not going to provide anything over here right now because I have not created any target groups. So before providing that, let's create 2 target groups for our 2 auto scaling groups. Okay, so I hope you guys understood till here, right? Till this part, security groups. So now let's create target groups and then let's come back and let's resume the load balancer creation. Okay, so first it's going to be instances. It's not IP addresses or Lambda function or application load balancer. Okay, so target group name is going to be, so server 1. Let me just provide target 1 server 1. Okay, it's going to be HTTP port number 80. Protocol version, it can be HTTP, HTTP2 or gRPC. I'm just going to keep it as HTTP1. So health check path is going to be this. So it'll basically send health checks to the root, and yeah, so it'll check if the application is working or if the servers are healthy or not. If the servers are healthy, only then the load balancer will redirect the traffic over there. So over here you can select the instances, but I'm not going to select the instance because we have to attach a auto scaling group to this. So if don't select individual instances here, so don't register any targets while creating the target group. Just create the target group. Once we create the target group, then we can do it. So over here you can just go here and edit attributes. You can also select the load balancing algorithm. So you can choose round robin or you can choose least outstanding requests. So yeah, so I'm just going to go with round robin. Round robin will basically select a random server and basically send the request over there. Okay, so we've created one target group. Let's create another one. So it's the same thing, only difference would be the target group name here, server 2. Everything else will be the same. Again, I'm not selecting anything. Create target group. So right now we have only created the target groups, guys. So now the application load balancer we are creating, we have not created yet. So we've created 2 target groups and we have created 2 auto scaling groups. So now how exactly you will establish the connection between the load balancer and the auto scaling groups? So that's why we need targets in the middle. So load balancers, auto scaling groups. So the load balancer will take you to the right auto scaling group according to the target in between. So now there are 2 auto scaling groups with 2 targets. So if the load balancer is taking you to target 1, then you will be taken to auto scaling group 1. If you're taking to target 2, you will be taken to target auto scaling group 2. Okay, so now we'll have to connect it to target 1 and server target 2, right? So for that we'll have to go to auto scaling groups. So I'm going to select this, edit. Over here, load balancing, right? We have to select load balancers, click on application, network or app gateway load balancer target groups. So select target groups, and the target group I want it to be connected is target 1 server 1. Okay, done, and that's it. Update. So now we have attached server 1 auto scaling group which has the server 1 to the target group 1. Okay, so now we have to do the same thing over here, edit, select here, and we're going to connect it to target 2. Okay, so now provided that, just update it. Done. So we have now attached the auto scaling groups to target. So now we only have to do, the thing we'll have to do right now is basically to combine or connect the load balancers with the target groups, which is already connected to the auto scaling groups. So if there is already a connection established, so the only thing we'll have to do is change here. So now whenever people are just typing in the URL of the load balancer, they should be taken to the target 1, so server 1, right? Okay, so now this is basically the first listener. I just want this listener to be available right now. Regarding the target 2, we can create one more here, but I don't want that. I just want it to listen to port number 80 because both the servers are running in port number 80. The default action is going to be default action in the sense whatever happens, if you're searching for the load balancer's URL, you'll be taken to server 1. Okay, you won't be taken to the auto scaling group 2. You'll be taken to the auto scaling group 1. So for now, let me just create this. So once we create this, then we can change the rules. Okay, so create load balancer and view load balancer. Okay, so load balancer is getting created, guys. Over here, if you see, so this is the DNS name. So DNS name in the sense, this is the URL. So right now, if I type in, it won't be visible. So it has to be running. So right now it's provisioning. So once it's available, only then it will be showing you. So right now, let me go to listener. The first auto. Okay, so this is the listener, the one listener we've created, right? So by default, it will take us to server 1, that is auto scaling group 1. So we can edit the rules for it to do something else as well. So to edit the rules, just click on plus and click on insert rule, add condition. I want it to be done according to the path number, the path value. So if somebody searches for /tutorial, okay, I want them to be taken to target 2 server 2. This is the target which is connected to the auto scaling group number 2, right? So that's what I want. Okay, so traffic distribution also can be made. So for example, let's say there are 2 target groups. Let's assume there are 2 target groups which has the same website running inside of it. So you can basically change. So let's say you can provide this as 70 or you can just provide it as 7, and you can provide it as 3. So the traffic will be distributed 70% and 30% accordingly. So 70% of the incoming requests will go to this target group, 30% will go to this target group. But right now, if people are searching for /tutorial or /tutorial/, I want them to be taken to target 2. Okay, so auto scaling group server 2. But by default, I want them to be taken to the target 1, which is the auto scaling group number 1. So this is the only rule I wanted to add. So now let's save it. And yeah, so that's it, we've saved it. So now going back, yeah, so let's just view if the rule has been updated. So yeah, so that has been updated. Let me go back. Okay, so the load balancer is still provisioning, and okay, so now I've refreshed it, so it seems it's active. So here you can basically see, right, you can see the connection requests and all. So right now there are 0 requests. 0 requests have been made. So this was the URL. So I'm just going to go back. I'm gonna copy the URL, go back to monitoring, go back to requests. So let me provide as the last 15 minutes. Okay, there were no requests. Okay, so now when I type in the URL of the load balancer, I am taken to the auto scaling group number 1, right? So what should happen when I type tutorial? What do you think it should happen? Should it take me to the same server, or it should take me to the server 2? So it has taken me to the server 2. It has taken me to the auto scaling group number 2. So we have 2 auto scaling groups. Whenever we search for the default page, it will take us to the default page. If we search for tutorial page, it will take me to the server 2. Okay, so let's say if I search for something else, it will say not found, because there is no website or there is no web page in this particular directory, and we've not provided in any of the rules. Okay, so I hope you guys understood how exactly this is working, right? When we are searching for the domain name, it will take you to auto scaling group number 1 by default. But when you are searching for a particular path name, we've provided in the rules in the load balancer, it is taking me to the auto scaling group number 2. So let me go to requests, and now you can see there was input over here. Okay, so let me just refresh this once again. Okay, so now let me click on this. So you can see there were 5 different requests. So this will keep increasing if we keep refreshing it. If I search again just for, okay, so now I've searched it twice again. So let me just refresh this, or let me refresh over here. So it will take again some time to show here. Then target response time, this is showing how long it took for the website to be loaded. So it took 0.8 milliseconds. Over here you can see it took 0.8 milliseconds. You can see, so it's HTTP. Rule evaluation, so how many times the rule was evaluated. The rule got evaluated 5 times. Active connection count, there are 8 active connections. So this is basically HTTP 400 counts. Target connection errors, if there were any errors when connecting with the target, if it did not work, that will show here. Let me check last 15 minutes. If there was any error, it will show here, but there were no errors. That's why it's not showing. Okay, so now again, there were 5 connections at this particular point of time, and there was 1 connection after this. So there was 0 connections here. Okay, so the total connections can be monitored right from here, guys. It could be the maximum. Yeah, so 5, 1, 1. It could be the average, or it could be the sum. Yeah, you can provide it accordingly. There were 5 requests, 1 request, 0 requests. Yeah, so it basically changes. And target response time, the first time it took 0.85 seconds, second time it took some 2.24 milliseconds. It will again reduce after some time. Let's see the last 5 minutes. So it's showing the average. Let's see the maximum it took 2.24. I want to see the sum of all. So sum, it took 6.52 milliseconds. So the total response time was 6.52 milliseconds. So there was rule evaluated. It got evaluated 5 times and it got evaluated 1 time. Okay, so the active connection count, it got reduced. HTTP 200s. So this is basically successful connections. If there were successful connections, it will show here. Processed bytes, new connections which happened. So everything could be monitored right from here. Now, so that basically is auto scaling. So auto scaling and load balancing, guys. I hope you guys understood. So now let me go to auto scaling groups. I just want to show you one more thing. That is the monitoring. So here you can view the auto scaling groups monitoring. Okay, so over here you can see pending instances, total instances. There were 2 instances, and there are still 2 instances. Instances were not increased. Total capacity, terminating capacity. Yeah, so basically you can check out everything right from here. You can check out individual metrics of the EC2 instances from here as well. So CPU utilization can be viewed here. So let's see the last 15 minutes. So you can see CPU utilization of the EC2 instances. This is the average. You can see the maximum, you can see the minimum. So everything can be viewed right here. So this is basically it. So we've combined EC2 auto scaling, load balancing, and also we've combined CloudWatch in order to create this particular demo. So I hope you guys understood, and also please try to do this by yourself. Please try to understand each and every step of doing it. So you can learn EC2 auto scaling, you can learn load balancing, you can learn how to use CloudWatch and create CloudWatch alarms, how to set up a scaling policy right from this particular tutorial. So I hope you guys have understood. So that is the last part, guys. So if you want to know how to delete the load balancer, so the first thing you'll have to basically do is delete the auto scaling groups. And once you delete the auto scaling groups, so let me try to delete this. Okay, so the load balancer got deleted, and then you can delete. So cleanup is also important, because if you just let them run, that will not be a good idea, because you will get billed after a certain point of time. So I'm deleting the auto scaling groups, and then delete the target groups if you don't need them. Target 1 and target 2. So when I delete them, let me see if they're deleting. Yeah, so they got deleted. And one more thing is that if you delete the auto scaling group, the instances attached to the auto scaling groups will also automatically get deleted. So you can see every instance is getting shut down, so you don't have to go back to the EC2 console and delete them. And so AMIs also will get charged. So if you don't need the AMIs, you can also delete the AMIs. So just deregister it and done. So this is basically a cleanup I wanted to show. So I've deleted the auto scaling group, the load balancer, I've deleted the AMIs, I've deleted the target group. So everything has been deleted successfully. So if you want, you can just go back to CloudWatch, and go to alarms, and also delete it. So under free tier, you are allowed to have 10 alarms at any given point of time. So you can have 10 alarms, but if you go more than that, you'll have to pay for each alarm. Also, so one more thing I wanted to just give you guys. So you can view the bill in the billing dashboard. So if you're using all the services within the free tier limit, you won't get billed. If not, you will get the bill over here. And if you want to see the bill for each and every service you've used, you can view it over here. So how much you used for load balancing. Over here you can see, right? So this was for the load balancer which I created right now. So you will get charged because mine is not a free tier account. So I'm getting charged. If you're under free tier, you won't get charged for this because you would have a free tier capacity. And EC2 same thing. So according to that, make sure you use your free tier, try to utilize your free tier to a maximum, try to understand all the AWS services to the maximum. So that's basically it, guys. So thank you so much for attending this particular AWS tutorial. So guys, that's it for today's session. I hope it was helpful and informative for you. If you have any queries, leave a comment down below and we would be addressing them and helping you out. And also leave a like if you enjoy our content, and share and subscribe if you want to help us out. Thank you. Hey guys, welcome to yet another video by Scaler, and in this particular video we're going to look into interview questions specifically on Amazon Web Services. So before we move on with this particular session, please make sure to subscribe to our channel so that you don't miss our upcoming videos, and also leave a like if you enjoy our content. If you have any queries, leave a comment down below and we would love to help you out. So now, before moving on, let's just understand what exactly is going to be covered in this particular session. To start off with, we'll be covering certain basic AWS interview questions that we'll be understanding and asking few very basic questions like what is EC2 and what is this particular service and how it works. All these basic questions will be covered. And then we'll move on to the advanced questions and we'll understand even more services, and also services which are basic in nature, but we'll also look at them in a more in-depth manner. Okay, so this is what will be covered in this particular session. And also guys, did you know that we do have a blog where we are covering all of these insights and important questions and topics, where we exactly are covering AWS and AWS interview questions. So that is available in the description, the interview bit blogs. You can go check that out. So now let's just, before moving on, I'll just give you a brief about how exactly to address in an interview, because this is exactly about interview questions. It's not just about giving technical answers, right? You should also know how exactly to answer them and what not to answer. So first of all, take your time. So when they've asked you a really huge question which needs some time to think, do not go on and start speaking something which you already have a little bit of knowledge about. Just try thinking about it once, try to solve it in your head, and then go ahead, until and unless it's a quick knowledge-based question. If it's a quick knowledge-based question, obviously you have to give an answer really quick. If it's a lengthier question, then take your time and then answer. Give a proper answer. Second, ask questions. This is really important. Do not say I don't have any questions. Ask about what the company is doing. Ask about what are the current projects which are going on. Like obviously they won't give away all the details. They might give you one or two insights about it, right? Always ask questions. So these two are really important. Once that is done, then basically try to be more attentive to what exactly is going on, and also try to basically indulge in what exactly is going on. So do not say I don't know, or no, I do not know that. Just don't try to do those things. If you do not know an answer, try that. Try to saying like, I do not know this, but I'm gonna learn this once I'm going to go out of this interview. And obviously if this is necessary for a job, I'll be able to learn it quickly as I'm a fast learner. So you'll have to basically try to turn your weakness into a strength. So that exactly is the last point which I want to talk about. Now, without any delays, let's begin with the session. So guys, we've understood what exactly is going to be covered in this session. So now let's start with the basic interview questions. So again, in the basic interview questions, some questions would be, the explanation would be less, some the explanation would be more, even though it's basic, so the explanations can differ. So you don't have to basically explain every single thing about a question which is asked to you. For example, let's say the first question is what is EC2? EC2 is the most common service. So it's the first service anybody would learn when they're getting into AWS. You might have learned a different service, but EC2 is the first thing most people would understand and learn when they are getting into AWS or any cloud platform. Virtual machines on cloud would be the first thing they'll be learning. So now, when somebody is asking you what is EC2, it's not necessary you'll have to explain every single thing from scratch. You don't have to tell them what exactly is a virtual machine first. Then you can tell, so that's exactly what we have replicated in cloud. Then you don't have to explain what is an hypervisor in order to tell them how exactly a virtual machine is created. You don't have to tell all that. You just have to tell them what is that particular answer for that particular question. So in this case, for the first question, which is what is EC2, the answer is EC2, a virtual machine in the cloud on which you have OS level control. So I think this particular line sums up everything. So it's a virtual machine which is running on the AWS cloud for which you get OS level control. So you will be able to control the processes, you'll be able to install software, you'll be able to deinstall, uninstall software, you'll be able to manage everything around that particular virtual machine, right? So these are the things which you will be able to do. So you can run this cloud server wherever you want and can be used when you need to deploy your own servers in the cloud, similar to your on-premises servers. And when you want to have full control over the choice of hardware and the updates on the machine. So for example, let's say if it's an on-premises servers, right? So you would have complete control over them. Even the network would be yours. But when it comes to AWS, the network would be AWS's, but you would be basically given OS level control. That basically means sometimes you can also select. There's something called reserved instances and on spot instances where you can also have authority over the choice of hardware, right? Even on-demand instances, that is normal virtual machine, gives you to choose the choice of hardware. That is, you can select how much storage you want, how much memory you want, how much virtual CPUs, that is cores you want. You can choose all of those hardware components, but it wouldn't give you complete control over how exactly that is, because they wouldn't let you choose 3 GB or like 7 GB. There would be certain numbers. There would be 1 GB, 2 GB, 4 GB, 8 GB, 16 GB, like that. So you wouldn't be able to choose an odd number or something. So you wouldn't be able to modify it, but you will be able to choose what exactly you need. So to be very simple, the answer you will have to give in an interview would be, it's a virtual machine which is running on the cloud, and you have OS level control to it, so that you can install software, you can use it as a web server if you want to, you can use it as a database server if you want to, you can use it as any server you want to. You can also use it as a PC. You can use it as your own computer, normally how you use your own computer, right? So you can use it like that because it's simply a virtual machine. You can literally do anything on it. So that's exactly what EC2 is. And EC2, the full form is Elastic Compute Cloud. So most probably you would know, and the person would know. It's not necessary that, first of all, Elastic Compute EC2 basically means Elastic Compute Cloud. You don't have to say that. It's not necessary, because I'm pretty sure most of you would have done this in an interview before. But moving further, you don't have to abbreviate something to someone when they're asking you something. You just have to explain what it is. Then they will understand you know it. You don't have to tell the full form, right? Okay. So now this is the first question. That's why I wanted to give you some insights about how exactly you can answer and frame your question. From here on out, I'll be just giving you the answers for the respective questions. So now, what is Snowball? So Snowball is not a feature, or it's not a inbuilt service like EC2 or S3 or RDS. Snowball is basically a small application that enables you to transfer terabytes of data inside and outside of the AWS environment. So it's a small application which runs on Snowball, which is a hardware device. So Snowball is a hardware device. For example, let's say you want to transfer terabytes or petabytes of data. What they do, basically, you can request to Amazon, that is request to AWS, you need to transfer this much data, you would need Snowball. So they would be transferring Snowball to you, to your company's data center. You would be able to create a job. That is the first thing. You would be able to create a job, right? You would be able to create a job, and once you create a job, that transfer would go on by connecting to the Snowball, and the data would be copied to the device. So now once the data is copied to the device would be given to AWS, and AWS would basically upload it to S3, where your data would be successfully uploaded and stored. So that's basically it. It's pretty simple. This is what you can tell when somebody asks you what is Snowball. Okay, next comes CloudWatch. So what is CloudWatch? CloudWatch helps you monitor AWS environments like EC2, RDS instances, CPU utilization. It also triggers alarms depending on various metrics. So to be very, very simple, CloudWatch is a monitoring tool which essentially and especially monitors AWS resources. That's EC2, RDS, all of those resources would be monitored by CloudWatch, even if you haven't enabled, because CloudWatch is a free default service which is already running there, and it will basically give you all the details and metrics you need. For example, if you take EC2, you would be able to see how much network, that is network in, network out, how many packets have come in, how many packets have went out, the CPU utilization. There are so many other metrics which you can go through for every single AWS service you want to look into. There is also a paid part of it. For example, in certain resources, there would be something called enhanced monitoring, which you can select. Enhanced monitoring will give you even more in-depth monitoring ability, but that would be a paid one within CloudWatch, but usually you can just go with the free service if you're just practicing CloudWatch, right? And one more thing which is called alarms here. Alarms is basically a service, a feature built in CloudWatch. For example, let's say you have one EC2 instance, and whenever the CPU utilization of that one EC2 instance goes above 90%, you want another EC2 instance to be created. So in that case, you set up an alarm that will trigger itself when the CPU utilization of that particular instance goes above 90%. And when it goes above 90%, that obviously CloudWatch is monitoring, and it will get that data. And once it sees that it's crossed 90%, it will automatically basically it will send a request to EC2, and EC2 will launch another server, right? So this is how it works. So that's a basic example of what alarm is. Next is, what is Elastic Transcoder? So Elastic Transcoder is an AWS service tool that helps you in changing a video's format and resolution to support various devices like tablets, smartphones, and laptops of different resolutions. For example, let's say you're creating an application and you want to have that application, in that application you want a video streaming platform. Okay, so in that case, if you are uploading a video, usually let's say you are creating a web page, you are creating it for the desktop, and you upload a video, and if you try to open that website in your mobile, right, all of your basically the resolution wouldn't, sometimes it wouldn't match, it would be kind of jumbled, it wouldn't be working properly. So you would be able to do, you would be able to basically solve that using Elastic Transcoder. So that's basically this particular tool. Next comes VPC, what you understand by virtual private cloud. So it allows you to customize your networking configuration. So again, without networking, you can't do anything in AWS. So without networking, you can't do anything in AWS. To be very simple, if you are in a company, let's say even if you have an on-premises data center, without networks, you can't do anything, right? Because every single server is connected together because of a network. Without, so a network is basically that. It's multiple servers connected together, or multiple computers or multiple clients connected together. So without a network, there can't be any communication between other computers. For example, without networking, there is no internet, right? So internet is basically a connection between other computers, right? So there are multiple routers which the internet goes through. There are various types of internet. Let's not discuss that. But again, without networking, you can't do anything in AWS. So the first and foremost important thing which you'll have to create, or it's already available in AWS, which is a VPC. So by default, there is something called a default VPC. When you start practicing AWS, you can use the default VPC. But if you are not using the default VPC, in that case, you can create another VPC and create subnets within it. So let's not cover subnets right now. When that question comes, I'll cover that. So VPC is a network that is logically isolated from other networks in the cloud. So even in your AWS account, if you have two VPCs, and let's say you create a server EC2 instance in VPC1 and EC2 instance in VPC2, so these two EC2 instances will not be able to communicate with each other because they are isolated from each other, because they are in two different networks, right? The only way they'll be able to communicate with each other, if the instances are public, they'll be able to communicate through the internet, right? If otherwise, there is something called a peering connection in VPC. You can create a connection between two VPCs, and these two instances will be able to communicate through that. Okay, so now it allows you to have your own private IP address, internet gateways, subnet, security groups. So these are all other concepts. So for now, when somebody asks you what exactly is VPC, you can tell that it basically lets you configure and customize your networking settings in AWS. And the foremost concept is basically it is logically isolated from other networks in AWS. Even within your account, it still isolates one VPC from another VPC, right? So when you create a VPC, you will be giving certain things, like you would be giving a CIDR notation. So within that CIDR notation, so your VPC will have a range of IP addresses. So whenever you create a resource within the VPC, the resource will have an IP address within that particular range, right? So these are the things. There are more things to VPC. VPC is a really huge concept, but when somebody asks you, these 3 points is more than enough. Just say it's the tool which is required to customize your networking configuration. It logically isolates that particular network from other networks in the cloud. Third one, it lets you basically create resources within it, and it will assign private IP addresses within the IP address range given to the VPC. Okay, so these are the things which you can take. Okay, next, DNS and load balancer services come under which type of cloud service? This is a pretty straightforward question. It will be a one sentence answer. So they are part of infrastructure as a service storage cloud service. Okay, so basically DNS, it's a domain name server. Next is load balancer. So what type of cloud service they are? So they are saying that they are infrastructure as a service. So infrastructure as a service in the sense they are providing you infrastructure over the internet. For example, EC2 is an infrastructure as a service. They are providing you a server over the internet which you will be able to use. So that basically is an infrastructure as a service. In this case, they are giving you a domain name server over the internet and a load balancer over the internet. So that they are also infrastructure as a service because they are infrastructural components. There are other services. There's platform as a service and software as a service. So we'll talk about that later. For now, whenever something relates to infrastructure, that basically means what does load balancer do? It balances the load and sends the what is that, the incoming requests across all the servers according to the rules you have provided. For example, if you're just going with a classic load balancer, a traditional one, so let's say there are 100 requests coming in and there are two servers. So first request will go to the first server, second request will go to the second server. For example, let's say this is the cloud and users are trying to access the website which is running inside these servers. So when a first request comes in, it goes to server 1. Second request goes to server 2. Third request goes to server 3. So this is a traditional load balancer. So now load balancer does this, and that's why it basically is an infrastructural component which helps you do this. That's why it is an infrastructure as a service. It's not platform as a service because it doesn't provide you a platform to do some operations over it. It's not a software as a service because it's not a software at all. Software as a service, Gmail is a software as a service because it's a software given to you over the internet, right? So I think it's pretty clear they are infrastructure as a services. Next, what are the different storage classes available in S3? So right now there are around 6 storage classes: S3 Standard, S3 Intelligent Tiering, S3 Standard Infrequent Access, S3 One Zone Infrequent Access, S3 Glacier, and S3 Glacier Deep Archive. So you can check out this. All of the storage are provided 11.9's SLA, and over here availability SLA is also provided. So SLA basically is Service Legal Agreement, which basically means that Amazon is promising you that this particular resource will be available 99.9% of the time. So that's what they are giving you. So they are saying it wouldn't go down at all. Even if it goes down, it would be just for 0.01% of the time. And let's not discuss more into it. Let me just briefly explain this. So that's all you have to say. So the storage classes are standard, which is the default storage class, which will be given to you when you create a S3 bucket, right? And then there is intelligent tiering. There is standard infrequent access. So intelligent tiering basically is, you can see minimum storage duration is 30 days, and in this case the only difference between standard and intelligent tiering is it's a little more expensive, and it has a minimum duration period over here, but other than that they are pretty much the same. But standard infrequent access is different from standard because standard is considered as hot storage. That is, when you store something in standard, you are basically saying that that particular objects are frequently accessed by someone. But if you store in standard IA, which is standard infrequent access, so you are stating that it's not frequently accessed. Okay, so that's what you are stating. Yeah, so basically that's it. And then coming to one zone, so in these cases, the data will be available in 3 or more availability zones. But when it comes to S3 one zone, it will be stored in just one zone. So that's basically the storage class name. This is not a good practice, but sometimes if it's not important data or old history data, you just want to have it there on AWS, then you can have it on this. For example, in that case, if that availability zone was down, you wouldn't be able to retrieve that data in that particular period of time until AWS comes back up in that region. But that's a risk you would have to take because it's not designed for availability. You can see it's 99.5% of the time it's available. All the other services have 99.99. Intelligent tiering has 99.9. Glacier and Deep Archive have 99.99. So you can see the difference over availability because it's only available in one zone. right? Okay, next comes Glacier and Glacier Deep Archive. The only difference between Glacier and Glacier Deep Archive, you can say the time, the minimum duration, and one more would be the so this Glacier Deep Archive would be much cheaper than Glacier. Why? Because you will be able to download stuff of Glacier within minutes or hours, but in Glacier Deep Archive it will take several hours because Glacier is a backup storage service. You will be able to back up your data. That's why the minimum storage duration for any data you store on Glacier is 90 days. You cannot delete them before 90 days. That's the minimum lock-in. When it comes to S3 Glacier Deep Archive, it's 180 days because these are data which you're archiving, which you don't want for now. You just want to archive them, like something company history data or project history data, whatever it is, you can just store over there, right? So these are different types of storage classes. What are explain what T2 instances are. Okay, so T2 instances are one particular type of instance in EC2 instance types. There are so many different types. For now, let me just explain this. So T2 instances are designed to provide moderate baseline performance and the capability to burst to higher performance as required by the workload. So each types of instances will have a separate like what is it, separate need to satisfy. So T2 instances are created to provide a baseline performance, that is regular performance, and also whenever the workload is increasing, they are equipped to give you a burst in performance which will increase the utilization of the CPU in order to provide you a better handling of the workload, right? So that's exactly what it is. So these are the different types of instances within T2: dot nano, dot micro, small, medium, large, X large, and 2X large. So you can see, so this is virtual CPU. That basically means how many cores that particular instance has. So the nano, micro, and small have one core each. Medium and large have two core each, and large, X large, and 2X large have 4 and 8 core each. Right. So the difference between micro, small, and T2.small comes within the memory range and the CPU credits. So let's not go into CPU credits. That's a whole other concept. So memory. So let's just understand the storage and memory and the virtual CPU. So we already understood virtual CPU. So memory, you can see Nano has only 0.5 gigabytes of RAM. Micro is 1. Small is 2, medium is 4, 8, 16, 32, right? And performance low to moderate, low to moderate, low to moderate, low to moderate, moderate, moderate. So nothing gives you high network performance. All are nominal performances. So if it's for a practice project or a demo project, go with T2 instances. So also T2.micro is the free tier instance which is provided to you. This is the free tier instance which you will be able to use when you want your instance for free. All right, so these are basically T2 instances. Coming to the next question, what are key pairs in AWS? So when you create a virtual machine in AWS, you would have to create something called a key pair. If you already have a key pair, you don't have to create it. You can use the previous one which you already have. But if you do not have, you will have to create a key pair. Without that, you will not be able to create a virtual machine. So it is secure login information for your virtual machines. So how exactly it works? You will be given a public key and a private key. The public key will be stored in the virtual machine. The private key would be given to you that you will be downloading and storing in your local PC. So when you are trying to log in into the server, right, you will have to upload the private key. So it should be the same private key which is given to you, because only that particular private key will be able to decrypt the public key. Only if it's able to decrypt the public key, you will be given access to the instance, right? So that's exactly how it works. It's pretty simple. Private key, public key. With this private key, you will be able to decrypt the public key. Once it is decrypted, then you will be given access to the server. Then you can start using it. That's basically key pairs. It's pretty simple. Okay, now how many subnets can you have per VPC? So in a VPC, you can create subnets. So you can have about 200 subnets in a VPC, and also it's a matter of IP address ranges available. You can still have more, but again, if you want more subnets than this, you will have to consult. You will have to basically mail AWS support. But usually by default you will be given access to create 200 subnets per VPC. So subnets are basically sub networks within the VPC. Again, it's a logical concept, right? Even VPC itself is a logical concept. It logically isolates your resources. Same way, within a VPC, you can create something called subnets, which are subnetworks within the VPC, where you can even isolate the resources within the VPC from themselves. So let's say you can have 10 instances, and there can be two subnets, and 5 instances can be in one subnet, and another 5 can be in another subnet, and they can be also isolated from each other if they don't have any connection between them. So they can only privately communicate with each other if there is a communication portal between them. If not, they wouldn't be able to do it. So that's basically it. Okay, so you can have up to, so for this question the answer would be you can have 200 subnets per VPC. I just wanted to give you a brief about subnets. Okay, next is list different types of cloud services. This is a pretty straightforward question, and mostly it won't be asked in a again, it's a basic, but these are basic questions. That's why this question has come up. So software as a service, platform as a service, infrastructure as a service. These are the three essential ones. Data as a service could be added if you want to, because if you add data as a service, there are other types of cloud services which could be added, like function as a service, like big data as a service, AI as a service. You can add so many things, right? As a service is just a term. So mainly there are three types: software, platform, and infrastructure. When you talk about software on remote servers. For example, let's consider Gmail. The Gmail is running on a remote server on Google's data center somewhere. You don't know where that application is running. You don't know where the application's code is residing. You do not know where your emails are getting stored. It could be stored in any data center of Gmails. So you wouldn't know all that, but you will be still able to access the software itself, right? So that's basically software as a service. You will be given access to the software, but you will not be given access to anything else apart from that. You will only be able to use the software. Next comes platform as a service. So in this case, application development and deployment. So to be very simple, in this case you'll be given a platform which will give you a little more access. So you'll be able to build something using this platform. For example, in AWS there is a platform called Elastic Beanstalk. If you guys want, just type it in Google and see what exactly it is. So I'll just give you a brief. So it lets you upload your code, and it will automatically provision instances, that is EC2 instances, and upload your code and install all the software necessary, and your website will be up in no time. You don't have to do anything else. You just have to upload your code properly, but your code has to be optimized for Elastic Beanstalk accordingly. But all you have to do is create the application and upload it. Beanstalk will take care all of it. That's the infrastructural part would be taken care of Beanstalk. So the only thing you will have to worry about is the platform, handling the platform, right? So that's basically platform as a service. Now coming to infrastructure as a service, as I already explained to you what is EC2. So servers, storage, operating systems. So S3, EC2. So these two are basically infrastructure as a services. So S3 basically provides you storage. You will be able to upload and download and delete and do every operation which you can basically do in your own personal computer. So it lets you do all that. They're providing infrastructure via storage. EC2 gives you infrastructure via servers. So in this case, what they are basically doing is they're giving you, like let's say they're giving you operating system level access to servers. So that's exactly what infrastructure as a service is. In this case, you will be given the access to the server itself. For example, in this case, you only get access to the software, only the platform. Here you get access to the infrastructure itself. You can install any software on it as you want. Okay, so now we've seen the basic questions. I hope the basic questions were helpful. Now let's move on to the advanced questions. Right. So also at the end of this particular session, guys, I'd be asking you a question. So if you know the question, please put down in the comment section. I'd be asking it to you. So for now, let's just try to understand everything about AWS interview questions. Now moving on, we'll be looking into advanced questions. So make sure you understand the basic questions. Make sure you just go ahead and check the documentation, just cross-reference everything. So I've given you the answers, right? You just cross-reference everything, make sure everything is clear for you, because some of these questions are pretty small. If you want to know more about key pairs, go to the documentation and learn more about key pairs. But we are just trying to give you answers for the questions asked, right? Alright, so now advanced AWS interview questions. Okay, explain what S3 is. So S3, it's called a simple storage service. So S3 is basically a storage service where you can store, retrieve, delete any amount of data. Basically, virtually unlimited data can be uploaded and downloaded like at any time using the internet. So basically, the payment is pay as you go for most of AWS services. So especially in S3. So basically, let's say you upload 2 gigabytes of data, you only have to pay for the 2 gigabytes of data which is uploaded. And if you deleted that, you don't have to pay anything because there is nothing stored on AWS at that point of time. So basically, you only pay for what you use on S3. So in this case, why I say virtually unlimited is you do not know how much storage space that AWS have. You can literally keep uploading how much ever data you want. AWS wouldn't stop you because obviously you are going to pay them for the data which you are storing, right? So they obviously are a for-profit business who are profiting from this. So they will provide you unlimited, virtually unlimited, because there will obviously be a limit to the data which you can store, which would be really high. You wouldn't have that much data to store, obviously. But again, that's basically what S3 is. It's a storage service which lets you store petabytes or even exabytes of data on it, and you just have to pay for what you use. Okay, next question. How long does Amazon Route 53 provide high availability and low latency? Okay, so the question basically is, how does it provide high availability and low latency? Why should I not go with GoDaddy or any other DNS service, right? Why should I choose Amazon Route 53? So now they're explaining that. So first of all, it provides a globally distributed service. AWS again is the biggest cloud network right now, uh, and obviously they have data centers all around the globe in most of the countries, and they literally have in every single continent, right? They have data centers in every single continent. So that basically helps them serve your website to every single person around the world. You'll be able to serve your website. Let's say you're in India, you're creating a website and you want your product to go global, and you want your application to be available for every single person around the globe. So you can use Route 53 to do that. Next comes dependency, and finally optimal locations. Now let's come from the top. So Amazon is a global service and consequently has DNS service globally. As I told you, they have data centers all around the globe. Any customer creating a query from any part of the world gets to reach a DNS server local to them that provides low latency. So low latency in the sense, they're asking how exactly Amazon Route 53 helps you in order to make sure your application is really fast for any user around the globe. So if the application is if the headquarters is in India, the main customer base in India, so then it makes sense to provide low latency to customers in India. But how exactly Route 53 provides low latency to every single person in the world if you're using this application in a global level? So that's how it is doing, by providing them a local server which is nearby them. So they'll be taken to the local server. From there, they'll be routed to the actual place where the website is hosted, or they could just, if the website is available globally, then the local server itself would be able to give them the access to the website. So that's basically how low latency is maintained. Dependency, Route 53 provides a high level of dependability required by critical applications. So again, you're paying AWS for something. They are the cloud leader right now. So obviously the dependency is there. They give you a high level of dependability required by critical applications. Even though it's a critical application, you could run on Route 53 and it will make sure it is running really well. That provides the website high availability. And finally, optimal locations. So Route 53 serves the request from the nearest data center to the client sending the request. Whenever a client sends a request, let's say my main customer base is in India, and there's a customer from, let's say, Ethiopia trying to basically send a request, and they're sending a request, and they'll be taken to the nearest data center to them, so that it's much faster for them to get the website shown in their browser, right? So AWS data centers are across the world. The data can be cached on different data centers located in different regions of the world, depending on the requirements and the configuration chosen. Route 53 enables any server in any data center which has the required data to respond. This way it enables the nearest server to serve the client request, that reducing the time taken to serve. It's basically caching. So the website will be cached in the nearest local server, and as it is already cached, it doesn't have to travel all the way to the original server to get the data back. It can just use the cached information and just return it to the user. That would be quick and the user would be happy about it, right? So this is how Route 53 does it. So there is obviously more to it. That's what we're going to look at right now. For example, let's consider, please cut that small part which I didn't speak. Okay, so now let's consider the requests are coming from a user in India or served from the Singapore server, while the requests coming from a user in the US are routed to the Oregon region. For example, let's say the application is in the US, right? The application is in the US. So now this is the Oregon data center. This is the Singapore data center. So let's say this website is not available in Indian data centers. So now a user is basically trying to request, right, some data on the website. So the user is requesting from India. So request from user routed to Oregon region. So this is basically for this. So now when a request comes from the Indian user, Route 53 checks for the nearest server. So the nearest server this time would be Singapore. So in this case, the request from the Indian user would be redirected to the Singapore server and the data would be given back to the user as fast as it can. But if a user from the US region itself is trying to access, they will be taken to the nearest server. In this case, it's Oregon. So this is how it maintains high availability and low latency. So this is especially for low latency, not high availability. For high availability, there are so many different things which you can talk about. Other AWS, so there are multiple data centers, so your application can be replicated in multiple data centers, even though one data center is not available. For example, even though if the Singapore data center was not available at that particular point of time, Route 53 would have taken them to the next nearest server, right? Next nearest data center. So that's exactly how it provides high availability. Okay, so now coming to the next question, how can you send a request to Amazon S3? So it's a REST service, and you can send a request by using the REST API, which is available, or you can use by using the AWS SDK wrapper libraries that wrap the underlying Amazon S3 REST API. So basically, you can use the REST API manually in order to do it, or you can use AWS SDK, and you can basically create a piece of code, and you can use that code. Whenever you run that code, it will send a request of whatever request you want to by using the wrapper libraries which you have created, right? So that's how you can do it. Moving to the next question, what does AMI include? So first of all, AMI basically means Amazon Mission Image. So an AMI includes the following things: template for the root volume for the instance. So how exactly the root volume should be formed, how much storage it should have, and what are the things which it should have. Okay. Second, launch permissions to decide which AWS accounts can avail the AMI to launch instances. So when you create an AMI, you can choose whether it's public or private. If it's private, only that particular AWS account would be able to do it, but that particular AWS account would be able to give access to another AWS account even though it's private. But you can also convert it into a public AMI. In that case, every single person in the world would be able to use your AMI to create or launch an instance. Now, a block device mapping that determines the volumes to attach to the instance when it is launched. So whenever the instance launches, it needs some volume to be attached, right? So that particular volume is basically so that information is also stored in the Amazon Mission Image. So basically, when you use the Amazon Mission Image, you can launch one instance or you can launch multiple instances according to whatever is your requirement. But the AMI will contain all of these things: the template for the root volume, the permissions to launch in whatever AWS accounts, and finally the block device mapping, that is what are the different types of block devices which needs to be attached to this instance. So when the AMI is creating, it will also basically launch the volumes and attach it to itself. So this is basically what an AMI is, right? If you want to know more about AMI, you can go check it out. So what exactly AMI is? It's a template which is used to create instances. So you can't create an EC2 instance without an AMI. Okay, so that's basically AMI. Coming to the next question, what are the different types of instances? So we saw one type of instance. So that is one singular type of instance, but these are basically the groups, the types. So basically groups in types of instances. So there is a compute optimized, there is a memory optimized, storage optimized, accelerated computing, and general purpose. So the T2 instance type, which we previously saw, was a general purpose type of instance, which is basically used for generic usage, and also it will provide you a burst in performance whenever required, but it's mostly basic. But compute optimized will basically provide you really good processing power. So basically it will provide you more CPU cores than the RAM provided. Okay, so that's basically compute optimized. It will be optimized for compute. Memory optimized is optimized for memory. That is, it will give you more RAM, but the cores will be less. The virtual CPUs would be, the number of the virtual CPUs would be comparatively less than the RAM. So this is for memory. So if there is any in-memory processing, you would have to choose a memory optimized instance type. Storage optimized, this is for storage. So for example, in this particular EC2 instance, there is often data coming in, data going out. You want the data read and write to be really, really fast. In that case, you should go for storage optimized. So that's exactly why you should go for that. Finally, the accelerated computing. So this is basically for example, if you're running an artificial intelligence model or a machine learning model, or if you're transcoding videos, or if you're rendering videos or graphics on the server. In that case, you need accelerated computing, which would provide you a really high performance for these kinds of requirements, right? So these are different types of instances. Coming to the 17th question, what is the relation between the availability zone and the region? So to put it very simply, the region is the entire region. So there could be so the regions are geographical. Within the region, there could be any number of data centers, but usually around there are 6 to 7 data centers in AWS. So an AWS availability zone is a physical location where an Amazon data center is located. On the other hand, an AWS region is a collection or group of availability zones. For example, let's consider in US, there are so many different states. So for example, when they say Oregon, right? In Oregon, there could be multiple data centers in different physical locations, but the group of them in that particular region. So that region, Oregon, is the region, and within that there are multiple availability zones. So they are the availability zones. That's basically it. Availability zones are individual data centers. Region is just to group them together. Okay, so this setup helps your services to be more available, as you can place your virtual machines in different data centers in even different AWS regions. So you can have your data center in Oregon, you can have it in North Virginia, you can have one more server in India, you can have one more server in Japan. So it totally depends on whatever is your requirement. So that's what they are saying. If one of the data center fails, the other one would be running, so that your servers would be always running, and that will make it always available. So this basically provides the failover. It provides you fault tolerance. Even though your server in a particular region goes down, your application wouldn't completely shut down, because there are other regions and other data centers which are actively running. This is basically the difference. It's not a difference basically, because availability zone is within a region. Region is a logical group, but within the logical group there are physical components, which is an availability zone. Next question, how do you monitor VPC? So as I told you already, there is CloudWatch. It's the default tool, but VPC has a separate function, which is VPC flow logs, which will give every single action performed within the VPC as a log. So you can see every single action done in that particular VPC with flow logs. So these are the two different ways you can monitor VPC. So what are the different types of EC2 instances based on their costs? Essentially three types: on-demand, spot, and reserved. On-demand instances are when they are prepared whenever you need. So you can, if I want an instance right now, I can log in AWS and create an instance. That would be an on-demand instance. So that would be created for a short period of time. So basically, on-demand instances are created for short-term requirements. For example, if I currently want to run a particular code and I want to just run a website for a couple of hours just to test it, so then I would go with an on-demand instance, because on-demand instances are more expensive than spot or reserved instances. let me tell you why when we come to spot or reserved, but they are expensive. So it is cheap for a short term instance, but it is not cheap for the long term. It will get much more expensive. So that's basically on demand. Coming to spot instances, so these types of instances can be bought through a bidding model. These are comparatively cheaper than on-demand instances. So in this case, you will have to bid for the instance, and if the instance is available, you will be given access to it. So once you win the bid, you will be able to pay for the instance. Basically, that particular bid amount you will be able to pay, right? So these are spot instances, but reserved instances are the one which companies mostly use for their needs. So why? Because reserved instances are reserved for you. For example, a company wouldn't be like, okay, if I want an instance right now, they wouldn't go right now and create it. They would already reserve some physical hardware which is already available. For example, you can create instances that you can reserve for a year or so. These types of instances are especially useful when you know in advance that you will be needing an instance for the long term. In such cases, you can create a reserved instance and save heavily on costs. Why save heavily on costs? Because when you reserve instances, AWS gives you discounts like 40 to 50%. That's a lot of money, right? Which you can save. And a company wants to obviously cut down on operational costs, and they will always go for reserved instances. For example, let's say there's a new project coming up, and obviously, if a new project comes up, the project will be always live, right? So to once for maybe for the testing and all, you can use an on-demand instance, but when it comes to live, obviously reserved instance would be a much better chance, because if the application is going to be live for a long time, you can take a 3-year reserved instance. It won't be one instance. When it comes to a company, it will be hundred or thousands of instances, basically servers. So in this case, you would be reserving them uh, by using basically using the reserved instances tactic, where you can basically reserve these number of instances for this period of time, that is 1 year or 3 year. You can put a contract with AWS, and you can pay them upfront, or you can pay them monthly, or there are different types of paying models in reserved instances, but it will be much cheaper than going with on-demand instances. It will save you, if it's a 3-year contract, it will save you more than a 1-year contract, because you're reserving instances for a 3-year period of time, right? So these are basically different types of instance based on costs. Coming to the next question, what do you understand by stopping and terminating an EC2 instance? Really easy question, but it comes with certain complications. Even though stopping and terminating may sound similar, but in EC2, it's totally different. Stopping is basically shutting down your system. For example, if you shut down your system and restart it, the PC is still there, right? If I shut down my laptop and open it back and switch it on, it'll still switch on, the instance will still be available. It'll have the storage, it'll have all my files, everything will be there. You can just start from where you left off. But terminating is basically like selling your laptop to another person or breaking your laptop. So once you break your laptop, you can't do anything to it because it doesn't exist, right? So that's basically what terminating is. You're completely deleting the instance, and so nothing would be available. The instance would be deleted, the data would be deleted, this volume will be deleted, everything will be deleted. You would not be able to restart or look into the system later in time. So that's basically the difference in stopping and terminating in EC2. I hope that's clear. Okay, coming to the next question, what are the consistency models offered for modern databases by AWS? So eventual consistency and strong consistency. So coming to eventual consistency, it basically means the data will be consistent eventually, but not immediately. So let's say there are two databases. If I upload some data to this database, I want it to be available in this database as well. But eventual consistency basically means it will get consistent eventually in time, but once I upload it, it won't be immediately replicated. It will take some time to replicate it. So this will serve the client requests faster, but chances are that some of the initial read requests may read stale data because that data wouldn't be available at that point of time, because it's not transferred to the other database. So this type of consistency is preferred in systems where data need not be real time. So if you don't want the data to be real time in a particular system, in that case, you wouldn't want this. So you would want this type of consistency. For example, if you don't see the recent tweets on Twitter or recent posts on Facebook for a couple of seconds, it is acceptable. So that's where eventual consistency comes into play, because it's not gonna kill anybody, right? It's not a thing which is required immediately. So let's say you're posting something right now and it takes 2 seconds to show up on your profile. that wouldn't hurt anybody, right? So that's basically what eventual consistency is. But strong consistency, it provides immediate consistency where the data will be consistent across all of your database servers immediately. As soon as you upload it to a database server, it will be immediately replicated to the other database servers. Okay, so this model may take some time to make the data consistent and subsequently start serving the requests. So eventual consistency, the data will be available in one database server, but it will take time to replicate to other database servers. So in that case, the data can still be read from that particular database server. But when it comes to strong consistency, as the database servers are currently trying to become consistent by basically replicating it across each other. So when you are trying to request some data, it would take some time because it is trying to make every database server consistent. So however, in this model, it is guaranteed that every single response you get will have consistent data. In the previous one, even though let's say it takes a couple of seconds to show up, it's fine because it's not real time. But in this case, strong consistency, you would need you basically use it for a real time use case. Okay, so this is the difference in consistency models offered. Okay, next question, geo-targeting and CloudFront. So geo-targeting enables the creation of customized content based on the geographic location of the user. This allows you to serve the content which is more relevant to a user. For example, if you take YouTube, some content is available in US, but you won't be able to see that content in India. Or take Netflix, some movies are available in Europe, those movies are not available in China, or that movies are not available in Japan. Why is that? They're using geo-targeting, right? By using geo-targeting, you can basically serve the relevant content to your user. And also, if it's an Indian YouTuber, it wouldn't make sense to show particular YouTuber, that particular YouTuber's content to a American, right? Especially if it's in an Indian language, they wouldn't be watching it. So it doesn't make sense. So by using geo-targeting, you would be able to deliver content in a proper manner based on the geographic location of the user. For example, using geo-targeting, you can show the news related to local body elections to a user sitting in India, which may not be suitable for a user sitting in the US. Why would they want to watch a local body election happening in India? Same thing if there is a baseball tournament in the US which is going on. We Indians don't play baseball. We play cricket and other sports like football and stuff like that. So maybe if it's a football game, we would watch it. But if it's a baseball game, most probably we wouldn't. So yeah, so that's basically is geo-targeting, right? Okay, coming to the next question, what are the advantages of AWS IAM? So IAM means Identity and Access Management. So it enables an administrator in AWS to provide granular level access to different users and groups. So using IAM, you will be able to provide access to a user you created in IAM. So you can basically create users, you can create groups, and once you do that, you can give them permissions to do certain actions. For example, you want to allow a user to basically work only on EC2. You don't want him to work on other services. You can do that. You can provide him permissions to only use EC2. He wouldn't be able to use other services, right? So that you can do with IAM. So it also allows you to provide access to the resources to users and applications without creating roles, which is known as federated access. Also, there is something called IAM roles, which could provide an user temporary access to that particular service you want them to use, right? It's temporary access, it's not permanent. So there are more things to IAM. So but the advantages are you can create users and groups, and you can control the users by you can basically have access to them, and you can have basically you can provide them different level of access according to the user. For example, a developer would need different types of AWS services. Data scientist would need different types of AWS services. Let's say a finance account manager would need different types of AWS services. So according to that, you can provide them particular access. So that's basically what are the advantages of AWS IAM. You would be able to basically administer over users and the permissions they have. Coming to the next question, what do you understand by a security group? So to be very simple, security group is basically like a virtual firewall. So when you create an AWS instance, you may or may not want that instance to be accessible from the public network. Moreover, you may want that instance to be accessible from some networks and not from others. For example, you are creating an instance and only you want to access it. So you know the IP address of your PC, right? So in that case, you can create in the security group, you can pass on your IP address and only you would be able to log in into that EC2 instance, even though somebody else has a private key. Let's say you have given the private key to someone else, they wouldn't be able to log in because they wouldn't have the IP address. Now, coming to second point, security groups are type of rule-based virtual firewall using which you can control access to your instances. So you can create rules defining the port numbers, networks, or protocols from which you want to allow access or deny access. Okay, so it's basically simple. You can provide the port numbers, you can provide the IP addresses, the protocols, all the things you can provide. So this will basically, and also you can allow them or deny them. So let's say if you want a particular range of IP address to be denied, whenever a request comes from that IP address, they wouldn't be allowed to access the instance because the security group will stop them. So it's basically very, very simple. You can control who can access and who can't access the instance, and where the request goes, where the request comes, everything can be accessed using a security group. Okay. Now, what are spot instances and on-demand instances? So I think we already looked into this, but I'll just explain what a spot instance is even better. The on-demand I've already explained in a previous question. You can go check that. So spot instances, while you create EC2 instances, there are some blocks of computing capacity and processing power left unused. So let's say you launch a really huge instance, but only utilize one certain part. So now these blocks are known as spot instances. So these spot instances run wherever capacity is available. So these are a good option if you are flexible about your where your applications run. If you don't want your application to be running in a physical hardware which is dedicated to you, in that case you can go for spot instances which are much cheaper in nature, right? So yeah, so if you're flexible with that, you can go with spot instances. So that's basically it. On-demand instances are I've already explained, and you can look into them. You can just go back in the session and you can look into them. Right. Next is explain connection draining. So connection draining is a feature by AWS which enables your servers which are either going to be updated or removed to serve current requests. So that basically means, let's say your server, right? It is going to be updated to a newer version, but connections are still coming in, so it will still allow the server to basically serve those requests. So if connection draining is enabled, the load balancer will allow an ongoing instance to complete the current requests for a specific period of time. For example, you can set that up. It will allow, let's say, the incoming request, it will serve for 10 minutes and then but will not send any new request to it. So if already 100 requests have been made, right? So it will allow those 100 requests to be served, but after that, it wouldn't let any new requests to come in, but that 100 requests will be served. Once it is served, then it will be stopped. So now without connection draining, an outgoing instance will immediately go off and the requests pending on that instance will error out. So that would be a major problem for users, right? So because if you're trying to retrieve some data and the application was working at that point of time, so once you click on retrieve data and it doesn't give you the data, you would be kind of pissed off. So, but in this case, using connection draining, that wouldn't happen. If the system is going to be updated, you would get back the data and then it will go to an off state where it's in maintenance. So otherwise, you would get the request back. So this is basically connection draining, and this feature is available in load balancer. Next, what is a stateful and a stateless firewall? A stateful firewall is basically the one that maintains the state of the rules defined. It requires you to define only inbound rules. Based on the inbound rules, it automatically allows the outbound traffic to flow. So you only have to mention the inbound rules. Basically means you only have to decide on the incoming traffic. So it'll automatically choose, or it'll automatically filter the outgoing traffic, but the only thing you'll have to provide is the incoming traffic rules. So who can access the server from where you don't want, so who can't access the server, all of these things you will have to do, but the outgoing from the server will be taken care of the system itself. So that's basically stateful. In stateless, you explicitly define rules. That is, you can basically decide what are the IP addresses, what are the things which comes in, and what are the things which goes out. Everything could be handled by you, but you will have to do it by yourself. You have to explicitly define those rules. For example, if you allow inbound traffic for port number 80, stateful firewall will allow outbound traffic to port 80, but stateless firewall will not do it, because in stateless firewall, if you provide inbound traffic for port number 80 and leave it, it will only allow inbound traffic for port number 80. But if in stateless firewall, you will have to go ahead and explicitly mention that also I need output traffic for port number 80, right? Once you do that, then it will allow. But in stateful, you basically means if you mention something, if somebody can enter the instance, right? Somebody can inbound, they can also go out. So that's basically what stateful does. Stateless doesn't do it. In stateless, you have to give every single detail manually. Coming to the 28th question, what is a power user? Access in AWS. So it's pretty simple. It's like a sudo user in Linux. So a power user will be given administrator access. So using IAM, you are creating a user. Once you create a user, you can give them administrator access. So once you give them administrator access, they can do everything the root user does. Only thing they can't do is like they can't delete the AWS account. They can't check out the billing dashboard. So those are the things they can't check out, but they can do everything else apart from those. So without the capability to manage the users and permissions. In other words, a user with power user access can create, delete, modify, or see the resources, but he cannot grant permissions to other users. So he'll not be able to create other users and grant permissions to other users, but he'll have all the access to use any service in AWS he wants or she wants, right? Okay, next question is, what is an instance store volume and an EBS volume? So it's basically two different things. So instance store volume is a temporary storage. Only temporary data is stored, because let's say the instance is restarted, that data will be gone. That is the instance store. It's like RAM. But EBS volume is like your SSD or your HDD. So once the data is stored, it is stored there because it's a storage disk. And once it is stored, even though the instance gets turned off, it will be available. That's the only difference. Instance store is like RAM. When the instance is running, when temporary data is available, it will be stored in the instance store. Once your instance is restarted or it's shut down, that data will be gone. But whatever data is stored in the EBS volume will still be there. 30th question. What are recovery time objective and recovery point objective in AWS? So recovery time objective, it is the maximum acceptable delay between the interruption of service and restoration of service. This translates to an acceptable time window when the service can be unavailable. For example, recovery time objective, let's say AWS tells you that 5 minutes per day. So you can expect that the service will not be available for 5 minutes in a day, but it is not acceptable if it goes beyond that 5 minutes. So if it goes beyond that 5 minutes, you will be able to get a refund or whatever from AWS, but that's the limit given to you. So but it's 5 minutes per day, it's also a lot of time. So that's not the case, it's totally different, but I'm just giving you an example. Next is recovery point objective. So in this case, it is the maximum acceptable amount of time since the last data restore point. It translates to the acceptable amount of data loss which lies between the lost recovery point and the interruption of service. Let's say data is being uploaded and the service has been interrupted. So there would be obviously some data loss, right? So how much data can be lost? How much data loss is acceptable? That's basically a recovery point objective. So these two things has to be given to you when you are trying to create a mission critical application on AWS, because mission critical data can be lost, mission critical applications might be interrupted of service. So these are the things which we'll have to discuss with the AWS team, AWS sales team, the tech team, everything before you basically transition all your stuff into AWS, right? 31st question. Is there a way to upload a file that is greater than 100 megabytes in S3? So in S3, at one go, you can't upload files more than 100 megabytes, but there's an option to do this, which is multi-part upload utility. So it will split the large file into multiple parts. Let's say you're uploading a file of 1 gigabyte, which is 1024 megabytes, right? It will split it into 10 parts and it will upload it or it will split it into 11 parts and upload it. And then once it's uploaded, it will be clubbed together. So you can also upload decrease upload time by uploading these parts in parallel. Uh, so in this case, larger files can be uploaded in multiple parts that are uploaded independently. So if you want to reduce the time, you can upload those 11 files at the same time, and then you can club them together. After the upload is done, the parts are merged into a single object or file to create the original file from which the parts were created. So you can use multi-part upload to upload a really huge file. Coming to the 32nd question. Can we change the private IP address of the EC2 instance while it is running or in a stop state? So first of all, once you created an EC2 instance and once the private IP address is assigned, you will not be able to change the private IP address. When an EC2 instance is launched, a private IP address is assigned to it. So once it is assigned, you will not be able to change it because it is attached to the instance for its entire lifetime. So once it's terminated, you can create another instance and that instance can have the same private IP because this instance is dead, it's not available, and the private IP address is free now, so it can be assigned to another uh, a server, but that server cannot have a different private IP address. It can have the same, it will only have the same IP address. 33rd question. So what is the use of lifecycle hooks in auto scaling? So lifecycle hooks are used for auto scaling to put an additional wait time to scale in or scale out event. To make it even simpler, let me just explain using this particular thing. So this is a lifecycle hook and this is a lifecycle hook, right? First of all, scale out. Scale out basically means decreasing the number of instances. Let's say you have 5 instances. Now you don't need 5 instances, you want only 3 instances. So now you are reducing 2 instances, right? Now scale out pending. So lifecycle hook basically pending wait, pending proceed. So it is basically the instances are launching. So sorry, scale out basically means increasing the number of instances. Sorry, my mistake. So once then the instance, once it is launched, it would be in service, and then scale out comes in. So in this case, there is another lifecycle hook which is for terminating. First, once the terminating is started, it will wait and then it will check how many instances has to be terminated. So once that is decided, it will terminate the instances and then termination will be done. So in an auto scaling instance, so this is what happens. So it basically gives you an additional wait time to scale in or scale out. That's exactly what lifecycle hooks does, and that's exactly what it helps. And the final question, which you're going to look into, is what are the policies that you can set for your users' passwords? Okay, so you're, let's say, using IAM, you're creating a user's passwords. So what are the different kinds of settings you can do to that user's password so that they create a secure password? First of all, you can provide a minimum length. If you want the minimum length of the password to be 10 characters, you can do that. Second, you can ask the users to add at least one number or special character. Third, you can provide a requirement like a particular character type like @ or hashtag or forward slash or backward slash. So you can provide that you need at least these, or you need uppercase letters, lowercase letters, numbers, and non-alphanumeric characters. So you can ask these requirements. Fourth, you can enforce automatic password expiration. That is, you can set up a password expiration period. After every month, they'll have to change a new password. That's basically the fourth one. And the final one is you can have the AWS users contact an account administrator when the user has allowed the password to expire. So basically, you don't have to manually change the password. You can allow them. So you can basically give the access to the account administrator when the user has allowed the password to expire, right? So if the user allowed the password to expire, then they will be able to contact the account administrator and get their password back if they are not able to create a new password. So these are the different types of things. These are different policies which AWS administrator can set to the IAM users, right? So these are basically the questions, guys. So now coming to the final part, I'm going to ask you a question. So if you know the answer, put down in the question section and we would give you a heart from our side to recognize that yes, that's the right answer. So the question basically is, which of the following is an edge storage or content delivery network? So which of the following is an edge storage or content delivery system that caches data in different physical locations? Four options: relational database service, DynamoDB, CloudFront, associate web services. So I'll repeat it again. Which of the following is an edge storage or content delivery or CDN that caches data in different physical locations. So is it RDS or DynamoDB, CloudFront, or Associate Web Services? If you know the answer, put it in the comment section. So that's basically the session, guys. I hope it was helpful. So meet you in another one. And if you like the session, please leave a like. Thank you. Hey guys, welcome to yet another session by Scalar, and in this particular session we're going to look into AWS IAM, which is also known as AWS Identity and Access Management. So before we move on with this particular session, please make sure to subscribe to our channel so that you don't miss our upcoming videos, and also leave a like if you enjoy our content. If you have any other queries, leave a comment down below and we would be addressing all of your questions. So now, before moving on with the session, let's understand what will be covered in this particular session. To start off with, we'll be understanding what is IAM. Okay, first we'll understand the very basic, which is what is IAM, and then we'll move on to what is AWS IAM. What exactly is IAM in AWS, and why should we use IAM as an AWS administrator or a solutions architect or a developer, whoever is using AWS? Why should we use IAM? Once that is done, we'll be covering all the basic concepts in IAM. We'll be looking into roles, we'll be looking into users. So we'll have a quick intro about that before going into the session after the agenda. And once all of that is done, we'll be looking into demos where we'll be doing all of these theoretical concepts in practice. So this is the intro for this particular session. So now let's start with it. So guys, first let's understand what exactly is IAM. So IAM means Identity and Access Management. So first of all, what is identity? So identity is basically logging into something using your identity, using your credentials. So first of all, if you're using AWS, you need an identity. Okay, so that's basically the identity part. Next comes the access management part. So let's say identity, that basically is you're creating a user. Okay, now you have the credentials to log in and everything. So the second thing is basically access management. So identity, access management. So second comes access management. What exactly does that mean? It's basically providing access to that particular user who you just created. So let's say I'm creating a user number one. So that particular user just needs access to one particular service, let's say AWS EC2. So using access management, you can create a policy which basically enables the user one to just access that particular service. So you as an administrator, let's say I'm the administrator, I will create a policy and I will attach it to the user one's permissions. Okay, so now that user one will have the permission to log in into AWS and work with Amazon EC2. Okay, so that is the only service you'll be able to do. So now let's say I'm creating user two, and now the user two is a, let's say he's a finance accountant. He just needs AWS details just for the sake of reimbursing the amount. Okay, so that's the only thing he would need. Okay, so now for that particular purpose, let's consider user two. I'm creating another policy and just giving the billing permissions and attaching it to the user two again. So now there are two different users, even though there are two different users and they are able to log in into the same AWS account, but the things they can access are completely different. And that's exactly where access management comes into play. Okay, so I hope this is very clear. So this is basically identity and access management. So now in this case, in AWS, they have their own IAM service, which is available where you can create users, you can create groups and add the users to the groups. Then you can create policies, which are basically permissions. Then you can create roles. The roles are basically creating temporary users. You can create a role and attach it to someone, and they can use the role to access those services. And then it'll be just for a particular period of time. You can delete it, and that would be gone. Okay, so these are the very basic and essential things you can do with IAM. There are still more things which you can do. There are security credentials which you can generate. So you can authenticate into a database using IAM. So there are still more things to cover in IAM, but apart from that, these are the essential things. So now I hope this is understood. Now with this, let's begin with the session. So guys, I've already explained you what exactly is identity, access management, how identity and access management works, how exactly you can create users. So all the basic stuff I've already explained. So let me just tell you what exactly is AWS Identity Access Management. So now you can clearly see the first liner itself, apply fine-grained permissions to AWS services and resources. So basically you can create certain policies and roles which will provide you access and provide you control over your users in the AWS account. So basically what you can do is you can create these permissions, attach it to a user, and you will be able to control what permissions that particular user has, right? So you get fine-grained access to that. That's what exactly they mean. So now AWS Identity and Access Management provides fine-grained access control across all of AWS. With IAM, you can specify who can access which services and resources under which conditions. So that basically means, let's say you have user one. Okay, so now the user one only needs EC2 and S3. So only these two services he wants access to. So now to user one, you can provide these two services and under which conditions. So even that you can specify. That is, if you can provide a role, that is, for example, if that user only is in a particular group, only then they can access. So you can attach the permission to the group, and only if the user is added to the group, then he can access those services, otherwise they cannot. So all of that can be done. And with IAM policies, you manage permissions to your workforce and system to ensure least privilege permissions. That basically means you don't have to provide the entire AWS account, right? So if you provide access to the entire AWS account, anybody could log in, anybody could like create and delete resources, which won't be cost effective. Second, it won't be easy to manage all the resources. Third, you wouldn't know who exactly is creating what when everybody can do every single thing, because you won't be able to get fine-grained access and permissions, like control over each and every user. But IAM is a free service, and you can do exactly what I told for free with no additional cost, because it's a service which helps you to manage the AWS ecosystem and AWS users who are using in your account. Okay, so that's basically what identity and access management is. Now let's look at the use cases. First of all, apply fine-grained access control. So grant access to specific AWS service APIs and resources by using IAM policies. So this is what I actually meant. You can also define specific conditions in which access is granted, such as granting access to identities from a specific AWS organization or access to a specific AWS service. So all of this can be done using IAM policies. Next comes, there is something called AWS organizations, which is not a tool which you need if you are an individual AWS user. So this is only for people who are working in organizations as an AWS administrator or a cloud administrator who is trying to manage all the users within the organization, that is internal members, external members, and everybody. So you get something called service control policies. So using service control policies, you can control all of the IAM users and roles across the AWS account. So this is established permissions, guardrails, and data perimeters across your AWS organization. So who can access and what they can access. So those are the things you can handle. Achieve least privilege permissions with IAM Access Analyzer. So this basically is a tool which is already inbuilt. So you can run the IAM Access Analyzer, which will basically check if certain permissions are a little too high, or if somebody has a certain permission which has never been used, something like that. It will view all of that, and it will give you a refined set of what can be done. You can verify certain users permissions and reassign them, set certain permissions or remove certain permissions. All of that will be provided. Automatically scale fine-grained access using ABAC. So attribute based access control is an authorization strategy for creating fine-grained permissions based on user attributes, such as department, job role, and team name. So for example, let's say you have 100 users, and there are three different groups. Okay, so there is development group, and there is let's say finance group, and there is one more group, let's call them data science group. Okay, so there are three groups. So there are 50 members in the development group, 25 in each of the other two groups, finance and data science group. So now all of these users need different kinds of services, right? So even in the development team, there could be multiple subgroups. So one of the developer would need access to EC2, S3, RDS, and stuff like that. Another user would need access to Redshift, Glue, and other tools related to data engineering. So it totally varies. So now you can do that with ABAC. So a particular attribute will contribute in order to make sure that the right permissions are given to the right person. So if you're from the development group, only then a particular resource will be provided to you. Okay, so if you're not in that group, you wouldn't be provided. So that particular attribute will be looked into, only then that particular permission will be given to you. Okay, done. So how exactly IAM works? So this is the second thing which I told you I'll talk to you about. So with IAM, you can define who can access, What? By specifying fine-grained permissions. IAM then enforces those permissions for every single request. So access is denied by default and access is only granted when permissions specify and allow. So the permissions you create, right? You can also deny certain resources. So you can allow certain resources, you can deny resources, you can deny specific permissions within a particular resource. For example, EC2, you can allow someone to create an EC2 instance, but you can deny them the permissions to delete or stop those instances. So you can do that. Okay, so you can do that with IAM policies. So now basically first thing you will do is choose who or create a user or use an existing user from IAM. Okay, second, what they can access and what they cannot access. So that you will do by providing permissions in IAM policies. And finally, what they can access using this. So they can access, let's say they can access EC2, they can access S3, but they cannot access RDS. Okay, these are the things we've provided. But what the resources, let's say S3, so this is again a key management system, then there is, let's say EC2. So now within those resources as well, what they can do. So if they can just view what resources are available, or can they create and delete, or can they access a certain feature within that resource. So all of that can be provided. Okay, so this is how basically it works. You choose an IAM user, you create a policy which will allow them to do like access certain resources in the AWS organization, and then you basically attach it to the user, which will then be in effect. So every time the user tries to open a resource, AWS will check their access policy. So basically it will check their policy. Okay, so once it checks their policy, then in that case, if there is an allow, only then they will be allowed to use that resource. If it's a deny, or if that service doesn't even exist in their policy, they wouldn't be allowed to access it. So this is basically how it works. So I hope this is clear. Okay, so now let's understand certain features of IAM right now. So fine-grained access control, we already know about that. Delegate access using IAM roles. Okay, so now with IAM roles, you delegate access to users or AWS services to operate within your AWS account. So users from your identity provider or AWS services can assume a role to obtain temporary security credentials. So again, roles are not permanent. So a user is a permanent entity who you can attach a IAM policy to, but an IAM role, you don't have to attach it to a particular user, but again, it is a temporary credential. It will only give you a temporary credential that will request AWS to let you use a particular service for a particular time according to the role you created. Okay, so you can see IAM roles provide a way to rely on short-term credentials for users, workloads, and AWS services that need to perform actions in your AWS accounts. For example, let's say somebody just wants to pay the bill and you just want to allow them billing access. So in that case, you can just allow them billing access by providing the billing permission. So you can create a role in order for that particular person who can use that role to get temporary credentials and then log in into AWS and access the billing dashboard. Okay, and then IAM analyzer, we already saw about that. Permission guardrails, we saw about that. Attribute based access control, we saw about that. So we all saw all about these features. So these are basically the features, guys. I hope everything is clear in this section. Okay, so now getting started will basically be the docs. So we already know how exactly it works. We already know what it is. So if you want more IAM demos, you can just check out AWS like keynotes. But the thing is, these are pretty long and they would be more theoretical than practical, but you will get a really good understanding of what exactly it is. So go through these notes. Okay, so you can see 10 effective ways to secure your AWS environment. It's a 30-minute clip, but it's a really effective video. So you can watch all of these videos according to your need. Okay, so this is just to understand it even better, how exactly it works. So how exactly fine-grained access control works, how exactly it helps you reduce the risk in your AWS account, how exactly the IAM access analyzer works, how exactly a policy works. So all of that you can learn here. So what we're going to look into is we're going to understand certain basic concepts right now. And once we understand the basic concepts, then I'll be showing you how to create a user, how to create a group, how to create a policy, and how to create a role. Okay, so these are the things I'll be showing you. So now let's start with the basics. So we already know what is IAM. We already know IAM features. accessing IAM. So there are mainly three ways. One is the management console, which I already have open here. Second is the CLI, command line interface. You can install command line interface if you have a Mac system or a Linux system or a Windows system. You can so you can see here for Windows PowerShell, and you can install it to other Linux environments. So Mac basically is, even though it's a Mac, it's still built upon a Linux operating system, uses Unix. So in that case, you can still install CLI over here in the terminal. And then there are SDKs, basically software development kits. So you have software development kits for these many languages in AWS, which you can install, and then you can incorporate the IAM services and resources into your code. So these are the things which you can do. But here we are going to use the AWS Management Console, and I've already logged in here. So I've logged into my root user. I'm not logged into my IAM user. I'll be showing you how to create your first IAM user and group. Okay, done. Okay, so now how IAM works, we already know this. Okay, so now but that was a simpler explanation. This is a much So this is a much better example to look into. So this is the AWS account, complete account. For example, let's see, this is my account, right? So you have your account ID. Okay, so this is my account. So this is the account ID. So every account will have a 12-digit account ID. Okay, so now inside the account, you have all the resources and everything. Done. Okay, first there is something called a principal. So principal is basically the users, the roles, the federated users, the application, whatever requires authentication. So any resource or service or user who requires authentication, they are basically the principal. And then there is a request. So under request, there are so many things. So what kind of an action they want to perform, what resource they want that action to perform, and what kind of a request they need. Is it a temporary one like using an IAM role, or are they using an IAM permission by logging in, or they are logging in from a third-party user, third-party tool, something like that. Okay, so now then comes authorization. Okay, so once, let's say, a user wants to use EC2. Okay, so they are requesting, so that request is sent to IAM. So IAM will have all the identity-based policies. Okay, so these are IAM policies. Other policies which are available, resource-based policies. So yeah, so all of the policies will be available. Okay, so now basically this particular user will have a policy which is attached to that particular person, right? So the request will go and check that particular policy. So let's say it's this policy, and they are checking this particular policy, and if it allows that particular user to do the action which they are trying to do, in that case it will allow them to go to the action. So once it is saying that it's allowed that particular action, they'll be taken to the resource. For example, they wanted to use EC2, right? So they'll be taken to EC2 and they will be able to work with it. So now the permissions are only for EC2, IAM and S3. So now let's say they are requesting to use RDS, relational database service. So now that won't be available in the policy, and in that case they will not be available, so they will not be going to the next step, which is actions. Okay, so they would not be going over there because, again, as I told you, they don't have that resource over here and they do not have the permissions to do that. Okay, so now once they come to action, so let's say they are trying to use EC2, and inside EC2 there are so many different things you can do. You can create an instance, you can stop an instance, you can terminate an instance, you can attach a network interface to the instance, you can attach an IAM policy to the instance, you can see what exactly is that instance is about, you can attach a security group, you can do so many things with the instance, right? So in that particular thing, what action are you trying to perform? Let's say you want to run instances, so basically you want to create an instance. Okay, so now once you do that, then the resource will be created and you will be able to see the resource if you have the permissions. Okay, so this is basically how it works. And then over here, resource-based policies. So this is like a role, so where the user is allowed to request something even though they are basically not an AWS user and they are a temporary user. They'll be using their temporary credentials to access it. And one more thing, this is a completely different AWS account, and if you have provided permissions to that particular account to do certain things in your AWS account, they will be provided access. So this particular account is a different AWS account and this is also a different AWS account, but this AWS account has permissions provided by resource-based policies, but this account does not have permissions, so they will not be able to perform any actions within this AWS account, but this particular account can do that. So this is a overall summary of how IAM works, provides you access and denies access. Yeah, so these are the things. So a principal is a person or application that can make a request for an action or operation on an AWS resource. So that's basically what I was saying. Okay, so now let's just look at the terms and then move ahead. IAM resources. So any user, group, role, policy, anything related to IAM is an IAM resource. IAM identities are used to identify and group. You can attach a policy to an IAM identity. It could be users, groups, or roles. So policy doesn't come under this because we're attaching a policy to these identities. Okay, so then IAM entities. So users and roles are entities because they are individual entities. Groups are just to group multiple users together, but you cannot give a group a particular authentic. So you cannot let the group handle it because it's not a single entity. It's a group of multiple entities. And finally, principal or single thing. So it could be the root user, it could be the IAM user, or it could be the IAM role. Okay. So principal requests. So we've looked into this authorization, actions or operations. Yeah. So we've looked all into this. Users in AWS. Okay, so now let's understand this first time access only. So use your root credentials. So the thing is, even though you have your root credentials, it's always better to create an IAM user and then perform all your actions using the IAM user rather than using the root user, right? But even though I use my root user because, so why exactly is this required? Is because if you're going to share your root user credentials to someone else, that would be a major problem because it's your root credentials. They could manipulate it. They could change the root credentials. They could do so many things with it, right? So it's always a bad idea to provide root credentials. Always a good idea to create an IAM user right from the start once you log in. But I am just using for a personal AWS account, so I do not need that. Again, for practice, you do not need it. But if you're using it in an organization, better create an IAM user. So IAM users, identity aspect of AWS. Okay, so who is that user? Often referred to as authentication. So account, so this is the main account. Under the account, you can have multiple users. So Lee, Mathayo, DevOps1, DevOps2, TestApp1, TestApp2. So these are applications and these are users. So all of them have IAM access. See, users, all of them have IAM access under a single AWS account, and each of these users will have their own credentials to log in, right? Federating existing users. So if you are running an organization and if you already have a directory full of users, let's say you have an active directory, let's say you have Azure Active Directory, or you are using already an external directory where you have all the information of your users. So now you can federate those users into AWS using IAM. Okay, you can federate them into IAM, so they don't have to exactly log in into AWS every single time. They can just log in from outside the organization, even though they do not have access to AWS account. So by federating it into IAM, you would be able to do that. Okay. So the following diagram shows how a user can use IAM to get temporary AWS security credentials to access resources in your AWS account, even though they don't have permanent passwords and usernames. So your users already have identities. So using SAML 2.0, if it is compatible with it, in that case, you could create a single sign-on. So you don't have to sign on to the AWS account. You just have to sign on to your external authentication provider, so external directory, and through that you can log in and use your AWS account. Okay. And then permissions and policies, this we'll look into right now. We'll just understand what they are and then I'll explain you while we are creating them. So policies and account, if you manage a single account in AWS, then you define policies and permissions within that particular account using policies. If you manage permissions across multiple accounts, it is more difficult to manage permissions on your users. So in that case, you will have to use IAM roles, resource-based policies, and access control lists. So this is for multiple AWS accounts. Only then it will become complex. If it is in a single account, you just need regular policies. You don't need anything else. So this is how a policy will look. So the version will be provided. You don't have to enter this when you're creating a policy. The version will already be provided. The latest version will be taken. Statement. So effect. Do you want to allow or deny? Action. What is the action? So DynamoDB :* basically means all the actions which you can perform on DynamoDB should be allowed for this user. The resource. So this is the resource ID. So there is something called ARN, right? Amazon resource number. So it will specify which particular resource you're going to use. So this is that particular resource, and that is what is provided over here. And this particular, okay, so this particular policy will allow the user which is attached to. So you are creating this policy and attached to a user. That particular user will be able to access DynamoDB and do all of the actions which they want to do under this particular resource. So there will be a table called books. Okay, so in that particular resource they can do any action they want. Okay, so that's what this policy is about. So now policy and groups. So you can organize IAM users with IAM groups. So I'll also be showing you how to create IAM groups. So now this is the account, and there are three different groups. Under three different groups, there are multiple users. There's Bob, Susan, Nate, Brad, DevApp1, Kathy Allen, TestApp1. So one more thing, there could be the same user could be in multiple groups as well. So I just wanted to tell it before. Okay. So now IAM groups are basically logical entities where you can combine multiple users. So let's say there are 100 users who want the same permission. So it will be a tedious task to attach the permission to every single person, right? So instead you can create a group, add all of them to the group, and attach that particular permission to the group. And once you attach that permission to the group, that permission will be basically assigned to all of the users who are within the group. I hope that's understandable. Yeah, so that's basically it, which I wanted to cover. So ABAC, so attribute based control list. Okay, so this is what I was talking about. Let me just give you this example. For example, you can create 3 roles with the access project tag key. Set the tag value of the first role to heart, second to sun, third to lightning. You can then use a single policy that allows access when the role and resource are tagged within the same value for access project. So what they are meaning is you don't have to create separate. So usually you would create a separate policy and attach it to the user, attach it to the application, attach it to the user, right? So instead of doing that, you can have a single attribute based access control. You can have a single attribute based policy over here. That policy will have multiple role names, tag names, so heart, sun, lightning. So it will look into the tag names and only then allow that particular tag to work. For example, if this user is trying to access, so even though they are going through the single list, they'll only be allowed to access these two which are tagged heart. Okay, so same thing, this application will be only be allowed to use the sun, and this user will be only allowed to use what is this, and also they are able to access sun as well. If they could, they can also access the other resources with that particular tags. So this is attribute based access control. Okay, so you can understand it even better. So this is basically how it usually happens, right? But this is what we are trying to do. Okay, so that's basically it. Getting started, you can, if you want to start, you can start off with this. Anyway, I'm going to show you this, how to create an IAM admin and user, uh, delegated user. So I'll be showing you how to create an IAM admin user. I'll be showing you how to create 2 more regular users, and I'll be showing you how to create an IAM policy. I'll be showing you how to attach it to the policy. I'll be showing you how to create an IAM group and how to add users to the group. And I'll also be showing you how to create IAM roles. So let's start with it. So again, if you wanna do it by yourself, just check out the tutorials over here and check out getting started. You can just open the documentation and start using it. So for now, if you want to follow this particular session, you will understand everything. So if you just click here, there is something called security credentials. You can click on this and go to IAM, or just type in IAM and open it. Okay, so off the bat, you can see add MFA for root user, deactivate or delete access keys. So I have some access keys, I guess. Let me just delete them. Okay, so let's not worry about access keys in this session. If you want to know more about it, I'll make another session where we discuss that. I just wanted to delete it because it showed. So now let me refresh it. So now you can see there are no active access keys. Next, MFA. So multi-factor authentication. So you can add multi-factor authentication by using a multi-factor authentication tool. So there are tools like Google Authenticator. So there are tools like Google Authenticator, and there is Microsoft Authenticator. So what, you can download any app, you can download the app in your phone itself. Okay, so you can download the app in your phone, and you can add MFA to your AWS account. That basically is, even though you provide your password, even then you will get a 6-digit code in the MFA app. You will have to enter that code before the timer runs out. Then you will be able to log in. If not, a new 6-digit code will appear, and then you will have to put that particular code again, and that will let you log in. Okay, and also you can see I have 80 different roles, and I also have 89 policies. So again, off the bat, let me just tell you. So there would be already existing roles, that is default roles, which is provided by AWS, and default policies provided by AWS. If I open here, so type customer managed, AWS managed. So AWS managed roles are basically roles which are provided by AWS. Okay, see, there are 1008 policies. But if you go to the dashboard, how many is showing? 89, because there are 89 policies which I have created, and there are 80 roles which I have created. Everything else is AWS managed. So over here you can see all of this was created by me. So some of them were created when I was creating a service. For example, when I'm creating code pipeline, this role got created. But these are available. These are provided already. You can also see last used date over here, last activity, 6 hours ago, 48 days ago, right? Okay, so then you can create roles, let it be. Okay, so the first thing I want you to do is create a user, right? First, let's create an IAM admin user. Add users. Okay, I'm going to provide my own name. I'm going to provide both access key and password. I can create a custom password if I want. So if you need to require password reset once you log in, so that is, you can provide a simple password over here and provide password reset. They can reset their password once they log in into your IAM account. So next, permissions. Right now I don't want to attach any permissions. Let me just leave it. Tags not required. Review and create. Okay, now let me open incognito. Okay, so let me open console. So now login, usually you will log in using root user. As an IAM user, you will have to log in using IAM user. So first thing you will have to do is provide. So you can actually copy this and you can paste it. It will automatically input the 12-digit code like this. If not, you can just ask them for the 12-digit code, they'll provide it to you. Or when you download this credentials, right, when you download the credentials, the 12-digit code will be already provided. Okay, so you can provide that, an IAM username and your password, and sign in. So now we provided, right, require password reset. So that's why it is asking me to change my password. So I'm going to change the password into something easier. Just sorry, this should be my old password. Yep, I've provided the password, I've reset. So now you can see this thing, Cody at. So usually in the root account, you can see only the account ID is provided. But in the IAM user account, it's the IAM user and the root accounts ID. Okay, so this I have logged in, but this particular user doesn't have access to any resource. For example, let's say if I open EC2, I don't even have access to view the data because no permissions has been provided to this user. Okay, that's why you are seeing API error. If I click on this, even then nothing will be shown. Let me click on launch instances. See, an error occurred describing your selected AMI because I don't have permissions to do anything. So now let us make this an admin. Let us make this user an admin. So to do that, you can open here and then you can click on permissions and add permissions and add user to group. No. Copy existing permissions from existing user. No. Attach existing policies directly. So by default, so this is an AWS policy. You can see AWS manage job function. So I'm providing this user administrator access. So when I provide administrator access, they will have every access. Okay, they can use every service they want except the billing dashboard. That is, they won't see how much bill has been generated and all. They wouldn't be able to see that, but they would be able to see every single thing except that. So now if I let me refresh this, let me go to EC2 dashboard. So now you can see they're able to see, this particular user is able to see the details, and let us check if the user is able to create an EC2 instance. So select yes, they are allowed to move to the next step. So that basically means they are allowed to use these AWS resources. Why? Because we attached a administrator access permission. Okay, so now let's just use this user to create further users. Okay, so now let me open IAM once again. Okay, so now let me quickly create two different IAM users. User 1, add another user, user 2. Okay, I want to just provide them password access. I want to provide custom password and I want them to reset it. Permissions. No, I don't want to provide any permissions right now. Let's provide it once we create the users. Okay, users are created. Okay, it's the same thing. You can log in into them the same way you logged into this user. So right now they are not in any groups. They don't have any permissions attached. So now I just want to attach one single permission which will allow this particular user to access EC2. So let's create a policy for that. Let's create a policy for user 1. Policies, create policy. So there are two ways to create. One, you can use a visual editor, or if you know how to create using JSON, you can use JSON. So if you know how to work around with JSON, that's much easier. If not, go with the visual editor. First, select the service you want to give the permission to. I want to give permission to EC2. So I'm selecting EC2. So now what are the actions you want to give permission to? Do you want them to be able to do everything with EC2, that is create it, delete it, start it, stop it, attach permissions to it, use tagging, write things to it? So if you want them to do everything with it, just click on all actions. Or if you just want them to view, that is only read the data, only describe the data, then just click on list. So if not, if you want to do particular actions, you can basically expand it and check what you want them to do. Okay. For example, if I click on read, so do you want them to view describe tags? Do you want them to view tags? If you want them to view the launch template data, then there is list. Do you want them to describe host or regions? Do you want them to see the list of VPCs? And then there is write. Over here, you will be able to see where's our run instances. So if you want to know what exactly an action does, you can just click on it. It grants permissions to launch one or more instances. If you just want them to be able to launch instances, you can just provide this particular permission. Okay, so these are the things, different things which you can do using a policy. I'm going to provide all actions, and then coming to the next step, which is tags. I don't want. So request conditions, again, as I told you, right, you can provide certain conditions. So one condition you can provide is only if the user has multi-factor authentication enabled, they can do it. Second condition is source IP, that is only if they access from a specific IP address. For example, if you all are working from a company and all the systems are within the network, so they will be having a set of IP addresses. So if you know that IP address range, you can provide that range, and only if they are in the company and trying to access the AWS account, they'll be able to do it. If they're outside of the company, they won't be able to do it. So for that, you can provide the source IP. If not, there are other conditions. You can select a condition and you can select a qualifier and you can set up that condition. Okay, I'm not going to provide any condition. Next, tags. I don't want any tags. Okay, sorry. We have to do one thing in resource. We'll have to choose at least one resource. So because under this we provided all resources, right? So under this they're asking which resource. So over here you can select one resource or you can just click on all resources, which will allow you permissions to everything. So next, tags. So one more thing you can do, you can add additional permissions also. You can, if you just don't want them to access EC2, if you want also them to allow access to Elastic Beanstalk, you can add that permissions too. Next, tags. Review. I'm going to provide the name as user1 EC2 access, EC2 access, create policy. That's it. Policy is created. Done. So now go to the user, add permissions, attach existing policy, search for the policy, user1 EC2 access, and review it, add permissions, and done. So access is given to user1. So now user2 doesn't have any access, right? User2 doesn't have any permissions. The only permission he has is to change his password, but I'm not going to log into these users. You already know how to log in. You can do that by yourself. So what I'm going to do is I'm going to create a user group and add both of them to a group. I'm going to add these two users to the group. The group name is going to be practice group, create group. Group is created and there are two users in this group, but there are no permissions attached directly to the group. So now the users will have only their respective permissions. So you can see there are no permissions, and let's say user2 still doesn't have any other permission. So now what I'm going to do is I'm going to attach a permission to the group and not the user, and the permission will directly be applied to the users as well. So now attach policies. Let me search for EC2. Let me search for S3. I want to provide both the users S3 full access, but I don't want to provide them the permissions individually. So what I'm doing, I'm attaching it to the group. So now this particular permission is attached to the group, not the users. So now if I go to user2, sorry, user2 is already open, right? If I refresh this page, you can see attached from group there's a policy which is Amazon S3 full access. Now until and unless this user is not removed from the group, they will be having this access. They'll be able to access S3. Same way user 1 will also have the same access. So they have two directly attached permissions, and attached from group there is one more. Okay, so these are the different permissions, guys. Okay, so I hope this is pretty clear. I've shown you users, policies, and user groups. One last thing which I wanted to show is roles. Let me show you how to create a role. It's pretty simple. Create role, AWS service or AWS account. Okay, so if you want a particular service to access another service, you can click on AWS service, but I don't want to do that. If you want a person from an external federation, that is an external an external account who wants to use an AWS service, you would have to select this. If it's in web identity, so all the users federated by a specified external web identity, for example, like Facebook, Google, Cognito, or Amazon, if you want them to use from those credentials, provide web identity, but I don't want any of that. I want to use the same AWS account. So this account, next, I want to provide EC2 access. So I'm just searching for EC2, Amazon EC2 full access. Next, Role name is going to be EC2 full access role and create role. So role is created, right? Let's view the role. Okay, so role is created. So this is the link to switch roles in console. So if I just open this, so now I'll be able to switch roles of my account. So this is the IAM user. So I'll be able to switch the roles into that account. Okay, so this user can do, this particular user is an admin. He can do all actions. I just was using IAM. So now once I shift to this particular user using the role, they would be only be able to access the EC2 instances, EC2 roles. They will not be able to access the IAM or any other resources. You can change the color of whatever you want. Display name, I'm going to provide it as EC2 role switch role. Done. So now you can see I'm an EC2. So I'm basically in this particular role. So currently active as this particular role, you can use that particular link to log in into the role. So as I told you, it is temporary credentials. You don't have to log in using anything. You are already logged in, you're using the temporary credentials to access something. So now this particular user will be able to view and see everything about EC2, but they won't be able to see or do anything else with any other service. For example, let me open IAM. You can see they don't have permissions to do it because it's a role, but this particular user will be able to do it. So basically logged out because we switched the role into, so we switched the normal account into the role, right? So we are logged out. So that's the thing. Okay. So now anyway, this is fine. Now let's switch back. I'm switching back to my own account which we just created. Okay, so now there is one user group, there are 3 users, 81 rules and 90 policies. Okay, so that's basically is the session, guys. I hope everything is clear about users, roles, policies and groups. I will come up with more in the next session, but for now this is it. I hope everything is clear. Also guys, if you have any questions, leave it in the comment section. We would be answering them and helping you out. Okay, thank you.
Hey guys, welcome to Scalar's live session. So in this particular session, we're gonna start with AWS architecture. Let's wait for a couple minutes until few viewers have joined, and then I will basically share my screen and I'll explain you guys about the architecture which we'll be learning today. And once we understand how the architecture is going to be, and then I'll open the console and launch all the resources necessary, and we'll create that architecture. So if you already have an AWS account, then just you can open it side by side, and we can you can basically do what I'm doing, and you can get an idea of how to create an architecture by yourself, right? Hey Fatma, okay. So just give me 1 second, guys. All right. I'll share my screen in a couple seconds. Let me just check uh, the viewers. All right. Okay, guys. So now let's start with the session. I don't want to take further of your time, even though there are a few viewers who joined right now. I'm just going to start with it. Again, it's a Friday. The session will be available once I complete the live as well, so you don't have to worry about it. So now I want to share my screen. Okay. So the screen is shared. I hope you guys can see it. Uh, and also I'll change my view. Okay, yeah, so also which is better, this or this? I think this would be better because you guys can see more things. All right, so I'm just gonna go with this. Done. Okay, so I hope you guys can see this as well now. Okay, so this is the architecture which we'll be trying to create today. Okay, so first of all, there is a VPC. So the VPC is the first thing we'll be creating. The VPC is basically a logical network. It's called virtual private cloud, and it's a logical network which you can create. Okay, so this particular logical network can have various resources within it, because you cannot create a resource without a network. So if you launch an EC2 instance, it should be within a network. It cannot launch an EC2 instance without it being inside a network, because the EC2 instance will be given an IP address, a private IP address. So all of that requires the VPC, and it also requires the subnet. Okay. So yeah, so that's what we'll be doing today. So then there's a VPC, and within the VPC, we'll be creating two subnets, a private subnet and a public subnet. Okay, so a private subnet is basically, it won't have internet access. It will just have uh, access within the VPC, but a public subnet will have access to the internet. So how does it have access? We'll be using an internet gateway, which will allow access for the public subnet. Okay, so the public subnet, so the instances, EC2 instances within the public subnet can directly connect to the internet, and also can basically get back all the info from the internet. That basically means, okay, okay, I'll just try to explain it again because I don't think I showed it. Just give me 1 second. Yes, that was a mistake from my side. I was not showing the. Yep. Really sorry, guys. I'll just explain the architecture once again before we start creating the architecture, right? So first, we'll be having a VPC, which is a private cloud, virtual private cloud provided by AWS. So it's basically a logical unit. So in AWS, you can have any number of VPCs. So you can create VPCs, and there can be another customer, even they can have a VPC. So what is the purpose of it? It will isolate the resources within that VPC from other VPCs. So let's say there are four VPCs, and one particular VPC, let's say it has 2, 3 EC2 instances. So these EC2 instances will be isolated from the other virtual private clouds. So you can create connections and make them communicate with each other. This instance within VPC to another VPC, it doesn't matter. You can create connections, but the purpose of creating virtual private cloud is create a sub network within AWS. So then within the VPC, you can create something called subnets. So subnets are basically uh, sub networks. It is basically used to create a smaller network within the VPC with a bunch of IP addresses. So a range of IP addresses. So if there are two subnets here, so if I launch an instance within the subnet, so the instance will have an IP address within the range provided over here. Okay, same thing goes here. And then there are two types of subnets in AWS and in VPCs. So there's a public subnet and there is a private subnet. A public subnet is, again, from the name itself, it's public. The public subnet, the resources within the public subnet can communicate with anything. They can communicate with the internet, and also the internet, you can basically try to communicate with the resources within the public subnet from the internet. So it's a two-way communication. So how does it work? So they use something called an internet gateway. So using an internet gateway, you will be able to do that. And then coming to private subnets. Okay, so now private subnets, within the private subnet, they don't, the resources within the private subnet cannot directly access the internet. So there is one way they can access internet is by using the public subnet. So in the public subnet, you will have to launch something called the NAT gateway, network address translation. So what it does is it will translate the private IP address into a public IP address, which will then allow it to communicate with the internet. Okay, so that's how it works, network address translation. So that's called a NAT gateway. So using a NAT gateway, the private instances can connect with the internet, but again, within the VPC, a private instance could directly communicate with the instance in the other subnet. So within the VPC, all resources can communicate with each other without internet. But if a private subnet wants to download something from the internet, in that case, it would need a NAT gateway. Without a NAT gateway, we cannot. It would not work. Okay. So first, let me tell you what are the things which we'll be creating by order. So first, we'll be launching something called the VPC. We'll be creating the VPC. Once we create the VPC, then I'll be creating two subnets, the public subnet and the private subnet. Okay, these two will be created. So to accompany, to make it a public subnet, the first thing you'll have to do is a route table. There is something called a route table. A route table is what will allow the subnet to connect to the internet. So again, guys, there is a lot of concepts here. It's so, let's say if I'm saying something, I'll give you a brief about it, but if you want to learn more about it, just go to the documentation and check it. Again, there is also a complete tutorial on VPC in our Scaler channel. You can just go ahead and search for VPC tutorial, and I've explained all of the things over there. Okay, so you can learn over there. So now I'm not going to get into those things. I just want to keep it within the topic which we are covering for today. So now that internet gateway will be attached to the VPC. So if it is attached to it, then in that case, the public subnet will be able to connect to the internet. And once we've done that with the internet gateway, so that will become a public subnet. Next, we have a private subnet, right? So we want the private subnet also to have internet access. But if you use a NAT gateway, that basically means you will only have access to the internet. The internet cannot access the resources within the private subnet. So you can see, right, these are the private IP addresses. These are the public IP addresses. So if the private instance, if the private subnet can access the internet through the NAT gateway, but so there is only two-way access if you have an internet gateway. If it's a NAT gateway, in that case, it's just one-way access. The resources within the VPC can access the internet, not the other way around. So we'll be creating a NAT gateway. Okay, so these are the things we'll be creating. And once that is done, I'll be launching an EC2 instance within the public subnet and the private subnet to show you the difference between uh, obviously the public and the private subnet. So these are the things which we'll be doing, guys. So let me again, I just was explaining it. Now I'll just tell you what are the things we'll be launching so that you can note it down, or you can also try to do it. Create the VPC, create the public and private subnets. So they are basically creating two subnets. So once we created two subnets, we will be making one the public subnet by attaching the internet gateway. Okay, and then we'll be creating a private subnet. So let it be the private subnet. We won't be doing any change. And then we'll be launching two instances within the public and the private subnet. And I'll show you the difference between the public and the private subnet. Once that is done, I want to provide internet access to the private subnet. So to provide internet access to the private subnet, what I'll have to do, I'll have to create an NAT gateway and attach it to the public subnet. So the private resources can translate their private IP into a public IP to connect to the internet. So that's the last thing. I'll be creating a NAT gateway and providing access to the private resources. That will be the last part of this particular session. So this is the architecture we're going to create. So I hope you guys have been following me till now, and I hope it's understandable, right? Hey Priyanshu, hey Devijana, hey Karthik, welcome to this session. So I hope you guys will understand something from this session. So that's what I'm trying to do here. Okay, so now let's start with the actual architecture, right? I'll just keep this here anyway so that you guys could see it whenever I want to compare the architecture. So the first thing you'll have to do, go to VPC. You guys are doing good. Stay home. Okay, now I'm going to VPC. So you can see there is another VPC over here. There are actually two VPCs created. Okay, what I'm going to do is I'm just going to delete this VPC. Okay, so and one more thing, do not delete the default VPC. Okay, because if you delete it, then it's pretty hard to create. It's not that hard to create, but do not delete the default VPC. Okay, the default VPC, and the default VPC will have certain default subnets. Do not delete whatever is written as default. It is provided to you by AWS. Do not delete them. Okay, so now let's start with the first step. So I'm just noting it down here in my notes so that it will be better for me to track. So first thing I'm doing is going to create a VPC. Okay, so click on create VPC. So the first thing, provide it a tag. That's a name. So it's an option. It's optional, but still it's better to provide it. Okay, I'm going to name it as AWS Architecture Tutorial. Okay, and then you can choose from IPv4, CIDR, manual input, or IPAM allocated IPv4 CIDR block. So this will automatically provide a pool, but I'm not going to use that. Let's go with the traditional way of providing a CIDR block. So again, CIDR block, if you want to learn more about it, please learn it separately, because there is again an IP addresses video from in our channel, which is done by Lakshay, a research analyst in our institution. So basically you can just check it out. There he has explained how basically more about IP addresses and CIDR blocks, so you can understand it even better if you want to learn about IPs. So I'm not going to go further into it. Again, if you want to learn a little more about IP addresses, then just check out the VPC tutorial, which is already available in our channel. Yep. So here you can provide an IP address. So it could be, let's say it should be an IP address range, which will allow a lot of addresses. Okay. So if I provide 10.0.0.0/24, 24 is the number of bits. So in this IP address, there are totally 32 bits. So there are 10 bits over here, and then, sorry, there are 8 bits over here, 8 bits, 8 bits, and 8 bits. So every dot within that, there are 8 bits. Okay, so there are 32 bits in total. So now if I provide 24 here, what it basically means is the first 24 bits will be, what it will be, the first 24 bits cannot be changed. Okay, it will be constant. The last 8 bits can be changed. That's what this particular cider block means. If I provide it as 10.0.0.0/16, so this basically means the first 16 bits, right? The first 16 bits cannot be changed. They will remain the same. It will be always be 10.0, but the last two, that is the last 16 bits, can be changed. So I'm going to keep my IPv4 cider as 10.0.0.0/16. So this is going to be my IP address, sorry, my IP address range. Okay. So I'm not going to create a IPv6 cider block. I don't need one right now. Okay. So this is basically all the information you need to create a VPC. And once you provide it, click on create VPC, and the VPC is created, and that's basically it. It's pretty simple. So let me see if there are any questions, and I'll just answer them before moving on. Okay, so there's a question: what's the difference between a public and a private subnet? So that's what I was explaining before. I'll just tell it again, Priya. So basically, public subnet has internet access both ways. That is, the resources within the public subnet can contact or communicate with the internet, and the internet also can communicate back. That basically means I can communicate with the resource within the VPC using the internet, and the other way around. But it won't work the same way with private subnet, because private subnets are private from the name. There is no internet access. So that's basically private subnet. Do we really need subnets? Yes, we need subnets. We cannot just have one huge network and throw all the resources inside of it, because if you create subnets, it'll have a smaller IP address range, and according to the smaller IP address range, you can put in all the necessary resources within it. Because if you just have one, because again, as I told you, if you just want to give certain resources internet access, then you cannot put them all in a public subnet, right? The other, because all the resources will have internet access, then you just want to provide internet access to certain resources. So in that case, you would need a public and a private subnet. Um, thank you, Vijay. Good evening. Interesting session. Good agenda. Yeah. So we'd also be making more upcoming AWS sessions and Azure sessions. So make sure you subscribe and stay with us. Uh, there is one more question from Exon. Can you please explain what is EC2 used for? Okay, so again, there is already a tutorial in our channel, Scalers channel. You can just go ahead and check it over there. But I'll just give you a brief. EC2 basically means Elastic Compute Cloud. That basically again means compute cloud. You can create a compute engine over the cloud. So you can create a server over the cloud, and that is provided by AWS. And why it is named as Elastic? That basically means you can increase or decrease the number of servers. You can manipulate the instance type. You can create it anytime you want. You can delete it anytime you want. And the name Elastic basically comes from, you can stretch it and also bring it back. So you can scale up or down. That basically means you can increase the number of servers if necessary and decrease the number of servers if not required. And then there's a question from Pratyush. Can you please help me? What is VPC? Is it a local network? Is it like a local network? Okay, so VPC, yes, it's pretty much like a local network, but in this case, it's more logical. A local network is also logical, but it's created within bounds, and only the resources within the local network can communicate with each other. But when you talk about VPC, it's over the cloud, and it's also a network, but it is more logically created network to isolate other resources from the resources within the VPC. I hope that answered your question, Pratyush. And there's one more question from Karthik. Can't we directly launch resources in VPC? Uh, like, mm, so yes, you can do that, but only if there are subnets available. If there are no subnets, you cannot directly launch things within the VPC. Yes, so that's, I hope that again makes sense. So I hope I have answered a few questions. So then let me start with the session once again, and then after some time I'll check if there are more questions and then answer them. Okay, I'll just keep it over here. Okay, done. So guys, first thing, we've created the VPC. Now we're going to create two subnets. Okay. Okay. Uh, Coming back. So now we are going to create two subnets within this particular VPC. So over here, you can see there are other options where you can edit the CIDR, you can edit the DNS host names. There are so many other options which you can use here. You can delete the VPC. You can just look at all the things which you can do with the VPC. Next, going to subnets. Okay. So now you can see these are all the subnets of the default VPC. It's written clearly, do not delete the default VPC subnets. Once again, just to tell you guys. Now let's create two subnets which we require for our VPC. Clicking on it, selecting the VPC, which is AWS Architecture Tutorial. Selected it. First one, I'm just going to name it as public subnet arc. Availability zone, you can select any availability zone. I'm going to go with US East 1A for this particular public subnet. And here, one more thing you will have to note down is the IP address, right, within the subnet. So the VPC, we provided a range of 10.0.0.0/60. So if I provide the same over here, sorry, first let me delete this. Yeah, so I'm providing the same CIDR block here. Let me, now this particular subnet which I created completely overlaps the entire VPC. So if I do that, I cannot create other subnets, right? Why is it not showing yet? Okay, let me go back and create again. Okay, so now again, tutorial public subnet arc. I'm going to give it 10.0.1 slash 10.0 slash 24. So why I'm providing 24 is that the first 24 bits cannot be changed. Okay, so that's why I'm providing 24, and this does not overlap with my complete VPC's IP address. So this is what I'm providing. Next, I want to create a private subnet. So the thing is, right now there is no so there is no difference between the public and the private subnet. So first we can just create subnets, and then we can make them into public or private according to the things we attach to them. If I attach the internet gateway to the public subnet, this subnet, it becomes a public subnet. If I attach the internet subnet to the private subnet which I'm creating, it will also become a public subnet because it's an internet gateway. It provides internet access. Private subnets should not have internet access, direct internet access. Okay. So here I'm going to choose it as US East 1B, and again here I'm going to provide it as 24. So now in this case I'm providing one here, right? One here and two here. That basically means these two subnets IP addresses won't overlap, and that won't be a problem for me. Okay. So if I provide it as one, so these two will overlap, and that would be a problem for me because two subnets cannot have the same type of IP addresses. Okay. So that's what you'll have to make sure. So now create the two subnets. Done. Again, you're just creating two subnets. They are not. So this is the problem. I created a subnet with this, right? I think it's not allowing me to create it. So now let's go back and delete it. It's over here. Yeah. So this is basically the problem. I created a subnet with the complete, how to say, the complete range. So now this particular subnet has 65,531 available IP addresses. So yeah, so that's basically the problem. Let me delete this first. Okay, yeah, so these are the default subnets. Let it be. So let me create it. Sorry for a small issue on pubs arc 10.0.0/24 adds new subnet, private subnet arc 1b 10.0.2/0/24 done. Create new subnets. So now I've created two subnets, guys. You can see both the subnets are available, and now let's see the IP address range. So now both of the IP addresses have an IP address range of 251, right? So it actually should be 256. Okay, so it actually should be that, but the problem here is that 5 IP addresses will always be reserved with AWS, so that won't be given. So the rest of the IP addresses are available. If I launch a resource within this particular IP, so sorry, within this particular subnet, it will have an IP address within this, and you can only launch 251 resources within this particular subnet. Same thing goes with this subnet, because only you have 251 available IP address slots. Okay. Um, all right. So we've created two subnets, guys. So right now there is no distinct. So it's not distinguished, right? Okay. For public and a private subnet. Okay. Public subnet, private subnet. We have created two subnets. The next thing, let us make the public subnet an actual public subnet. So for that, what we'll have to do, we'll have to create an internet gateway and attach it to the VPC. Okay. So that's what we are going to do right now. And let me see if there are any more questions. Yeah, currently there are no questions, so I'm just gonna continue. Okay, public subnet. Make it a public subnet. First, let's make the public subnet, and then let's talk about the private subnet. Okay. Yeah. So now, as I was talking about, we are going to make the public subnet an actual public subnet. Right now, there is nothing attached to it, so it doesn't have any particular problem. So there is this route table, right? So this route table would have got created with the VPC. So that's the route table which we are going to attach our internet gateway to. So you can see here, right? This particular route table. If I click on this, so you can see the VPC. This particular route table is connected to is the AWS architecture tutorial VPC. So if I connect an internet gateway to this, that will basically mean this particular what is this particular subnet, right? This particular subnet will become a public subnet. But again, this subnet also the private subnet also has this route table connected to it. So that will be a problem, right? Because even the private subnet will become a public subnet. So now let me go to route table. We can actually change the route table if we want to, so that doesn't that won't be a problem here. Okay, so now route tables, we'll talk about them later once we create the internet gateway. So it's pretty simple to create the internet gateway. So this is a default VPC one. Click on create internet gateway, provide the name. I'm going to provide it as architecture internet gateway, and create it. So internet gateway is created, done. Next, we'll have to attach it to a route table. So now one thing I want to say before we move on with attaching it to the route table is do not attach it to the route table which is the main route table, because whatever basically whatever route you create here should be common for both of them. Or you can basically see here there is an add gateway, there is an option for internet gateway, and you can add the route here. But one major problem would be that when you add an internet gateway, so this particular route table is connected to two subnets, right? So these two subnets, these are subnets without explicit associations. We can make them associated to it. So if you associate both of them, okay, But then what basically will happen is, so if you attach an internet gateway, both of those subnets will have internet access, and both of them will become public subnets. So once you basically attach the root to the internet gateway to this particular route table, you will have to make sure only the public subnet is associated with the route table, with this particular route table. Okay. Then for NAT gateway, we'll create another one. So let's not concentrate about that. Okay. So internet gateway is created. We'll have to edit the routes. Click on add route, and over here, and I'm going to click on internet gateway, searching for targets. No, nothing found. Okay. Let me go back. I'll attach it first of all. Clicking here, actions attached to VPC, AWS architecture tutorial attached to VPC. Done. Now let's go back to route table. Clicking on the route, routes, edit routes, add route, clicking on target, internet gateway, architecture internet gateway, select it, done. So then you can just provide anything you want over here, doesn't matter. And then you can click on save changes. So valid cider block, I'm just going to provide it as, let me do this, is equal to or more specific than one of this VPC cider blocks. This route can only an interface or an instance. Okay, let me make it this. Done. So now the internet gateway is attached. So the destination could be any destination, right? The target is the internet gateway. So now first thing you'll have to do is attach only the public subnet. Do not attach the private subnet because we do not want to provide internet access to the public private subnet. Okay. So now we've successfully created a public subnet. So private subnet is still a private subnet. Nothing. So there is no internet access to it. So okay. So we've actually created the VPC, guys. We've created the public subnet. We've created the private subnet. We made the public subnet into a public subnet by attaching the internet gateway to the route table and associating the public subnet to it. Okay, I hope it makes sense because the public subnet needs internet access. So only way to get internet access is via internet gateway, and only way the internet gateway can provide access to the public subnet is by attaching it to the VPC. So we attached it to the VPC and associated the public subnet to the route table, and that's it. So now we've created a private and a public subnet. So to make sure they are public and private subnets, we'll have to launch instances within them and check if they are actually private or public, right? So now let me open EC2 in another tab. Okay, let's launch two instances. One instance I want to launch within the public subnet. One instance I'm going to launch within the private subnet. And then let's see what are the differences between them. So launch instances. So again, guys, I'm not going to explain the instance launching steps because again, if you want to learn about it, you can just go ahead to the EC2 tutorial or the complete AWS tutorial, which is on our channel, and you can learn everything over there. So I'm just going to stick to the schedule here. This is done. I'm just going to like fast forward. And only thing I wanted to show you guys is selecting the VPC and subnet. So here I'm going to change the subnet to the, change the VPC to the VPC which I created just now. AWS architecture tutorial, and you can select public or private. So the first instance, let it be the private instance. Next, storage, let it be 8 GB. Tags, name, private instance. Now let me just say private arc. SSH is more than enough. You don't need anything else. Review and launch. So this keeper, I already have this, so I'm just going to use the same keeper. Launch instances. So we've launched the private instance, guys. Now let's go back and launch the public instance. Launch instance. Again, I'm going to launch an Ubuntu instance. Keeping everything the same. Only thing will change in this instance would be the subnet, which is the public subnet. Okay, selected it. Next, add storage. Same storage type. I don't want to change anything. And here in tag, I'm just going to name it as public art. Security group, let it be SSH only. I don't need anything else. I'll also provide one more rule to show you guys the difference. So I'm going to add HTTP. I'm going to use the same key pair which I already have and launch instances. Okay, so now I've launched two instances, guys. One is the private instance and one is the public instance. So the public instance will have a public IP and a private IP, and the private instance will have only a private IP. I think I've made a mistake here while launching this. Let me check. Yeah, so when I launched the public instance, I made one mistake. I don't want, I'm going to terminate it. I'm going to launch it again. I'm going to show you what mistake I made. Select this and everything is the same. I'm just going to forward through previous. So one thing which I wanted to show is, so when I'm changing this, right, to AWS architecture tutorial and making it public submit. So here you can see auto assign public IP is disabled. So you will have to enable it so that a public IP address is automatically assigned to the public instance. So make sure to do this. Do not do the same mistake which I did. I just didn't see it. That's why I just went through. So let it be. So now next, change network setting which may clear your security group configuration. Yes. Next, name public arc configure security group, HTTP, review and launch, same key pair, and launch instances. Okay, so now we've launched two instances. One is the private instance and the other is a public instance. So now the difference you can see, right? The private instance does not have a public IP address. And the public instance does have a public IP address. Okay, so this is the major difference which you see first, but there is one more difference. So let me click on this. Let me connect to the private instance. So you can connect it in two ways. You can connect it with an SSH client using a terminal, or you can connect it to EC2 Instance Connect. I'm just going to connect it with, so I'll just show you how to connect it with EC2. So one thing I'm going to show here is the instance does not have a public IP and you cannot connect to it, right? So even if I do this in my terminal, it won't connect to the instance because it's a private instance. Without a public IP address, you cannot directly connect to it. The only way I can connect to this particular instance, right, the private instance, which I just created. So the only way I can connect to the private instance is via the public instance which I created. Okay, so now let the public instance initialize. I hope it's running right now. It'll take a couple seconds. So once the public instance is running, I'm going to connect to it first and show you if the internet is working or not. So the internet will work only if it's connected to the internet gateway, and we've already connected to the internet gateway, so it should work. Okay, so now let's try connecting to it. Click on connect. So again, as I told you, there are two ways to connect. One is EC2. So there are many ways, but essentially the most popular ways is EC2 Instance Connect. I wouldn't suggest this, but I'm just showing you how to connect it. And then SSH client is the most preferred way. I'm going to connect it using SSH client in a couple seconds, but I just wanted to show you guys you can connect this way as well. And you can see this, right? Okay, so now the first thing I wanted to test is if internet access is available to my public instance. So to test that, I'm gonna update my instance. So if it updates, so now it's basically fetching all of this from the internet. That basically means it has internet access. So one more way you can check it is by pinging it. You can ping, let's say google.com, and it's able to fetch info, right? I want to stop it. Done. So it has internet access, guys. So let me just close this and let me connect it via SSH. So to connect it via SSH, I'm going to open my terminal. I'm going to make it bigger. Okay, so hope you guys can see this, but wait, I have not shared my terminal screen. So let me share my terminal screen. Okay, so I've shared my entire screen. I hope you guys can see my terminal screen right now. Let me just check if I could see it so that I would know that you guys can see it as well. No, the entire screen thing isn't working. So let me just do one thing. I'll just stop screen share. I'll just share it once again. Okay. So there is a question. Okay. Let me just check. Okay. So I was connecting to this instance, right? So so I can connect it to my SSH client, but the screen share with the terminal isn't working. I'm just gonna connect it here. I'm just gonna show it you guys over here as well. So first of all, internet access is available to my instance because I was able to update my instance, right? So again, this is the first thing you'll have to do with any instance you create, update it, and then next thing you can try installing something. So I'm gonna install sudo install unzip. Sorry, very sorry. You'll have to use the package manager, which is apt.get hyphen get or apt, just apt. See, the major problem with the browser is it'll be slower than using your terminal. So that's the problem which I didn't want to face. So that's why I was trying to basically use my terminal, but there is some issue. Last time when I did it worked. This time it isn't working. Okay, so now we've connected to the. Let me just try to make it bigger. Okay, so anyway, guys, I've connected to it. This is a private, public subnet. Internet is working, so you've successfully created a public subnet. Now coming to the next instance, private subnet. So as I told you, we cannot connect it to directly. So one way we can connect it using SSH. So how through SSH is using the SSH. So this particular tutorial key.pan. So that particular key should be within this particular uh, instance only, then it will connect. If I just copy and paste it, it will not connect. See, permission denied. But let me try this. Let me try to connect without it, and permission denied because it requires a key. There is a public key within my private instance. So until and unless I connect it through that, it will not work. So the key is in my local PC. So let me once again try. I'll just once again try to connect or share my screen, guys. Just give me 1 second. I'll once again try to share my entire screen. But once I share my entire screen, it's getting stuck. Yes, once I shared my entire screen, it's getting stuck. I'm sorry, there's some issue with the streaming platform. Just give me 1 second. Okay, I'm not gonna waste you guys time, so I'm just gonna use the browser itself. Okay, so now let's connect to the private subnet, private instance from our browser. So to do that, first of all, I actually need to connect my public instance. So basically, what is that? The private key, right? The private key is in my local PC. Tutorial.key file. tutorial.pem, tutorial key.pem. Let me search for it. Tutorial key.pem. Yes, so it's in my local PC, guys. So the first thing I actually have to copy it into this, but I cannot copy it like this. But if it's a different, what is it? If it's putty or anything, we can do it. So to do this, I need FileZilla. So I'm just gonna install FileZilla client pretty quickly. You guys also can learn how to install FileZilla client, but I'm gonna install it for not Windows. I need it for Mac. So I'm just gonna use the the free one, not the paid one. So FileZilla is basically, let me just delete it again, cancel it. So FileZilla, guys, it's a client, it's an SMTP client or an FTP client, you can say. It helps you transfer files to other servers. So that's what this particular tool is for. Okay. Okay, I'm opening FileZilla in my PC. You guys are not able to see it apart from this particular window. So that's the problem here. But I've downloaded it over here. You can see, right? I'm downloading it. I'm opening it, and I'm copying. I'm gonna copy it. So just give me 1 second, guys. Let me do all that. So the things you will need in order to copy it to your public instance, right? So you would need your public IP. So there would be an option called host. You'll have to put your public IP there. Username. This is an Ubuntu instance, so the username would be Ubuntu. If it's any other instance, the username would be EC2 user. Okay, Ubuntu. The password won't be anything because we are using a key pair, and port number would be 22. So these are the things you'll provide, and then there would be settings option. Yeah, so there would be a setting option where you can go and add the key file, which is the what is this p.pem file. Okay, so that's, you'll have to go ahead and add it. Guys, please hang on for a couple seconds. Uh, so type default. Sorry for making you guys wait. Just give me 1 second. I'm just trying to copy this. Um, so meanwhile, you guys can go ahead and check out the VPC tutorial. I'm talking about the same things. I was able to show the terminal in that particular session, but I'm not able to share it right now. I'm just gonna try it once again using StreamYard. If not, I'm just gonna go ahead and no, it's still getting stuck. I'm very sorry about it, guys. So I'm just gonna go ahead and share just my window. Okay, let this be. I'll just keep this window for you guys. Um, CD downloads. Where is my key file? The key file is over here. Um, Tutorials key. Username is Ubuntu. IP address is 34.201. Okay, one more thing I want to show you guys meanwhile, so that you guys won't be bored when I'm doing this. So I'm just going to connect to my public instance once again, and I'm going to launch a web server, and I'll paste the URL in the chat so that you guys can go ahead and check it out in your browser. Okay, so I'm just gonna install a web browser, uh, install Apache 2. So before I install it, if you guys basically, I'll just share this with you guys, right? So try to copy and paste this URL in your browser. So let me do that for you guys also. You can also try. So right now nothing will be shown because there is no web page or website running in my instance. But once I install it, once I install the server, it will be running. So I'm going to install it. Okay, I'm installing it. Please check it once again. So now, if I do this, once it's completely installed, so once it's completely installed, it's done. So now if I do it, there will be a web page running. So you guys can just copy this and check it if the web page is running or not. Please tell the use of AWS. I'm new to AWS, don't know about it. So basically AWS is called Amazon Web Services. It's basically a cloud computing provider. They provide you cloud services and yeah, so you can basically create infrastructures using it. You don't have to, yeah, so you don't have to create your own data center and then buy hardware and set up everything. You can just do the exact same thing in AWS. Yeah, I'm just trying again, still trying to copy my file. Just give me 1 second, guys. So that's why I showed you this part. So you guys just check it out. Okay, so I hope it's copied. I just copied it using my terminal. Let me go back to here. Let me do an ls, and yes, so the pem file which I wanted is copied, guys. Okay, that is successfully done. And I hope you guys tried copying and pasting the IP address in your browser to see if it's working or not. I hope you guys tried that. If you haven't tried, I'll do one more small modification. So this file is what is showing here, right? This file is what's showing here. Let me change it works into updated and refresh it, and you can again see the change. Okay, so I'm just going to open the index.html file and go down. So I want to change it works to updated, so that's what I'm checking. So Apache to Ubuntu default page, under that it works. So over here, okay, I'm going to change this into, it's the browser, that's why it's, sorry for that. Not able to connect to the instance. Is my internet a problem? So I was basically talking about this. I actually created the yeah. So I created a route table, and I associated the private subnet to the route table. So basically, what I did was I created a route table, this route table, and named it ArchNat route. And once I created it, I went to subnet associations, edit subnet association, and I associated the private subnet. Okay. Next thing, I created an ad gateway, arch nat gw, and attached it to the route tables root. Okay. Over here, root. So you can see, right? I've already attached it. So let me remove it first and save changes. Okay. So now I'm within my, okay. So now I'm within my public instance, guys. Public EC2 instance, because you can see the key file which I copied over here. Okay. And it has internet access. Let me ping google.com. Okay, so it has internet access, that's why it is able to fetch data. Okay, so now let me connect to my private instance. Okay, so now I'm in my private instance right now, because if I do an ls, there is nothing available. Okay, So right now, this particular route table does not have the NAT gateway. So what do you think will happen if I ping google.com? Will internet work or will it not work? So it shouldn't work. So you can see, right, it's not able to access the internet. So let me do one quick thing. Let me go back here, go to edit routes, change this and connect it to the NAT gateway and save changes. Now let me go back here and now you can see it's able to access the internet because I just gave the route table. I just gave the private instance access to NAT gateway, which in turn basically converted the IP address of the NAT gateway into a public IP and was able to fetch data from the internet. So this is basically what I wanted to show you guys today. This is basically what I wanted to show, and I hope I showed everything over here. But sorry for the slight inconveniences in between where the screen wasn't showing completely. Uh, Again, you can still paste this and see this particular website. I hosted it. Yeah, so sorry for those inconveniences, guys. But again, I hope this session was helpful for you. If you have any other questions, you can ask me, or we can end this session. I'm just gonna delete the resources. So while I'm deleting the resources, you can ask me questions if you have. So I'm gonna delete the instances first. Hey Vicky, welcome to the session. You can check out the session once the session ends also. It will be available in our channel. So don't worry about it. So I'm just trying to clean up because again, so if you're practicing, right, always try to clean up. Okay. So I'm trying to delete it. I don't think it'll directly delete it. Let me check. Yeah, because it won't be able to delete. I'll have to delete the other resources. So let me go to route table. No, let me first delete the internet gateway, which I created, detached from VPC. Okay, understood. Going to route table, deleting the route table. Oh my God. First, I'll have to remove this. Remove, save changes, subnet associations, edit, remove, save associations. Now, let me delete the route table. Done. Okay. So next, going to my main route table, subnet associations, edit, remove, save associations, routes, edit, remove, save changes. Now I can delete the internet gateway, detached from VPC. Okay. I think the instances are still getting deleted. That's the problem. Delete, it's deleting. Next, subnets, private and public subnet. Delete subnets. Delete VPC. Delete. I just deleted these resources. Let me check once again if they're completely deleted. It's deleting. This network interface is still available. I'm deleting the network interface. Delete. Okay, so the instances got deleted. So the this also got deleted. Done. Your VPC. Let me try once again. Unable to delete. So it's showing it doesn't exist, but here it's still showing up. I don't know why. See, it's still showing up. So there's some glitch. Let it go ahead. I'll just delete it later. So I hope other things you guys understood. If you have any questions, please put down. Let me just check. Okay, so I don't think there are any questions. And again, sorry for the mishaps. If you guys need another session on AWS architecture, because there were some confusions here and I was not able to share my terminal screen. So if you want, we can do another session 2 on AWS architecture. We can try to create another type of architecture. If you need it, please put down in the comment section that you wanted. If you want any other topics, again, please put down in the comment section that you need these topics, right? Okay. So guys, I think that's it for today's session. I hope you guys understood everything, which and I was able to convey all the necessary things. Yes, now I can delete it. Okay, so that's basically it, guys. So I'll just stop sharing my screen. Hey, Meenakshi, you can again go ahead. The session will be available on our channel. You can go ahead and learn it. Uh, so that's it, guys, pretty much. I just wanted to share you guys the architecture and show you guys basically how to what is that? Just give me one second. Yeah, so how to basically do this. That's all I wanted to share with you today. I wanted to show you how to completely create that architecture. Yeah, so I think we actually successfully did it, even though there were some mishaps in between. So I hope you guys also understood. Uh, so thank you so much. Meet you in another session. If you have any queries, leave it in the comment section. If you want us to provide new videos on certain topics, particular topics, put down in the comment section. We would be making them. So thank you so much. I'm going to end the live. So meet you in another live session. Okay. Thank you guys.